whip up my appetite. Don't leave me here high and dry. Oh, well, I don't wanna jinx it, baby, and twist myself at the spine. Don't wanna overthink it, baby. It's just twist your body and mine. Baby, you give me ice and fire. You're giving me wind and rain. You're some kind of butterfly. Baby, you give me midnight. You whip up my appetite. Don't leave me here high and dry. Oh, but I don't wanna jinx it, baby. Let's not get ahead of my time. Oh, but I don't wanna miss you, baby. So I stand up and speak my mind. Oh. Baby, you give me ice and fire. You're chilling wind and rain. You're some kind of butterfly. Baby, you give me midnight. You whip up my appetite. Don't leave me here high and dry. Baby, you give me ice and fire. You're channeling wind and rain. You're some kind of butterfly. Baby, you give me midnight. You whip up my appetite. Don't leave me here high and dry. Oh, oh, up my appetite. Don't leave me here high and dry. Baby, you give me ice and fire. You're channeling wind and rain. You're some kind of butterfly. Baby, you give me midnight. You whip up my appetite. Don't leave me here high and dry. Oh,
morning, BSides Las Vegas. Everybody seems kind of sleepy today, so I don't want to talk too loud. I see a few still shuffling in the back. But we're also at time here, so I don't want to take too long either. I have a couple of quick announcements for today. We've had some schedule changes. First off, the honey pot training over in Platinum today in the afternoon at 1500 hours has been canceled. We had an unfortunate travel complication for one of the speakers there, so we will back away from the microphone, which keeps ringing, so that one's going to be gone. And then we also have in the ground truth track 2 speakers who thankfully are not canceling, but did swap times. It's updated correctly in the schedule, but if you're going to the cognitive security and social engineering talk that with Matthew Canham and Dr. Ben Sawyer, that's now at 1400 hours. And Stephanie Lossi's system dynamics and risk management talk is now at 1500. So that's the business out of the way. Hope everybody's been having a great time. Today we have the hardest, or the smartest working man in InfoSec, Mr. Sunil Yu, who's here to talk to us about how, well, this whole generative AI thing kind of plays into the broad field of what we're doing, how we're thinking about what we're doing, and maybe, sort of our conceptions of what the core business of, guarding and utilizing our intellectual property within our organizations is, and a whole bunch of fun stuff like that. So we like to do some of these kind of broader think pieces here, and I'm really excited to see what he has to say about it. Put your hands together for Mr. Sunil Yu.
Thanks, Damon. Yeah, I don't know why I got that reputation as the smartest person. I keep telling Bryson and others they need to meet more people. But that said, I've had a chance to really do some really interesting things in my career. Currently, I left the CISO role, and it's kind of actually part of the story here too, the tale of 3 CISOs. But I'm now security ambassador at Jupiter One. I used to be the CISO there. I used to be the chief security scientist at Bank of America. And while I was there, I had a chance to create 2 things that hopefully you guys have heard about in some respect or another. If you were at the Chris Hoff's keynote last year, he actually mentioned these 2. He mentioned the Cyber Defense Matrix, which I brought copies of, and I'm more than happy to give them away. Please come and see me if you want to get a copy, as well as the DIE Triad. And I want to talk a little bit about those in context, but those are just 2 things that I'm generally known for. If I run out of books, there's a book signing that if you have one of those expensive business hall passes that you should really get for free, I'll do a book signing over there as well. All right. Now, as I mentioned, I don't really consider myself the smartest person in cybersecurity, and I certainly would not put myself in the category for anything associated with this newfangled technology. By the way, so I hate using buzzwords. I prefer to just call it newfangled technology, or NFT. And so if you hear me just call it that, just make sure you understand why I'm calling it NFT. So, okay, so in this newfangled technology, I think I've passed the peak of Mount Stupid, okay? But I'm not that much further, okay? And so I'm sure there's people who are way, way smarter than I am, way more competent than I am in this particular new space. But I try to think more deeply about what are the ramifications, what are the things that we can look at beyond the problem space that we might be facing. And to kind of go and look at what Josh talked about yesterday, he kind of gave that 10-year recap. So I'm looking forward 10 years. And that was kind of my role at Bank of America as the chief security scientist. I said, what kind of things should I be looking for 18 months out, 3 years out, so that we can be prepared to tackle some of the challenges that we might face. And so that's kind of the perspective I'm taking as well. But even though I said 10 years, maybe it might take 10 years, but I hope it's much sooner. And for us to be prepared to be able to take on the opportunities that come from this is what I would like to share here. So as we look at what's coming, it seems like we're in this dichotomous time where it seems like it's the best of times and the worst of times. And if you're in security, wow, it seems like we're in the worst of times. We have a lot of challenges with how employees use this technology, how developers are building these technologies, and how attackers are weaponizing them, okay? And each of those poses a real challenge for us, and three core problems that we run into. But I think I'm not going to spend too much time on that because I'm sure there's more than enough material on that, okay? And I'm not planning on sharing that piece as much, but I'll give you a little quick snapshot of that just so you understand the context of how I'm thinking about it. But the real question is, how do we make this the best of times? How do we take the opportunities that are presented before us and really capitalize that for our careers, for our industry, and what we can do going forward, okay? So what are those opportunities? And that's what I'm going to focus on primarily. Now, as I talk about these best of time opportunities, it's somewhat prognosticating, okay? As I mentioned, I hope that these will come to pass. And I've looked at this for a while to see the signs of it. And I would say, I think one of the things I would look for is key indicators that this is actually starting to happen. And I've already started to see some of these things happen. So we'll see if it turns out. But I hope it's not, as I predict the future for you, I hope it's not too highfalutin and too ivory tower. I think there's some real practical truths that we can take away from some of these things. All right, so first, let's talk about the worst of times and how employees use this newfangled technology. Well, first of all is that we have a lot of fear, uncertainty, and doubt. And as we have folks using these technologies, we have people saying, oh, wait, it seems like it's spewing out the same intellectual property that we just put in, okay? And I would say, no, you gotta understand that's not how it works, okay? That's not how LLM works. And the way I would characterize it is that LLMs generate, but they don't commemorate. They generate new information. They generate information, but they don't commemorate information that's already in the system, unless statistically it's highly prevalent. Caleb Sima actually gave a great example. If you type in, what is my social security number, and you give it the first 5 characters, it won't be able to figure out the remaining 5, even if it was trained on a whole bunch of social security information, okay? So this perspective that LLMs generate and not commemorate is one of the misconceptions, or at least people thinking that that it'll spit out a whole bunch of information about our intellectual property. And so we're seeing a bunch of things happen in the industry for this. I was going to put a bunch of logos of companies, but as you probably know, the curve for the number of companies being created on LLMs is like vertical. Okay, so it's hard to keep up. I said, you know what, it's not worth trying to capture that. But there are tons of those technologies, and I was also part of a group that helped produce a policy around how should we look at this as a concern, okay? However, that said, okay, I'm not going to hit that much because you guys I'm sure you're already well versed in a lot of that, where you can hear a lot of talks on it. But I think there's an opportunity for us to, again, change the role. So change how we look at our role and the opportunities that we have. So how can we elevate the CISO role in this new environment? And so let me give you an analogy. Consider what a CFO does. What is the CFO in charge of? They govern the wise and appropriate use of money. They allow businesses to essentially spend money to basically make more money, right? So that's the whole point of businesses, right? They don't actually make money too, by the way. They don't generate money. I guess they can do fundraising, but that's not really creating new money. And if a CFO said, you can't spend any money, you might as well fire them, right? They're not a really good CFO in that regard. But what if the opportunity is for us to become the CFO for intellectual property? So we have a bunch of intellectual property going out, and we have these concerns around them. But it's sort of like, what if again, it's a form of currency, and we spend currency to make better currency? So what's the role? Then we govern the wise and appropriate use of intellectual property. We allow them to spend this IP, And this IP, by the way, has different, I don't know if I want to put a dollar value to it. I'm really deep, well-versed in the cyber risk quantification space. And there's a whole bunch of stuff around that. But I don't want to get into that. Let's just talk about it in the context of, like, are we talking about low denomination bills or high denomination bills, okay? Are we talking like, if I went to a CFO and asked, hey, I want to spend $25 on something, they would come to me and say, what are you asking me for? I'm like, just go swipe your credit card and go on. What is a low denomination intellectual property for us? Might I suggest, for example, our source code is low value denomination bills, okay? Do I really need to ask for permission to transmit snippets of source code? Now, a lot of low denomination bills may add up to a high denomination bill, so to speak. And so we have to figure out what that sort of threshold is. But the perspective is we have a lot of intellectual property. And if I said, as a CISO, you cannot spend any of that intellectual property, well, guess what? You should probably fire me, right? And so what if we change our role, and the opportunity is for us to consider what it looks like to be a CFO for intellectual property. Now, with that comes actually some other interesting implications or interesting concepts. And with finance and accounting, it's a very mature practice, as you well know. And in that context, there is lots of different things that we can borrow from that as well, okay? And we don't have those tools here, but these practices are things that we can probably figure out how we can adapt them to security as well. And so I just pulled up a bunch of terms in generally accepted accounting practices. I'm going to call them security practices. And here's an example, impairment. Impairment is a financial term, okay? And I did some slight tweaking just to remove some of the finance-specific words. But if you read it, it sounds like what we can do in security. What is impairment? It's when some sort of resource is impaired, okay? It's designated as impaired when I can no longer have any sort of assurance that it can be fixed within a certain time frame, okay? Sound like something we deal with on a regular basis, right? Should we call it maybe impaired, okay, versus vulnerable or whatever else is? Yeah, maybe, okay? And guess what? When you have the term impairment, there's also all these calculations that come into how we think about like how you calculate impairment cost. Assets. We call them assets, right? It just seems natural. Except assets on a balance sheet is on the positive side of the ledger. But most of the assets that we deal in security are actually more liabilities, okay? Do we actually have it on the right side of the ledger? And maybe if we start representing it as a liability and not as a, quote, asset, all of a sudden the business will see it as, wait, why are we carrying these liabilities, not doing something about it? Maybe we should try to get rid of these liabilities, okay? So again, just slight wording change, but you can see how that helps as well. Survival metrics. So if you're in a startup or if you're any venture-funded company, there's a whole bunch of metrics that we rely upon to see how much time we have before we die as a company. So they're called survival metrics. What's your burn rate? What's your runway? What's your churn? And in the context of assets and how we look at, liabilities, I should say, in the way that we look at the resources that we have to be able to run a company, how does an impairment reduce our runway? How does an impairment increase churn? And I'm not talking about churn in customers. I'm talking about churn in other ways that we think about how these digital assets work as well. Later today, I have a talk on double entry accounting. So what is double entry accounting? It's a simple way to be able to have two ledgers, two different systems, provide a check against each other, okay? And I'll share some examples of that later today during a talk specifically on that. So I'm not going to spend too much more time on that. And then EBITDA, EBITDA. There's a whole bunch, the finance industry has been reshaped a lot because of the simple concept of EBITDA. And we can think about, like, what does it mean to have income in the context of cybersecurity? We know what the term technical debt means, right? But how do we translate that into how it offsets this notion of income and the value that's being created by these assets or these assets/liabilities that we have? See, even I still keep throwing myself off in these things. But that's it. The premise here is that we have a set of practices that we can now try to codify within how we do cybersecurity. And I think the reason why that is particularly important is because I've been fairly deeply concerned, and if you haven't been deeply concerned, you should be concerned about how the government is deciding some of these things for us, okay? And whether you agree or disagree with the Joe Sullivan's verdict, I could put myself in his shoes, and there are many cases where I would have probably done similar things as he would have done. Maybe a few things I wouldn't have done, but nonetheless, I can see how many of us can fall into the same traps that he did. And then Tim Brown, with the Wells notice that he got served, I mean, there's a standard of practice that they're assuming that we can't ever achieve, okay? So when we think about, for example, some of these practices, I'll talk about this in double entry accounting. How precise is accounting, okay? Or how accurate are the books? How much variance do CFOs allow? And guess what? They do allow some variance, okay? It's not a perfect, I mean, the ledgers don't always match, and yet they don't get sued. Well, if it's a huge variance, they might. But within acceptable amounts, they don't get sued, they don't get fined, they don't get these issues. And it seems like that's not the same for us in cybersecurity. And so we have an opportunity well, we have a couple opportunities. One is to redefine our role, not as a person that tries to secure, as a technical weenie that tries to secure all these little things, but rather in this sort of governance role of how we manage and govern intellectual property and the institutional knowledge of the organization. And we have these tools to help us. Well, we need to come up with these tools. And in doing so, we'll end up with ways that we can potentially provide guidance for the government and for us as a practice so that we can not deal with these in the future as well. All right, so that's the first best of times opportunity. How can we become the CFO for intellectual property? The second challenge that we deal with, the second problem, is developers building. And I'm sure pretty much every company out there is now using these newfangled technologies to try to do something with LLMs or generative AI. Here's a diagram that you can barely see because it's the wrong contrast that Andreessen Horowitz sent out. It's a reference architecture for how you build LLM applications. And don't worry about the detail at this point, but I do want to point out a couple things that in the context of what we've always learned in security, there are a couple inviolable rules, right? One, never get into a land war in Asia, but the one that's probably more important, or well, just slightly less known, but nonetheless important, is to never trust user input. And fundamentally, one of the issues with, one of the fundamental flaws with LLMs, potentially a fundamental flaws, is that we can't separate out the control plane from the data plane. All right, so we know that, I mean, this is like such a well-known principle in cybersecurity, and yet when I go back to that chart, that reference architecture, everywhere that I've highlighted in blue is user input, unsanitized user input, okay? And it's pretty much everywhere, right? So, okay, are we gonna, it seems like it's gonna be a pretty bad thing if we build against this reference architecture that doesn't necessarily capture this core principle of not trusting user input. So, how do we deal with this? Again, there's tons of things out there. I'm not gonna spend too much time on them, but just for reference, you have things like Berryville Institute of Machine Learning, their taxonomy attacks. I love this particular one because it's the most straightforward, structured way to think about attacks against machine learning. Of course, many of y'all have seen the OWASP top 10, and there's MITRE Atlas. So again, I'm not going to spend too much time on those things, but the perspective is that there's a lot of work that we're trying to do to address this problem, which is all these places where we have unsanitized user input and all these attack surfaces. But I think there's an opportunity. And to be able to explain that opportunity, let me talk about safety and security, something that actually Josh talks about often as well. And by the way, there's a vendor out there, Integrity, that's giving out this really big poster that says, safety first. And I love that because they're using the word safety. Now, if you're not sure why I think that matters, here's the thing. Okay, so if you know Spanish, then the word for safety is seguridad, and the word for security is securidad. So in Spanish, we have one word for the same thing, so for two different things. In English, we have two words. And in cybersecurity, we have the same word again. So why don't we, in English, why don't we call it something different? Because we have two different things that we do, one that's called cyber safety, and one that's called cybersecurity. And if you want to understand if you want to get a sense of what the distinction is, we can apply other contexts. So let's take food. So when we talk about food safety, what are we talking about? We're talking about things like hygiene, compliance, inspections, good practices, bill of materials, having a sense of personal responsibility. And when we talk about security, we're talking about things like starvation, or like where's the Ukrainian wheat or the baby formula. And when people talk about security, or rather compliance doesn't equal security, might it be because compliance is safety, and safety doesn't equal security, okay? Let me give you another example. So airplanes. If I'm an engineer at Boeing or at Airbus, my job is to ensure that the airplane stays up in the air, doesn't come crashing to the ground. Pretty simple, right? My job is not to dodge Russian and Chinese missiles. That is somebody else's job to make sure that the airspace is free or that we have airspace security, okay, which is to have the space free and clear of Chinese and Russian missiles. It's not my job, rather it's somebody else's job, usually the public sector, right? But the perspective here is that there's an activity that we do, that most of us actually do, that's actually safety oriented. Most of us do safety work, okay? And there are still some of y'all that do security work, but just be clear that we do cyber safety more than we do cyber security, okay? By the way, just real quick aside, 7 years ago, Equifax got hit by a Chinese missile, okay? 3 years ago, SolarWinds got hit by a Russian missile, all right? But that event 7 years ago, as time passes on, that Russian missile starts to look like a bird strike. And that bird strike now is something that I'm responsible for, okay? If I'm designing an aircraft, I need to make sure I can survive a bird strike. But I shouldn't be able to survive, there should be no expectations that I can survive a missile strike, at least for most organizations. If you're Apple and you manufacture iPhones, you're probably building the equivalent of F-16s, and you better be able to survive Russian missiles, because guess what? You're going to get those shot at you. But nonetheless, just the perspective of, over time, a Russian missile or a Chinese missile shot 7 years ago is going to start looking like a bird strike. And what does that bird strike look like now? Things like a software bill of materials, okay? SolarWinds got hit by a Russian missile 3 years ago. What's that going to look like 4 or 5 years from now? You better have your software supply chain really secure, because that's going to be a bird strike as well. So now, with this perspective of us focusing on safety, the opportunity for the CISO role is to think about us as the chief AI safety officer. So you think that cybersecurity is a problem today? Guess what? There's going to be a much, much bigger issue coming up, okay? And I think that it's going to cause all the things that we're dealing with in cybersecurity to pale in comparison. And if you're not sure as to why I'm saying this, then I would recommend 2 books for you all to read through. One is Life 3.0 by Max Tegmark, and then the other one's called Human Compatible by Stuart Russell, very well-known researchers in the AI space. But they give a perspective of what the future holds, where AI systems, the concern is not that AI systems are malevolent. The concerns are that the AI systems are competent, very competent. So competent that we ask it to do something, and it does it extraordinarily well, despite what may violate our own value system. So for example, I would say, I'm running late, take me to the airport as quickly as you can, and this autonomous car will take me to the airport as quickly as it possibly can. I might not survive, I may kill people on the way. Minimally, I may be very nauseated, okay? Which doesn't necessarily adhere to my value system. So how do we design these systems so that they're built safely and responsibly? So if you've heard all the things around responsible AI, or even I think what you heard earlier about the cognitive science aspect of things, this is all centered around this notion of AI safety. And who better to take on the role of a chief AI safety officer than somebody who's been doing digital safety for years and years. So I think that the opportunity for us going forward is to say, hey, you guys need an AI safety officer? That's us. We've been doing this for a long, long time. Now what does that mean to be an AI safety officer? There's a lot of principles that do apply in cybersecurity. And we've learned some of these principles as well. And I have a whole talk on this, but I'm just going to hit the highlights on this. But we've applied these different newfangled technologies in security as well, tied it with automation, and have resulted in us basically shooting ourselves in the foot many times over, okay? And so we want to take those lessons learned where we've violated principles of safety in some of these systems and say, okay, how can we apply this to AI systems as well? And so I offer like 6 principles that I put together that I used when I was at major financial institution to figure out how do we set these sort of guardrails for ourselves. As we build these systems, how do we ensure, for example, that we know exactly what sort of inputs that we're putting into it? How do we have an AI bill of materials? How do we have conditions that are not unbounded but very tightly bounded? How do I know, how can I ensure that ultimately we want to make the system as deterministic as possible. And to make it as deterministic as possible, we try to make things as bounded as possible. We want to have thresholds when we know we need to either take action or not take action. And by the way, the examples I used in this when I came up with these were things like, when do you block an IP address automatically? When do you have an orchestration system take action on your behalf? These are questions that I'm sure some of y'all are dealing with. And these are the kind of conditions that I put forth when I said, okay, we will fully automate this activity once an analytic system figures out what's going on, okay? And so these are sort of the guardrails that we came up with because we wanted to make sure that things didn't go out of control, okay? And so fundamentally, these are AI safety sort of principles, which you will learn just by using these technologies within the context of security. So anyway, other things like just making sure that you have, you understand the processes that are anticipated by the operators, having a kill switch. And by the way, on that kill switch piece, let me mention the book Human Compatible has a really great thesis on how to build in a kill switch for these systems. Definitely worth taking a closer look at. And then making sure that there's somebody who owns this, this system so that you have somebody who's accountable for making sure that it doesn't kill everybody. All right. Okay, so those are the guardrails. And then lastly, the third challenge is attackers weaponizing. So we're going to have a lot of different ways that attackers will weaponize. Some of these are pretty well known. You're going to see presumably more convincing phishing attacks. You'll see people perhaps generate, or the novices generate more malware. But for the most part, I think those are things that we've already been tackling those problems. And that's not too terribly new. However, I think in the context of what these technologies are going to offer is ways that that attackers can potentially accelerate their ability to find vulnerabilities within our systems, as well as novel ways to leverage things like deepfakes and so on and so forth. And so for these two new types of attack vectors that the attackers may use when they weaponize these technologies, I think we should think about what those may imply. And so let me talk about those two for a moment. The first two, again, just keep doing what you're doing. It's not going to make, I don't know how much more of a difference it's going to make, but that's it. I think the bottom two are ones that I would be a bit more concerned about. So with the bottom two, though, there is some opportunities here. And to be able to explain that opportunity, let me explain something called the DIKW pyramid. So DIKW stands for data, information, knowledge, wisdom. And the premise here is that each layer provides more value than the layer below. So, and I think for the most part, we are now into what I would call the knowledge economy. We've been at the data economy, we've been at the information economy, now we're at the knowledge economy. To give you a sense of how you can look at this, like data might be, let's say, websites. Information would be Google. ChatGPT is at the knowledge layer. Okay? And the premise here is that LLMs is opening up this new economy, the cognitive economy, the knowledge economy. And it will give us the ability to access institutional knowledge like we haven't had before, okay? To give you another sense of how to think about this, we've been wanting enterprise search for a long time, and it's failed because what we get back is a bunch of data and information, not actual institutional knowledge, right? We get back a bunch of documents that you're supposed to process. No, I want to get you to give me the answer. I don't want you to just give me a whole bunch of documents that I have to go read through. What LLMs have opened up is this knowledge economy. And with that perspective, I would offer a view that our understanding of how to build secure systems is already known. It's just not widely distributed. It's not evenly distributed. But what if there were a system that helped distribute this knowledge more uniformly? What if there were a mechanism by which we could have an engineer who had a business problem ask this engine, and it spews out the instructions for how to build this system? Now, the engineer will never, or rarely ask, how do I build this system securely, right? That's not really part of their equation. But we built that in as a part of the answer, okay? And by the way, the answer may not necessarily to build it more securely, but as I frame it down here, to have fewer security concerns, okay? Fewer security concerns. And the reason why I say that is because the DIE triad, if you're not familiar with that, it's a concept that I came up with called, that stands for distributed, immutable, ephemeral. And the idea is, if I build systems to be distributed, immutable, and ephemeral, it allows us to reduce the amount of security concerns I would have. So even if the system were vulnerable, even if the system were even compromised for that matter, my security burden is lowered, okay? How do I build systems to either be secure by default, or even better, to not require security at all? And that sort of design pattern is actually known. Some of it's not known, and some maybe narrow edge cases, but across the industry, we do know that. And guess where we share it? We share it in conferences like this, okay? We share it in KubeCon and CNCF and all these other places where people are sharing these design patterns. It's just not widely disseminated. It's not easily accessible. This knowledge sits in all these videos, and I have to go and pick them out myself. But what if there were a way to be able to tap that and pull that out? And so at this point, we have the mechanisms to build more secure or systems that don't require security at all. It's just a question of how do you assemble this together. And so this perspective of, that we saw earlier in terms of the issue with vulnerabilities, what if we're able to build systems that have fewer vulnerabilities to begin with? Or systems for which, even if it had a vulnerability, I didn't care. And then the second piece is around the deepfakes. And so for that, I have to explain yet another concept. So again, I mentioned the cyber defense matrix earlier. I'm sure folks are familiar with the, or heard about the CISA's zero trust maturity model. There's 5 pillars: identity, devices, networks, applications, and workloads and data. There's 5 asset classes in the cyber defense matrix: devices, apps, networks, data, and users. Now, if you wonder why there's 5 and why those asset classes align pretty closely, there's a reason behind that. But unfortunately, some of it gets slightly misinterpreted. So let me clarify some of the misinterpretation. First of all, identity is not just users, okay? That's how people typically think of it. They think of identity as being users, and if you look at the logo, that's a user, right? That's what CISA is conveying. So users and identity, as far as they're looking at it, are kind of synonymous, okay? But they're not. Why? Because all these asset classes have an identity. Devices have identity. Applications have identity. Networks have identity. Data has an identity, okay? And you're like, okay, well, I think I understand the first 3, but what does it mean to have a data identity? And by the way, before I go to answer that question, I should mention, so not all these asset classes have identity, not just users. I should mention, I thought it was kind of funny, back in 2016, I shared this briefing of like, where does governance and analytics and automation and orchestration go? And they pretty much put it under the same sort of view as well. So a lot of this was, I think, pretty much inspired by some of the work I did. But There's some just slight variations I wanted to correct. But that's it. Okay, let's go back to data identity. What is data identity, and why is that a problem? Well, let's go back to deep fakes. Think about deep fakes. Fundamentally, the deep fake issue is a data identity problem. Okay? We have a situation where we have content, data, and I don't have a way to authenticate whether it's, well, I don't have a way to determine if it's authentic, right? Now, we've had this problem before, okay? And it's the source of all the issues that we saw earlier with these lures, right? It's phishing, emails, right? And we've had this trouble with email for a long, long time because, well, it's an ecosystem problem, and we need an ecosystem, we need the will of all these organizations to say, we got to fix this problem. But email, it doesn't seem like we got the will to get that done, okay? There's been a lot of efforts to try to get email to be more authenticated, but it still sucks, and that's why we still have all these phishing emails and so on that are effective. But there's a bigger problem that's emerging, a much bigger problem, and it's one that is of societal concern, meaning there are people who care about this beyond this room, okay? People outside of the security community. And because it's a bigger, deeper concern, I believe that the will to fix it is going to be coming up, okay? So what would this look like? Perhaps it's a situation where the ecosystem says, hey, you know what? If you take a picture with a device that has a certificate on it, signed by a major manufacturer, then I can validate that this picture was taken by this piece of hardware and it's been unadulterated, okay? And you've seen already places where people have tagged it to say this is AI generated. But what I'm looking for is something that says, no, this is authentic, right? And I'm looking for authentic video. I'm looking for authentic photos. I'm looking for authentic audio. Now, if I solve that problem, what is email, right? I mean, that's trivial. Email is trivial compared to video, audio, images, okay? And if we can find a way to solve that problem, might we get rid of the bigger problem that we've had in security for such a long time? And so I think that's the perspective to look for in the future, which is, with the bottom one, you have fewer systems built with fewer security concerns, and then the bottom one being where even email becomes a trivial, we can solve the authenticated email problem, which really gets rid of some of the problems above as well. All right, so to wrap up, I think the best of times for number 3 is not elevating the role, but eliminating the role. How do we eliminate the role of the CISO? Because I think if we have a way to build systems with fewer security concerns, if we have a way to solve some of the thorniest problems that we've had in security, well, you know, my job as a CISO may not necessarily be as important anymore. And so I would love to have this role shrink. And what's interesting is Ryan McGeehan, he used to work at Netflix. He's an advisor to a lot of startups. And he states that there's a lot of security companies, there's a lot of new companies that don't even need a CISO because they've already built systems that don't require, that have a much lower, reduced risk profile. And that's partly because they build against the DIE triad that you saw before. But I think it's also because, again, they're building against better design patterns. And so I think the opportunity for us is to look at, so as our job goes away, we have other opportunities. And one is to become the CFO for intellectual property, and the other one is to be the chief AI safety officer. So with that, thank you very much. I'll take any questions.
Hello? Okay, great. We have time for questions.
Thank you for the talk.
One last thing, we're going to move this back away from that projector because it's got a bad leg, and if you touch it, it's going to fall over and go boom.
Thank you for the talk. I have a nuanced question in the spirit of deliberately feeding Rocco's basilisk. And your presentation seemed to focus primarily on the business user, the engineer, the technologist. But my question is really for you on this room. How do you change or amend these principles with the dark, sweet embrace from the security enterprise professional deliberately using LLM for the purposes of security? And when we're making decisions around information that's coming out of LLM for security purposes, how do we need to be thinking about building our own tools and our own practices for InfoSec, and not just thinking of that sort of us and them towards the user, towards the business aspect, and towards the developer and engineer?
Sure, great question. So let me answer it in two ways. First is the business alignment. You're spot on in terms of the way I'm characterizing the future role is highly business aligned. And that's been a flaw of how we thought about security for a long time, that we weren't business aligned. So the real goal, as I see it in the future, is for us to be highly business aligned. That said, we are here today, and we're dealing with, we're trying to leverage these technologies to deal with the present problems, the problems of the present. And so I did mention this as a way that we can think about how we leverage some of the technologies and what sort of safeguards we can put in. The other question, there was another facet to your question is, how are security teams using LLMs today? Okay, and I deliberately skipped that question because I spend time with startups, talking to startups about what they do, and I haven't run into a single one that isn't using LLM in some way to help address our security problem. So I deliberately skipped that question because I'm inundated by that. I don't know if you guys are, but nearly every startup I talk to has something associated with that. So if you want to get more specific details, I'm happy to share that because I have a lot of it in my head. I just didn't think it was worth spending time on here because really just go out to any vendor out there and they'll tell you.
Good to see you again.
Good seeing you.
There's an industry effort in the font industry, Monotype, Adobe, Microsoft, et cetera, around authenticity. And we're building a standard around it because it's a problem that needs to be solved for the benefit not only of just the font industry, but larger industries. I would encourage everybody in this room to research about standards emerging regarding authenticity and to start checking around the problem of how you validate authenticity independent of authentication. They are separate problems that require independent solutions. And authentication is a path towards validating authenticity, but not the only one. And I'm not just splitting hairs here. The differences of concepts matter. And solving the problem of authenticity is one of the biggest problems we have to solve in order for our profession to thrive, much like solving the issue of control or utility remain unsolved problems and undiscussed problems in our industry.
Yeah, I don't know if I can understand the semantic difference. I think I have some sense of the semantic difference between authenticity and authentication. So we can have a sideline discussion on that. I think fundamentally, what the premise I would still offer is that I would push forward the notion that we know how to solve the problem. We just haven't built up the will to solve the problem. Even if it's to say, you know what, we're just going to create a de facto standard to do this, right? And whether you're Apple or Microsoft or Google, they can do something that will drive that sort of adoption. Even if we ended up with 2 or 3 different ways to do it.
Yeah, and it's in the works. It is happening.
Thanks for your talk. So I'm more worried about veracity instead of authenticity. So I'm sure you're aware of the case lately where AI generated a legal brief, had 8 different case
Fake
laws
cases,
cited
yep.
that were fake cases that made them out of whole cloth. I've had conversations with it where it tries to convince me of stuff that I know personally didn't happen. What kind of guardrails do you envision around those kinds of things? Because I see us, it's like it wants to appease us, so it's going to give us the answers in the words that we want to hear.
Yeah.
But there's not any real good way for us to authenticate the veracity of it right now. Nobody's even thinking about that problem, I don't think. Are they?
So I have a model for that.
Oh, good.
It's called the DIKW pyramid. So LLMs are offered at the knowledge level, and what sits above it? Wisdom, right? And so I think there's and we don't have a machine that will go and apply that wisdom. So that's still up to us to apply that wisdom on top of whatever anyone shares with us, right? So I'm sharing to you knowledge. I expect you to take your wisdom engine and discern whether or not what I'm telling you is has the veracity that you're looking for, right? So that's something to consider. By the way, on the topic of hallucinations, there's a wonderful case that you should read about with this girl who was undergoing open brain surgery, and she was conscious at the time. The neurosurgeon zapped her brain. She started to laugh. This neurosurgeon asked, "Why'd you laugh?" We know the answer, but based on the sensory input that she was getting, her brain made a statistical guess as to what was the cause. And the cause was, oh, it's because of what you're wearing, or zap. It's because of the photo on the wall, or zap. Or it's because of something. In other words, her brain was hallucinating, statistically. Fascinating story. But anyway, all right.
How do you see organizations addressing data compliance with AI? Because not only are you dealing with the challenge now of users willingly giving up IP and information to public sources, thinking that they're helping the company, or not just fighting rogue actors that may be exfiltrating data. So how do you see companies thinking about this differently? Because currently it's still a fight to get people to maintain compliance and think about data compliance. Even industries that fall under SEC, FINRA, FDA, Part 11 stuff, those orgs really, they fight compliance on that as much as they can because they feel like it hinders operations in the business. So I'm just curious how you see AI changing that, or whether or not that's something you think is actually going to change, or if it's going to be the same fight with a new thing.
Yeah, it's fundamentally a different type of problem. So let me explain why. So data governance, information governance, knowledge governance, okay? Let's look at access controls. Data access controls, information access controls, knowledge access controls. Data access controls can be done at a very discrete level. You have access to this document, you have access to this database, this row, whatever, yes or no. Very binary. Now, information is more abstract. It's confidential. What do you mean by confidential? Like, what's the specific thing that's confidential, right? Or secret, or top secret, whatever. This perspective of abstracted data is where information operates. And what is information governance at that scale? It's a little bit more intangible, right? Then you have knowledge, which is even more abstract and intangible. And we've seen this already happen with LLMs that seemingly reproduce copyrighted material, right? By the way, we, in our conversations, reproduce copyrighted material all the time, and we don't cite the sources. It's called education, okay? And so how do we know what the sources are? I mean, we can't, actually, because it's from so many different pieces of data and information that gets assimilated into this notion of knowledge. So it's a whole different problem. And I don't think I can give you the answer because I don't know the answer, but I can pose the entirely different nature of the problem itself.
Thank you.
Separating the AI for a moment, your vision of a chief intellectual property, like CFO alternative is nice for trade secrets and intellectual property, but an entire new branch of officer is the chief product security officer for the things you put into the world. Or in OT and ICS environments, it's availability and cyber physical safety roles for a CISO. So have you put some of these models to product security and operational cyber physical system security, their futures and their evolutions, or is this a fork in the tree of a CISO?
The view that I would have is whatever you're building, if the understanding of how to build, for example, either a more secure or a system that doesn't require security at all, IT system, OT system, ICS system, whatever else it is, Again, I would postulate, and maybe you can tell me if I'm wrong, but that is known. It's a known quantity. Is that a fair statement?
It's less mature.
Well, I don't disagree, but somebody knows, oh, this is how you should build a system that is not just secure or doesn't require security at all, but rather also works with the business. It actually achieves the business goals, okay? How do we get that knowledge more widely disseminated? Write a book about it. Or have something that taps that understanding, right? And that's what I think the future holds. Now, that understanding has to be properly verified, that it's correct, okay? But nonetheless, we have a leg up now in being able to say, okay, here's a design that may actually be the better design.
Thank you, sir, for doing this. Huge fan. You know, one of the criticisms I've heard in both the professional world and the education world is that LLMs will give false answers. And my response is always, well, I get told the wrong thing every day, you know, without LLMs. Going back to your DIKW model, I'm curious, you know, one of the things that I've seen is where there's a masking of ignorance, where suddenly an analyst who wasn't super smart yesterday is suddenly an expert in his field. Where do you see organizations, like what are some safeties or guardrails or ways to expose where we might have these false flag experts who really don't truly understand the material, but because of this introduction of new knowledge and being able to basically have a tutor on demand, which I'm all for, by the way, but you know, this kind of hiding of ignorance and subterfuge of expertism, if that makes sense.
Yeah, and I don't know where the solution's going to emerge.
Sure.
Perhaps it's sort of like if I want to teach my kids well, then am I going to fill them with a whole bunch? Will I give them access to the internet and YouTube and say go learn from there, or will I have a curated set of content that I know to be true, right? That this is verified by scientists, by people who've actually you know, and there may be disagreement, right? I'm not saying that there's a disagreement in some things, but the perspective of, you know, this is foundational knowledge that everyone should have, okay? Train up on that, right? And that's what we would that's what we kind of need to do. It goes back to an earlier point I made around the sources, right? So if we want to have, like this AI bill of materials is something that we're actually trying to figure out, like how do we establish that? Because I don't want that to include poison.
Sure. Wonderful. Thank you.
So anyway, hopefully that answers your question. I don't know how we purge it yet, but that's the premise.
I'm here to thank you for your talk and say it's time to move on to the next one.
All right, cool.
Good morning and welcome to BSides Las Vegas Breaking Ground. This talk, Wolves in Windows Clothing, Weaponizing Trusted Services for Stealthy Malware, is being given by Michael. A few announcements before we begin. Sponsors, we'd like to thank our sponsors, especially our diamond sponsor, Adobe, and our gold sponsors, Prisma Cloud, SemGrep, Blue Cat, and Toyota. It's their support, along with other sponsors, donors, and volunteers that make this event possible. These talks are being streamed live, and as a courtesy to our speakers and audience, we ask that you check to make sure your cell phones are set to silent. If you have a question, use the audience microphone so that YouTube can hear you. It's located right up here at front. As a reminder, the BSides Las Vegas photo policy prohibits taking pictures without the explicit permission of everyone in the frame. These talks are being recorded and will be available on YouTube and in the future. With that, let's get started.
Hi everyone, my name is Michael Barguri, and this talk is gonna be interesting because let me kind of share briefly what we're gonna do. We're gonna show you how you can take trusted executables that are baked into Windows, service accounts that are baked into Windows, and services that are part of the Office cloud to operate your own malware. All right? So that's the premise. Let's see how it goes. So briefly about me, I've been kind of focused on this area of, you'll see in a moment, but no-code, low-code, and the kind of things that business users are building for a long time now. And I've founded a company that's focused on this area. If you're interested, if you're looking for something interesting to do, reach out to me afterwards. There's plenty of research we put out there. So please check us out. All right. So what I'm going to do in this talk is to try and get from initial access to a full operational malware op. Now, one thing so two things are important to note here from the get-go. One is that I assume initial access. Okay, that's the start point. I have access. I have the ability to run code on somebody's Windows machine. And then I want to create a malware operation on top of it, and let's just try to make sure we all understand, we're on the same page of what do I mean by that. So you have initial access to a victim machine, which is great, right? You're like, you won, right? So actually, no, there are a few things in the real world that would stop you from actually doing anything with it, right? This might be behind a firewall with an EDR. In a corporate environment, things are difficult. So you have initial access. You need to be able to actually run malware on that machine, right? You need to be able to do command and control through network perimeters. You need to be able to exfiltrate data back. You need to avoid defenses while you're doing all of that. And you need to persist in case somebody tries to boot you off the machine. And so there are plenty of things that you still need to do after initial access. And when you think about this list of things, these are mostly grunt work, right? This is not hacking. This is mostly engineering. There's a lot of operation involved, which is great. But as hackers, we want to focus on what we care about. We care about hacking. So all of this thing right now, we want somebody else to take care of this for us. Now, in today's world, there's pretty much a SaaS for everything, right? So what if we had a SaaS that would solve this thing for us? That wouldn't be nice. That would be probably pretty good. Let me introduce you to RPA, Robotic Process Automation. I'm not sure how many of you have heard of this, but this is a technology that's meant to help business users automate their processes or help people automate processes. And the way it works, it has three separate components. There's an agent running on people's machines, laptops, workstations as well. There's a controller, so something that can reach out through the network to your machine and run something there. And there's a cloud endpoint that allows you to manage all of that. Now, the crucial thing about RPA is that it's trusted. All of these things are trusted. And what do I mean by trusted? I mean that your EDR will already have inclusion rules for all of these services, right? So it would ignore everything here. Which is pretty great. So RPA is what we're going to use here because it seems like this is the service we want, right? It's like a remote code execution as a service, which is awesome. This is what we're going to use. And so one thing that's important to note is that RPA is really anywhere. I put here like the main RPA vendors. that are out there. But in any major enterprise, you'll find at least one of them. And I'm going to pick on Microsoft in this talk, because, I mean, why not? It's kind of the thing that we're doing. But this is actually a problem with RPA as a whole. Like with this type of thing, you'll see in a moment why I focus specifically on Microsoft. And so RPA is going to take care of everything for us. So everything we wanted earlier, command and control, exfiltration, avoiding defenses, persistency, cleanup. But it's also going to do a whole bunch of more things. Because when you build malware, you need to think about the different OSs that you want to support. You need to be able to handle errors. You need to be able to do retries, updates. All of these things are taken care of for us, which is nice, right? It's really like built for our purposes. So this is what we're going to, how RPA is going to help us. And so just a kind of a quick understanding of what RPA is. The idea is to replace the copy-paste integration that business users are doing. So like if you want to move a file from one place to another, people have been doing that for ages. We've been trying to tackle it with DLP and all sorts of solutions that didn't really kind of solve the problem. This is an attempt to automate that process. And the key feature about RPA is that it works as the user, on the same session as the user. So it impersonates the user by design. It means that it can operate in tandem with the user. So the user is interacting with things on their computer, and in the same time, the bot is interacting with those same things, with those same credentials, same permissions. Everything is the same, right? So it's very difficult to distinguish what an RPA agent does on a user's behalf and what a user does. All right. And it can run on users' machines. It can also run on dedicated servers to do some more heavy lifting, because people are also using RPA for heavy enterprise processes. And use cases, I mean, there are many of them, like onboarding and offboarding, financial management and reporting. There are plenty of use cases for automation. This specific automation, again, is the number one thing about it is because it emulates the user, it's able to integrate with things that don't have a proper API. So if you have a legacy system that doesn't speak to anything else, like, I don't know, a healthcare system that people are plugging in data from that system to some other systems, so RPA could help you there. But again, it also means that you're operating as the user inside of the user context. And so here's what we're going to do today. We're going to start, we just covered the motivation, like what are we actually going to achieve here. We also talked about I'm going to kind of briefly show you an example of what RPA is, so we all make sure we're on the same page. And then we're going to do a technical deep dive to understand how we can exploit this. We're going to see how we can take RPA and turn it into RCE as a service. I'm going to introduce you to a tool that will do all of that for you. And of course, we'll finish with defense and understanding how do we protect ourselves from this thing. Because of course, this is the goal here. So just as a quick example to make sure we're all on the same page on what RPA is. When I was a teenager, I used to play in a game called Tibia. I'm not sure if there are any Tibia fans here. I'm not finding a lot of those, but I spent like the majority of my teenhood playing this game. And what you're doing there is actually, it's like an early MMORPG, right? But the vast majority of the time, you're not doing what you want to do, which is kind of go on quests and play with your friends. You need to do grunt work in order to level up. And in this particular case, you do fishing. So fishing means you go to a pond and you click on a worm, and then you click on the sea, and then you click and you get some fish, and you click and you get some fish, and you click and you get some fish, and it's terrible, right? You spend hours doing this thing, and so I really wanted to automate this thing because it was too much, and so this is kind of the equation that you're going through. So I wanted to do something better, and then I came up with a very good idea: physical automation. So. And this is an illustration, but I couldn't find the real picture. This is really what I used to do. I used to go to sleep with like heavy things on my keyboard and mouse, and when you wake up in the morning, one of two things happened. Either you leveled up, or somebody killed your character, and you're not in a good state. Of course, this doesn't hold because this is very basic, right? You can only click things. So the next level up after you do this thing is to use some sort of a program that records your screen, records what you're actually doing, and then replays it. And the cool thing about this thing is that you can also share it with other people. So this kind of made me popular for a second there, because I could share it with my friends that could also fish automatically at night. And then you can see what this thing is actually doing. So I'm recording an entire session of me like fishing around, and then this thing will replay it overnight. Okay, so this is a funny example, but this is actually what RPA is. And now, like, I don't know, 20 years later, we are using this kind of technology to solve enterprise problems. All right. So now that we understand what RPA is and we have an example in mind, which is very relevant to the enterprise setting, we are going to look into RPA and how RPA works. Because if you don't understand that, then you won't understand how am I achieving what we're going to see in a moment. So I'm going to focus on Microsoft, and this is the reason. Every Windows 11 machine has an RPA agent built in to Windows right now. So open up your laptop, you'll find this agent. Look for Power Automate. It's already there. And so this is the reason why Microsoft is definitely the thing to focus on. And so let's try and look at how this looks like. So when you open a brand new Windows 11 machine, you'll find this screen. And then let me show you, hopefully. All right. Yeah, so we don't need the videos, but basically, when you log into this, let's do it here. So when you find this Power Automate agent on your machine, the next thing that this will pop up is like a sign-in screen. And that sign-in screen allows you, it asks you for an Office user account, whatever account you have. This could be your personal account, this could be your corporate account, whatever you have, right? And once you do that, this agent will start syncing with the relevant Azure tenant. So it could be, again, your personal, like a personal account, and then it's the shared tenant, or it could be a corporate tenant. And it's going to fetch all of the different automation that you've already set up on the cloud side, and then you can just pick them up and use them. And so, sorry. All right, and so once you do that, this is the screen that you're seeing after you log in. And you can see a whole bunch of, so in this case, those are payloads because I've pre-prepared this, but this could be just like regular automations. And you can see on the upper side, that this goes to an environment that's something called Pontoso. Pontoso is actually just the malicious tenant that I've created, all right? And so this thing is synced with the cloud. Again, this is my Windows machine talking to Office. And so we need to understand how this thing actually works, because recall that Microsoft has put this inside of Windows 11. They didn't ask any network admin team in the world to open up different ports, right? So something is going on here that allows the Windows machine to communicate with Office in whatever setting you might be in. And so on the left side, on the machine side, Power Automate is actually comprised of multiple different executables. The first executable that you saw, that you'll see for the sign up is Power Automate. It communicates with something called machine runtime, which is actually a service that's going to go up to the cloud and pull payloads that it needs to run. And this is running on a service account. You can see the service account there. Okay, that is automatically being created on your machine. Power Automate also allows you to run a bunch of automations on the browser. So again, by default, you can install a plugin on your browser that takes full control over your browser. In Edge, this would be automatically deployed in some cases. In other browsers, you need to install it. And then it would allow you to do, like, it would allow Power Automate to operate on your behalf on the browser. So in order to do this, there are specific executables that communicate with each one of those. Now, if you're looking for a place to do some research, I really recommend this. I've just described like 3 executables out of this entire thing. All of this thing is already in your Windows machine, and the attack surface is huge, and not a lot of people are looking at it. So if you're looking for easy pickings, I really recommend this. But all right, this is the machine side. Now let's try to figure out how does Power Automate, how does the RPA agent work with Office? How does it work through this corporate boundary? So the way that it works is actually with a neat piece of software that's called Azure Service Bus or Azure Relay. Basically, both sides are creating outbound connections, and then there's no inbound connection to your network. There's outbound connections from the Windows machine through your firewall or whatever to pull on this queue. Now, most people are not blocking outbound connections, especially not to Microsoft services, right? And so this is the way that it operates. So this is basically a message box where people can leave messages, where Office can leave messages for your machine to execute, all right? And so once you sign in, then on the Office side, this is what you see. This is basically a way to, so you're seeing all of the machines that I've infected. You can see their versions. You can see the ones that are connected or disconnected. You can see how many automations are running on those machines. And you can actually go further, and you can execute things from the cloud to the machine through this mechanism of queuing. You can also look at each individual task that you've scheduled through the cloud and see what exactly happened, like full logs, and if something was failed, you can rerun it. So everything is handled for you. And so this is pretty much what we needed, right? And so now I'm going to show, now that you understand how this works, I'm just going to show you how, what we can do with it as hackers. So from now on, we are wearing the hacker hat, and we're not describing the service anymore, but we're describing how we're going to use it, all right? So this is my wish list, and let me go through the wish list one by one. So first of all, deploying the malware. To start this thing, what we need is a malicious Microsoft tenant. This is pretty easy to get, right? So I've created something here called Pontoso, which is kind of I don't know, a nice reference for Microsoft. And you can create this tenant free, no credit card needed. Then once you do that, you go to Power Automate. It will tell you, hey, you need to introduce new machines. And so in order to introduce new machines, well, you didn't see that because the video didn't work. But what you're seeing right here is the sign-in screen that people need to log in through when they first go to Power Automate. And so what we really need is to use our account, not this account here. This needs to be our hacker account, because this is the moment where we register a user's machine to our tenant, rather to their own home tenant. Once we do that, the machine is onboarded to our malicious tenant. We're a global admin. We can do whatever we want, right? So we can also run things on their machine. And so this is the crucial piece. Now, you can do this with UI, but well, as a hacker, that wouldn't really help us. And so we need a way to circumvent this thing, this registration form. And so the question is, can we avoid that? And the answer is that, of course. So Microsoft actually has like an existing executable there called machine registration.silent, which is awesome. And then you can use this nice little script to register the machine to your own tenant. And you can see that this is the command that I'm using here, right here. All right? So it's like a one-liner, very quick. And this machine is now registered to my tenant. And by silent, it means that this machine, nothing will pop up on the machine side. Right? If you go to Power Automate and you try to log in, you wouldn't see that it's already registered. Right? You can check registry keys. We'll go into that later in this talk. All right? Now, this is great, but if your eyesight is especially good, then you have picked up, you know what? You have picked up on this little thing right here, which is that I'm running this as an admin, which is like I don't know. It's not good, right? If this is only something that requires admin access to the machine, then this would be terrible. And so we really wanted to find a way to circumvent this protection and to run this as a user. So we did a very sophisticated thing. We just tried, and it actually worked. So why not? So it works. And by the way, once you do that, of course, the machine is now registered here to your malicious tenant. So you can go to your malicious tenant. You can view the machine. Specifically, this is Windows 11, which I just infected, and it's connected, and you can see the version of the agent and so on, which is kind of nice. So I just showed you how to infect a machine. That's it. That's what you need to do. again, when you run this command line right here, no EDR will stop you, because this is something that enterprises are already doing. I mean, it's something that they need to do. And so, all right, in order to trigger this thing from the cloud, then I need to do a couple of things. First of all, I choose that I'm going to run this automation on some sort of machine. I need to specify the specific machine and credentials for that machine. I can run this with any user on your local machine, right? Not just a single user. By the way, this opens up another threat vector, because think about a machine that just gets a stream of payloads with usernames and passwords on top of them, but that's a topic for another talk. And then I need to choose a payload. And these are the payloads that I already submitted to my cloud, all right? And now, one thing that I need to figure out is what happens if a user is working on the machine. So if somebody's already working on the machine and I'm going to run some sort of payload, is it going to conflict with them or not? So how do I manage that? And if somebody is not logged into the machine, will it still work? So the good thing about this is that RPA has already solved this problem for us. That's why we're using SAS, right? So you have two versions of RPA, attended and unattended, which basically means whether you are sharing a session with the user or not. If the user already has a session that they're working on their machine, then you just join their session. This is called attended RPA. But if the user doesn't have a machine, they're not logged in, doesn't have a session, they're not logged in, so you can just create a session, do whatever you want, and then discard that session, all right? So both of these things work out of the box. And so we've seen, I didn't do anything until now, really. This was just creative reading of docs. But what you have already seen is that I can deploy malware. Defense evasion is kind of obvious, right? Because, well, it's all signed by Microsoft. And persistency is also obvious because Microsoft is treating this for us, right? Microsoft is creating this mechanism. It needs to be able to still be there once you boot and everything. And so this is all taken care for us by RPA. And so now we're going to have some fun, because we've reached that point where we can start looking at what we can do with this. So let's start by data exfiltration. What you're seeing here on the left side is actually the way that the RPA, the way that you create tasks on RPA. You can see this is kind of a drag and drop interface. There's a whole bunch of actions here, and this is the thing that I'm actually doing. And you can see that this data exfiltration payload is pretty simple. I'm getting as an input a specific file that I'd like to get, and then as an output, I'll get the content of that file, right? And this is just there's an error block here, some engineering, but other than that, it's pretty simple. And on the cloud side, so again, the input is give me this specific file with the secrets, and this file is now, and the content is being shared through the cloud. So again, just to make sure that we understand what's going on here, because I just did the data exfiltration from a Windows machine to my own malicious cloud, and we need to figure out whether you would have found this on the network or on any perimeter that you have or any logs that you have. So let me convince you that you would not. Remember this screen that we showed earlier, this architecture? The way that this works is that the instructions are being written to Office, again, to my malicious Office tenant. And then the payload goes through this trusted communication channel. And the exfiltration, the output, goes through that channel as well. All right? So you wouldn't find this machine going out to a random IP somewhere to dump data. No, this is all in trusted communication with Microsoft, with an Office account. That would be pretty difficult to pin down. All right. So the next thing I wanna get to is code execution, like full-on code execution. All right. And in order to do that, again, RPA treats this already for us, so I'm not sure if you can actually see, but the RPA agent has built in a way for you to spin up scripts on the machine. Then you can use whatever you'd like. You can use Python, JavaScript, command line, PowerShell. These are all available for you. And so this is an RPA payload that takes as an input the type of command that you'd like to run, so which interpreter am I using, and then the actual script. And it will run it for you and give you back the output and the errors. And so this thing is actually pretty cool, so let's try to run it. But when I try to run it, I get this little pop-up that we really didn't want to have happening. And so this is, I identify, I've used this to run Mimikatz through a command line. And so of course, this is finding us, right? We are being flagged. Why we are being flagged? Because, well, the RPA agent is trusted. But when you run a command line that is trying to run Mimikatz, I mean, you will get caught, right? And so we are in a kind of a pickle because we want to have full code execution. But when if we start a script from the Power Automate agent, then this script would definitely get caught. Would definitely be like the place where EDRs are looking for. So how do we circumvent that? Well, notice that this thing is already implements some sort of some level of like programming, right? This has an if statement. It handles errors. There are some things that we can do with no code, just inside of the RPA agent. And so the next thing you need to ask yourself is how sophisticated can we get only using no code, like only using this drag and drop interface without using any scripts at all. And so this is this is what we're trying to find out right now. And the answer is that we can do a whole bunch more, a whole lot. So this is the list of actions that are available for you. You can do things like you can change registry keys. You can work with Windows processes. You can read and write files. You can set up an HTTP call. You can encrypt files with a handy encryption function right here, which is kind of nice if you want to like play around with it. So you can do basically everything. And actually, since I've created this slide, Microsoft also introduced actions that do things on the cloud side. So you can do things on Azure Active Directory, Microsoft Graph, SharePoint, all of those kind of the Microsoft 365 suite, which is kind of awesome. So actually, we can do a whole bunch more, a whole lot more with this thing. And so we can stay with no-code primitives, and we can achieve things that usually would take like heavy scripting. And so let me show you a couple of examples. The first one, no-code ransomware. I mean, it's very easy, right? I get it as an input like a file, like a root file, and then I'm iterating through all of the directories recursively. And then for each file, I'm going to use the encryption function provided by Microsoft, and then just encrypt it and dump the encrypted file on top of the original file, right? And this just works, and this is all within the Microsoft executable, right? All right, and just as outputs here, I'm taking a few things like how many files was I able to encrypt, and like statistics because well we need to know that. Another example. All right, I think this will not work. Yeah, this will not work. But what I wanted to, but this is a like very brief demo where I basically showed that this thing you can run it from the cloud, right? But if you want to check it out, like there's a link here. It's already up on YouTube. But basically, the thing here is that while you build this, while this thing will run on somebody's machine, you can very easily, as you've seen earlier in the slides, you can run this through the cloud, and you get all of the telemetry back to your cloud. All right? OK. What you can also do is clean up, because like one thing that this agent does is generate a whole bunch of logs. Because this is something that is supposed to be used by an enterprise. So if you go to the relevant temp folders, you'll find a whole bunch of logs on what this agent actually does. So how do we make sure that nobody catches us? We just use the agent to delete all of those files. Why not? I mean, it's a documentation. We know exactly where those are. All right, so no code cleanup. Again, I'm just iterating through those folders with the logs that I know where they are because it's in the docs, and then I'll just delete the logs. All right. So one other thing that we can do, because we talked about the browser side, and the thing is that if you have this RPA agent that installed on your browser as well, then I can basically steal any token that you have on your cached on your browser, right? Because again, I'm impersonating the user, and so again, I think I have this in a YouTube video, so I don't think you'll be able to see it. But what I've actually done here is just like created a very simple script that opens up the browser and then goes specifically to Power Automate, like the Office Cloud version, and just steals the user's token. Because, I mean, why not? It's very easy. And the crucial thing here is that you can open the browser in a minimized version. Because, again, the RPA is built by Microsoft and by others as a way for you to run things on users' machines in the enterprise. You don't want to disturb those users, right? You don't want them to have a browser pop up and something automatically happening. So we can use the same mechanisms for our purposes as well, right? And so this is what you'll see here if you go to this link. All right. And so as a quick recap, what we've done so far, we were able to go through the entire checklist of the things that we wanted to do. So we deployed malware with a trusted service. Like defense evasion and persistency were kind of obvious. We did command and control, exfiltration, cleanup. You also saw a specific ransomware payload, but you can actually play around with this and do a whole bunch more. So I really encourage you to do that. I'll show you how in a moment. And we also saw credential access through the browser, or rather, I talked about it. And so if you want to play around with this yourself, so here's a tool. This tool will allow you to do everything that we just saw in this talk. Like all of the payloads are already included there. The infection script is already there. You'll also find links and more details that I'm going to share in a few moments on how to protect yourself. So this is all there. This is actually a second version of this tool. I gave an earlier version of this talk at DEF CON last year. And so this is the second version of this tool, where we go through a whole bunch more than just ransomware. There's a backdoor, there's phishing, there's internal phishing. There's a way to dump data with guest access. I just gave a talk about this yesterday. So check this out. This is a whole tool set around the no-code, low-code capabilities that Microsoft has built into Office. What PowerPoint is going to do for you is automate everything that we've seen up until now, but for us as security folks, so we can work with this without UI and like drag it and drop it, right? We want command line. And so the way that I'm generating a command line here is that I'm actually creating an automation on the cloud side that is triggered by an HTTP request. And then I have error handling all figured out for you. And then it's going to execute the payload on somebody's machine. And there's one endpoint that controls a whole bunch of payloads. So any payload that you saw here in this talk is available through the tool. And then what you actually need to do is just do a post request to the endpoint that's generated here by Microsoft on your own tenant, right? This is also available through a nice little CLI with PowerPoint. So check it out. It's kind of cool. All right. So we figured out how to use RPA. We figured out we saw what RPA is, and we saw what we can actually do with it. Do with this. The next thing I want to, I think it's important to discuss is like the communication with Microsoft about this thing. And so let me show you what has happened so far. So this was actually first found in last year. So when I gave a talk about this at DEF CON, and Microsoft pretty much said, yeah, this is a non-issue. Like everything here is like it's. I think the exact quote was that this requires social engineering in order to work, which it does not, but all right. And so that's where we were last year. Since then, Microsoft actually issued a fix, and we're going to discuss this fix in a moment. But the fix was issued for specific versions. So this is something that is on your machines, so you need to update in order to get that fix. We don't have a CVE for that. They did acknowledge at the end, like just a couple of weeks ago, that this is related to our research. But there's still no CVE for it, right? So what's the actual fix here? What actually happens is that the crucial piece is that I was able to register this RPA agent to my own tenant, rather than the home tenant of the user, right? So in an enterprise setting, the user is already logged in. The machine is probably AD joined, or at least AAD joined. And so the machine needs to know that there's already a tenant for that machine, right? And so by default, if you use a secure version of Power Automate Desktop, they have made it so that you cannot register the agent to another tenant if you already logged in with a tenant. But there are a few crucial things that are missing here. One is that there's no CVE, and earlier versions of Power Automate desktop are still vulnerable. So you still probably have business users that have this older agent that could still be owned. The other thing is that, well, the default is secured, but you can definitely move to an insecure default, and there are actually reasons to do it. Most enterprises don't have one tenant ID. They have lots of them. And once you have lots of tenant IDs, then you need to switch off one of these secure flags, which would allow an attacker to use that as well. And so any machine that's not AAD joined is still in a problem, is still vulnerable. And this is probably not an enterprise setting, but well, who cares about consumers? We have insecure configuration that would catch you, and we have the older version of Power Automate Desktop. Again, no CVE, so you need to manually make sure that people are updating their agents. All right, so this is the work that we've done with Microsoft. Actually, like I'm joking about them, but in the last few weeks they were kind of nicer. So we're getting along good now. And so let's like a very quick recap of what we've seen so far. We saw what RPA is. We mentioned that it's available on every major enterprise right now. We did a technical deep dive into RPA. We saw how you can abuse RPA and basically turn it into what it is, remote code execution as a service. We saw that you can distribute payloads. We saw PowerPoint, which would allow you to play around with this thing. I really encourage you to do that because there's plenty more payloads that you can actually create. And the last thing I need to give you is something to do with it. Right, so a way to protect yourself. And so let's do that. All right, these are the best things that we've discovered so far to try and catch this attack or prevent it on your tenant. I mean, the number one thing you need to do is monitor any usage of these two executables. One is for command line and the other is for PowerShell. If you see any weird things going on with these executables, this is a giant red flag, right? Especially if you see a tenant ID that doesn't belong to you. I know that's a difficult task to always have like an updated list of tenant IDs that belong to you, but it is what it is, right? This is the best thing that we can do to protect from this, because once somebody has already registered one of those machines, one of those agents, then you're in a tough place, right? It's difficult to do something with it unless you actually get a hold of that machine. The second thing is that so again, the first two things are kind of similar. The other thing is that you can actually apply, there's a link there, I'll show the slides afterwards. You can actually apply a bunch of best practice on like there are configurations that you can create to harden your environment even more, but this requires changing registry keys on your user's laptop. So if you have a way to do that in a way like that's comprehensive, go ahead. And the last thing that I'll mention is that this has been focused on how an attacker could live off the land of this Power Automate thing, but actually business users are using this. And when you think about putting power in the hands of business users for them to automate things, connect anywhere with their own credentials, then you can think about the kind of thing that would happen, right? We can't expect them to make consciously good security decisions. So there's plenty of things that can go wrong, and if you're interested, there's an OWASP project that's dedicated to these things, the things that business users are building. It's called the OWASP Low Code, No Code Top 10. I think with that, thank you very much. Yeah, if we have any questions, then feel free.
So you mentioned that there's two flags that as part of Microsoft sort of fixes what's going on. There's two flags that they've introduced. Do you A, know if they're set by default, and B, what privileges are on those flags to unset them or change them back to what they were?
Sure. So the question, because Mike didn't work at first, the question was about the two flags that I've mentioned that Microsoft has introduced. These are indeed set by default on the newer Power Automate desktop agents. And so by default, you're fine if your machine is AAD joined and you have an updated agent. However, like you can just change those register keys. In order to do that, you need to be an administrator on the machine. It's admin to change them back, yeah. On new machines that have just been introduced, you're fine in an enterprise setting. All right. Any more questions? Okay, I'll be here afterwards. Thank you very much.
giving me wind and rain. You're some kind of butterfly. Baby, you give me midnight. You whip up my appetite. Don't leave me here high and dry. Oh, well, I don't wanna jinx it, baby, and twist myself at the spine. Don't wanna overthink it, baby. It's just twist your body and mine. Baby, you give me ice and fire. You're giving me wind and rain. You're some kind of butterfly. Baby, you give me midnight. You whip up my appetite. Don't leave me here high and dry. Oh, but I don't wanna jinx it, baby. Let's not get ahead of my time. Oh, but I don't wanna miss you, baby. So I stand up and speak my mind. Oh. Baby, you give me ice and fire. You're chilling wind and rain. You're some kind of butterfly. Baby, you give me midnight. You whip up my appetite. Don't leave me here high and dry. Baby, you give me ice and fire. You're channeling wind and rain. You're some kind of butterfly. Baby, you give me midnight. You whip up my appetite. Don't leave me here high and dry. Oh, oh,
Good morning, and welcome to BSides Las Vegas Breaking Ground. This talk is mainframe hacking for kicks and giggles, and is given by Jay and John. A few announcements before we begin. We'd like to thank our sponsors, especially our diamond sponsor, Adobe, and our gold sponsors, SemGrep, Toyota, Conductor One. It's their support, along with our other sponsors, donors, and volunteers, that make this event possible. These talks are being streamed live, and as a courtesy to our speakers and audience, we ask that you check to make sure that your cell phones are set to silent. If you have a question, use the audience microphone so YouTube can hear you. The microphone is right up here, up front. As a reminder, the BSides Las Vegas photo policy prohibits taking pictures without the explicit permission of everyone in the frame. These talks are all being recorded and will be available on YouTube in the future. All right, with that, let's get started.
Morning. So thank you for being here this morning, especially on a topic as esoteric as mainframes, specifically mainframe applications. So a show of hands, how many people here have used a mainframe as a developer, a sysprog, or a user? Okay, good amount. How many of those in the last 5 years? Even less. And then how many people have done a security assessment on a mainframe? Okay, a few. There should be way more people than that. And it turns out that it's really, really hard to do this stuff for reasons that we're going to get into. So a bit of housekeeping. The first thing is that we have a lot to talk about, and we only have a short amount of time to do it. So by necessity, we're going to have to move fast, and it's going to feel like drinking out of a fire hose. As I said, this is on YouTube, so you can always go back and look at it later. The second thing is that we are not mainframe experts. We're security researchers who were asked to look at mainframe applications, and we kind of had to figure this stuff out from the ground up. So if you're a mainframe expert, whether that's a developer or sysprog or whatever, we apologize in advance for anything we say wrong. We're security researchers, not mainframe gurus. And then the final thing is a disclaimer. We are not here on behalf of or representing our employer, and anything that we say is our own views and not those of our employer. So with all of that out of the way, this is the research team. My name is Jay Smith. I've been doing IT for about 25 years. I've done everything from thank you for calling the help desk, systems and network engineering, SOC work, NOT work, development, and now I'm a lead security researcher at my company.
My name is John. I got my career started in software development. Then I moved into information security compliance. And eventually I got into application security. I've worked mostly with HTTP-based applications, some native mobile apps, and most recently mainframes, which we're excited to talk to you all about today.
And then the third member of our research team is Garland. He could not be here, even though he should be. His contributions were extremely valuable, and we want to make sure that everyone knows he was a part of this project. So when you talk about any other topic in security, there's a basic amount of information that you can assume people have. They know how web applications work. They know how Windows works, Linux works, and so on. We don't really have that foundation with mainframes. So to really talk about this, we have to talk about what mainframes are and how they work. So when I talk to people about this kind of research and I say, hey, I do a lot of stuff with mainframes, this is what they think of. They think it's this legacy, archaic system, was built back in the 70s or 80s and is shoved in a back room of a closet somewhere. All the time I get, I worked with those things back in the 80s, they're still around. Or they think it's this giant monolithic machine that takes up an entire room and requires a team of people to operate, like Joshua from War Games. Well, the reality is today they look like this. This is a Z16 mainframe, top of the line. Costs high 6, low 7 figures, and it's one of the most powerful commercial computers you can buy. It runs an architecture known as the Z architecture and an operating system known as ZOS. And just to give you an example of how powerful they can be, one of these can run over 200 server-grade CPUs, 40 terabytes of RAM, and petabytes of storage. So there's nothing archaic or legacy about them. They are extremely powerful and modern machines. And whether you realize it or not, you rely on them all the time. Probably every single person in here has relied on one just to get here. If you've ever used a credit card, withdrawn money from an ATM, booked a plane, scanned a check for a mobile deposit, anything like that, you have relied at some point on a mainframe during that interaction. They have been and continue to be the backbone of many modern industries and diverse industries such as finance and banking, healthcare, utilities, government, insurance. All of these industries rely on mainframes to do their day-to-day operations. And you might be asking why. I mean, these things were in the 50s and 60s. Why are people still using them? And there's a lot of reasons, but just to give a couple of examples, these machines can have mean time between failures measured in decades. You can take an application that was developed in the 70s and drop it on a brand new Z16 mainframe that you just got, and it's going to work right out of the box. That's like taking a DOS application and running it on Windows 11 with no emulation or compatibility. It just runs. And for our purposes, they are very, very good at high-speed transaction processing, and this is one of the primary reasons they're used. To give some context, a modern mainframe can process up to 100 billion transactions per day. So that's the equivalent of hundreds of Cyber Mondays per day per machine. So these are incredibly powerful machines. Given the power of them and given the criticality of them, they are also incredibly high-risk systems. So if Twitter or Facebook or Instagram or something like that were to go offline today, people would whine about it, they'd moan about it, but something else would pop up in their place and life would go on. If mainframes were to stop working today, it would be global economic pandemonium, and that's not an exaggeration. Finance would grind to a halt, so you can't get money, you can't spend money. Food shelves, grocery stores would be empty because the logistics would stop working, planes, trains, all of it would stop. They are that critical to our infrastructure. Unfortunately, for reasons that we will get into, they are not tested as frequently enough or as thoroughly enough as they need to be. So now I'm going to hand it over to John, who's going to talk about the application side.
Great. So the first thing we'll cover is how mainframe applications differ from traditional distributed systems. Let's say you have a web application. Whether it's in the cloud or on-premise, you'll likely have an application server, a database server, an authentication server, a logging server, and all these distinct systems that support the same application. On the mainframe, everything is self-contained. There are no distributed components. So if you need a database, well, mainframes have subsystems rather that do pretty much anything you need for an application. So if you need a database, there's a subsystem for DB2. If you need access control, there's a subsystem for RACF. If you need a facility for maintenance and development, there's a subsystem for TSO and so on. So now, mainframe applications generally fall into one of two categories, depending on the type of processing they perform. The first kind is batch processing. So if these applications, you'll typically submit a task, work related to that task is completed, and eventually you get some kind of result. So for example, a utility company with a mainframe will likely have a monthly batch process that calculates consumption data and generates billing statements for all of their customers. So the time that these take to run is proportionate to the task that's being performed. So we can have batch processes running for minutes, hours, or even days. And because of this, end users aren't typically interfacing with batch applications directly. Instead, these are scheduled or just kicked off by some back-end process, and they just run until they're done. In contrast, we have mainframe applications that perform online transaction processing, or OLTP. And these are more like the types of applications that we're all familiar with, right? So this is when a end user submits a task and they'll get an immediate response, or submits a request and gets an immediate response. So you're at an ATM, you tap to view your account balance, and you're immediately presented with your account balance. We're not waiting around for a batch process to finish because these applications are running online. So the most common OLTP system on the mainframe is CICS, or the Customer Information Control System. And CICS is just another subsystem that supports the running of mainframe applications online. And these are more like the types of applications we're all familiar with, right? So yeah, you're at an ATM, you tap to view your account balance, you're immediately presented with your account balance. So we can think of CICS as a proto-web server before the web. And this is a rough analogy, but it'll help us understand some of the terminology. So when you're working with a CICS application, the terminal can be thought of as your web browser. And CICS does have other front ends, but if you're interacting with CICS directly on the mainframe, you're going to be using a terminal emulator. So once you're in the terminal emulator, you need to know where to go. On a web application, you'll typically just enter a URL in your web browser. In a CICS application, this is your region. So you need to know what region you're logging into. So in this example, DVCA prod is a region that we're logging into from our terminal. So once you're logged into your region, you need to know what page on that website you want to get to. So in Kix, this is a transaction. It's a 4-character alphanumeric transaction ID. So once you're logged into the region, you enter the transaction ID for the screen that you want to access. And you can access any transaction on that region, provided you're authorized to do so. So as I mentioned earlier, there are multiple ways to interface with Kix. Most of these are facilitated by APIs that expose Kix to systems outside of the mainframe. So you can have web applications, web services, RPC clients, desktop applications, native mobile applications, and all these various interfaces that interact with Kix as a back-end system. Now, you may not realize it, but many of the applications we all use today utilize Kix as a back-end processing system. So Kix is still one of IBM's flagship mainframe products. In fact, the latest version of Kix was released just last year. However, Kix suffers from this concept of a legacy code base running on modern infrastructure. So as Jay mentioned earlier, you can take a Kix application that was developed 50 years ago, drop it on a modern mainframe, and it's just going to run. This is great for maintenance and compatibility, but it's terrible for security, because many of these applications were developed at a time when security just wasn't a priority. In fact, it's not uncommon for Kix applications to go 10+ years without a single code release. And part of this problem is that the original developers retired 10+ years ago, and the ones left maintaining it have no idea how anything works. So this is a problem that reinforces the need for ongoing security testing of these applications. Unfortunately, that's easier said than done, and Jay's going to tell us why.
So the reason that we're all here testing this stuff. So management came to us and said, we need people to test mainframe applications. And we're like, cool, that sounds awesome. Let's do that. How do we do that? And they were like, we don't know. Figure it out. So we tried to figure it out. And this was us for the first year. To say that mainframes are difficult to work with is a drastic understatement. There's really no parallels you can draw to other kind of work, whether it's systems engineering, network engineering, development, whatever. All of that goes out the window when working with mainframes. You have to learn a completely new language, completely new world, everything. So that's what we started to do, but we ran into a number of problems. So the first one, and the biggest one, is gatekeeping. To say that mainframe developers and sysprogs are prickly is an understatement. Whenever we try to talk to them, if you don't know the terminology, if you don't know how to say what they want you to say or the way they want you to say it, they'll flat out tell you to get out of their face. They don't want you near their systems. They don't want you touching their stuff. They don't want anything to do with you. And to be fair to them, they have some reasons to do that, because if you don't know what you're doing, it's pretty easy to bring down an entire LPAR. Ask me how I know that. When you get that phone call from a pissed off mainframe dev, like, they're angry. So they do have some legitimate reasons for not wanting people on their system. But when you try to research this stuff, if you think Reddit is like a cesspool, read mainframe forums. So trying to look at stuff, so I just spent literally 2 minutes on one of the popular mainframe forums just looking for examples of developers being assholes. So here we have one where they said, if it's so urgent, why don't you read the manual? Well, if it's urgent, you don't have time to read the manual, plus the manuals are almost impossible to read. This dude, and he has a lot of these posts, he won't even touch your post if you don't make it colorful and pretty for him. And then this is my favorite. I doubt it's throwing errors because errors are not thrown on the mainframe. So this is what you will come across all the time when working with mainframe developers. So that was the first hurdle that we ran into. The second one is cost. Now, thankfully, we had the backing of our company and we had access to true big iron mainframes so we could do this stuff. But if you're just an enthusiast or working with a smaller company and you want to emulate a ZOS system, you're looking at about $6,000 per person per year just to have an emulated ZOS. And that's well outside the range of an average researcher. There is an open source solution, which we will get into later. If you want to do any other kind of testing out there, web applications, thick clients, Active Directory, whatever, there is a wealth of tools out there. There's tools for every single thing that you would want to do, and it's easy to build your own tools because there's already so many tools out there. Well, with mainframes, almost none of that exists. From an application perspective, we found 3 tools that could kind of do what we wanted. 2 of them hadn't been updated in 5 to 8 years, and 1 of them only kind of did surface stuff. So in the end, we had to build our own tool. And then finally, the gatekeeping combined with the difficulty of mainframes makes it an extremely steep learning curve. So whatever it is that you want to learn, there's a training body out there and probably a certification. But none of the training bodies out there, SANS, OffSec, TCM security, like nobody offers anything in the way of mainframe offensive security work. I ended up, so these are some of my personal library, and I learned more digging through these books than I did on anything online on any course that I found. So it's a difficult thing to get into. So at this point, we were tasked with looking at these applications, and we realized we had no idea what we were doing, so we just kind of had to start digging and researching. And I'm going to hand it over to John to talk about the research.
Right, so once we figured out those challenges, we came across another problem. We had no idea how to get started and little reference material. So we continued our research and eventually came across the 3270 Data Stream Programmer's Reference. And this was the official reference manual for developing 3270-based applications, which means it had everything we needed to build an attack model and start developing test cases. So this is what we learned. The 3270 terminal is a block mode terminal, which means anything you change on the screen is only sent back to the mainframe if you press one of about 35 attention identifier keys. And these were all physical keys on the 3270 on the terminal keyboard, which we don't see on keyboards today, and this will be relevant once we get to the demo. The screen buffer stores the data that represents the content you see on the screen. So it stores all of the field values and information on how the fields, how those fields should behave in the terminal. Notice how you can, this might be hard to see, but notice you can click anywhere on the screen, and it doesn't matter if there's data, if it's a field, or if it's just some random empty spot. This is because each character position in the screen corresponds to a location on the screen buffer. So when you're performing a security assessment on pretty much any application, an important consideration becomes how that application communicates with upstream and downstream systems. Traffic between the mainframe and the terminal emulator occurs over the TN3270 protocol. And this was IBM's way of adapting to the prevalence of TCP/IP and personal computers in the early 80s, because before that, mainframes were accessed using a dedicated terminal that was physically connected to the mainframe over coax cable. So IBM's solution was to wrap their existing 3270 data stream in Telnet and call it TN3270. So this allowed mainframes to be accessed over TCP/IP using a terminal emulator on pretty much any device that supports it. So you can analyze this traffic in Wireshark just like you would any other protocol. In fact, Wireshark has a dissector for TN3270, and you can even begin to uncover sensitive information in hidden fields this way. But in order to make some of the more interesting test cases possible, we needed a deeper understanding of the protocol. Fortunately, everything we needed was in Chapter 4 of the reference manual. So there were two characteristics that made the majority of our test cases possible: start field orders and field attributes. An order is just a byte in the 3270 data stream that tells the terminal how to render the screen. So this is a field. This is where I want you to position that field on the screen. Each order corresponds to a specific byte value. So in this example, the first byte is equal to the hex value 11. So we know it's a set buffer address order, which sets a field's location in the screen buffer. The next two bytes are just parameters for column and row that indicate the exact position on the screen. But the byte we're interested in is the start field order, because not only does this indicate the start of a field, it also indicates the start of a field attribute, which is the byte right next to it. So in order to illustrate why these bytes are important, I'll continue the web analogy. So whereas a web browser renders HTML that's transferred over HTTP, a terminal emulator renders a 3270 data stream that's transferred over TN3270. And we like to think of the start field order as an HTML input tag, and the field attribute byte as HTML attributes for hiding and disabling an input tag. So let's focus in on the field attribute byte. Each highlighted bit in this byte has something to say about how that field is displayed on the screen. So the bit in position 2 determines whether a field is protected or unprotected. The bit in position 3 determines whether a field is numeric or alphanumeric. And the bits in positions 4 and 5 work together to determine whether a field is hidden or displayed. So we were especially interested in bits 2, 4, and 5, because if we could intercept this traffic and flip these bits so that protected fields become unprotected and hidden fields become visible, we would have viable test cases for hacking mainframe applications. And we get to share this research with you today because it worked. Before we get into the demo, just a quick word on encryption. Our tool sort of works like Burp Suite. So we're sitting in between the mainframe and the emulator, and we're just we're proxying traffic between the mainframe and the emulator. So we negotiate TLS with the mainframe, but because the emulator is listening or connecting via loopback, we don't actually negotiate TLS with the emulator, and it doesn't enforce the need for encrypted traffic. This is why we can intercept this traffic or analyze this traffic through Wireshark, because it's plain text, the connection between our tool and the emulator. So yes, while TN3270 does support encryption, it doesn't actually prevent any of our test cases. All right, so we're just about ready for the demo. Before we do, we'll show disabling field protections, we'll show revealing sensitive information in hidden fields, and then we have some bonus attacks. We'll iterate through all known transaction IDs, and then we'll brute force some application level secrets.
So a little word about the demo. As we mentioned, if you wanted an emulated version of ZOS for your personal use, you're going to pay about $6,000 a year. I did mention that there was an open source solution, and that solution is MVS 3.8. Due to historical legal reasons, it is a perfectly legal open source version of an older mainframe OS that you are able to run on your machine, and it's used with an emulator known as Hercules. There's a few ways to get it. The two primary ones, and I have the links there. The first one is TK4, and what this is essentially a zip file that you just download, unpack, and run a shell script, and you have a mainframe up and running. The other one is a Docker container from MVS Community Edition, and this is the one I do recommend using because with it being the Community Edition, there have been numerous quality of life changes added to MVS 3.8 to make it much easier to use. There's tools that have been added, libraries that have been added, programs that have been added, so it's just a much easier to use version of MVS. And again, it's wrapped in a Docker container, so just Docker pull and you're good to go. Now, that gives you your mainframe. That's like, okay, now I can log, I can play with it, I can learn with it, but you can't do anything that we're going to demo with just this. So we reached out to Soldier of Fortran and we said, hey, we need a vulnerable kicks application, but we don't have the knowledge to do this ourselves. Can you help us out? And he's like, yeah, I got you, man. And he created DVCA, which is Damn Vulnerable Kicks Application. This is along the same lines as web application, thick application. It's just an intentionally vulnerable application for you to play with. It comes also in a Docker container, and that Docker container is the MVS CE with this application bundled in it. So you just pull this, start it, and you have a vulnerable application ready to go. But then you need to use something against that vulnerable application. And today we're releasing the tool that we've been working on for the past year, Hack 3270. So this is essentially burp for 3270 traffic. It allows you to intercept all the traffic and manipulate it in any number of ways. So you can read the hidden fields, you can disable protected fields, you can change each individual attribute. It has full logging capabilities, including a CSV export. So if you're on a penetration test and you need those artifacts for the test, you have all of that available for the client. It also has brute force capabilities, so you can iterate through aid keys, you can iterate through passwords, kicks transactions, whatever. So it's, we think, a fully featured tool that is available at the URL down below. You can go download it today and start playing with it. So we're going to try and do a live demo. 3270 is notoriously finicky, especially over a Docker container, and live demos, you know, are always subject to the demo gods, which in fact they've already hit us because we can't do mirrored, so we're going to have to look at this while we do our demo. So wish us luck. Did that already start? Hold on. There we go. Okay. This is going to be fun. So I'm going to start the Docker container. And then, so with our tool, with our tool, so we start it and we give it the server and port that we're connecting to, and then the listening port. So in this case, we're connecting to the Docker container on port 3270, and we're listening for connections on 3271. Unless I need to bring this down a bit. All right. So, boop. All right, so now this is the equivalent of burp. When you have intercept turned on, it's waiting for you to send something through it and allow the traffic to go through. So Now I'm going to connect to that, and oh, I should change the screen. All right, so it has detected the connection and says, okay, hey, I see a connection on 3271. Let's go ahead and do this. So I click continue, and you can see that we are now on the Docker container. And again, I apologize that we can't mirror this, but that should be the last time I have to move anything over. All right. Don't do this. There we go. Okay, so the tool is running. We're proxying all traffic through the tool. I'm going to log on. And this is our vulnerable application. And John's going to go ahead and walk through the next part.
All right. This is going to be a challenge, but we'll get through it. All right, so DVCA is a generic application for ordering office supplies. This is the main menu. We have 3 menu options. The first option allows us to order those office supplies. Okay, so here we have printer paper, we have a 3-hole paper puncher, we have some rosé, we have a 24-karat gold MacBook Pro. All right, so I'll go back to the main menu, and menu option 2 allows us to edit the shipping address that those items get sent to, right? But notice that in order for us to edit this shipping address, we have a supervisor code that we need to get past. All right, so we'll get back to the main menu. Menu option 3 is just an order history. So I'll go in and notice that we haven't ordered anything yet, right? So let's order something. But before we do that, we have to get past that supervisor code. So I'll go back to the shipping address menu, which is menu option 2. And I'll start to make some updates here. I won't actually go through all of this. It's really hard to see from here. But let's just make a couple of updates here. All right, so instead of sending that to Jay, we'll send it to me. We'll just update this to the hotel. Okay, let's change this to okay. All right, I'll just change this to last. Let's leave that. That'll be the last update I make here. All right, so we made some updates to our shipping address, but if I try to enter this and persist this transaction, we'll get an error, right? So it says invalid supervisor code, which appears to be a 4-digit code. So if you were using Burp, you would probably use something like intruder, right, in Burp. In our tool, we have inject into fields tab. That is it's on the other side. All right. Okay. So we have this inject into fields tab. So the first thing we would do is we would select our payload list. So in this case, we would typically have a list of 10,000 payloads, right, or injections, one for each permutation of a 4-digit supervisor code. We have an abridged payload list for the purpose of the demo. So I'm just going to go ahead and select that. So the next thing you would do is select the injection field, right? So we would click Setup. We would select a mask character. You can customize this. We'll leave it at an asterisk for now. So I'll go back into the app, and I'll change the supervisor code to our mask character. So we'll do 4 asterisks here. So our tool is asking us to submit a sample transaction using the mask character, right? So I'll go ahead and do that. And notice now the tool was able to identify the injection field, and it indicates that it's now ready for injection. So I'll go ahead and press inject. And notice you can see here all of the permutations that it's iterating through. So eventually it'll hit the correct supervisor code. I can't quite see. Does it say it works? All right, cool. All right, so we were able to brute force that supervisor code and make updates that we're not authorized to do so. So that's our first test case. We'll go back to the main menu. Now that we've updated our shipping address, we can go in and order some office supplies. So I'll go back into menu option 1. And let's order that 24 karat gold MacBook Pro. So it's $20,000, right? It's a little bit past our budget. So it'd be nice if we could edit that field, right? Like in a web app, you'd probably use developer tools or just proxy through Burp and make those updates and hopefully get some authorization bypass. Within our tool, we can use the Hack Fields tab. Yeah. All right, so I'll drag that back over again. Is it on? All right, there it is. Okay, so the Hack Field tabs, we have a couple of options here. The Start Field Extended, and Modified field, we're effectively telling the tool which start field order to parse. Currently, we have all of them selected by default. And then on the left side, we have Disable Field Protection, Enable Hidden Fields, and Remove Numeric-Only Restrictions. So here, that's where we're flipping those bits in the field attribute byte. And we have some other options here for the field intensity to highlight those fields that we're modifying. So we can toggle this now, enable Hack Fields. And I'll go back to my tool, and I'll try to make some updates here. Right, so I'll change this field, which is a protected field, and I'll update it from 20 grand to something a bit more reasonable, right, like $1. So because we've enabled Hack Fields, we've disabled field protection. So now if we hit enter, okay, right, so I have to go down, indicate that yes, we want to purchase, and then hit enter, and now we were able to purchase that MacBook Pro. Yeah. Okay, let's update this again. Okay. Okay, so now hopefully we were able to purchase that MacBook Pro for $1, not 20 grand. So I'll disable Hack Fields now, and I'll go to the next item. Let's see what we have. So we have an ancient golden idol. Right, so if I try to purchase this, I would get an error indicating that it's denied, right, where we can't purchase this golden idol. So I'll enable Hack Fields again. And notice we have this hidden field, right? So if I toggle it off, we don't see that field. I toggle it on, we do see that field. And it's a field that seems to indicate whether or not we can purchase this item. So I'll change this from yes, or from no to yes. I'll purchase the item. And now we're able to purchase an item that we were previously not authorized to do so. So I'm going to disable Hack Fields and go back to the main menu. Okay, and we'll go into the order history to see some of the work we've just done. All right, so it looks like we purchased the MacBook Pro. We were able to purchase it for $1. And then we were able to purchase the ancient golden idol despite it being not purchasable. So wouldn't it be nice if we could cover our tracks and delete this order history? All right, so we'll go back to the main menu.
Sorry, again, it's hard to see.
Yeah, we can't. Okay. So we're back at the main menu. We'll enable Hack Fields. And notice now that there's a hidden menu option for deleting our order history. So we'll go in, we'll select that menu option. Okay, we'll hit enter. And now we've deleted all of our records from our order history. So let's go back in and confirm that that's the case. Okay, menu option 3. And there you have it. We were able to cover our tracks. We deleted all of the order history. Okay, so up until now, we've demoed disabling field protections, enabling hidden fields, and brute forcing known application level secrets. All right, so the next test case will be using the inject key presses tab. Let me see if I could bring this back over again. Okay. So if we recall from earlier, I mentioned that there are about 35 attention identifier keys that send data to the mainframe, right? So we have the enter key, the clear key, 24 function keys, and I think 3 program access keys. So what we're doing here is we're iterating through all of these known attention identifier keys in hopes of finding hidden functionality. So because these applications were potentially developed decades ago, and because keyboards today don't necessarily have these physical keys, it's not a stretch of the imagination to think that mainframe developers and operators could have hidden functionality behind some of these keys, not necessarily out of malicious intent, but just to facilitate systems maintenance. So I'll go ahead and press the Send Keys button. Yeah, I'll do that. So I'll let that run. We'll run it on this screen. Okay, and we'll go back to the main screen. We'll run that again. Notice some of these options are not selected. That's because if for some applications, if you iterate through the clear button, for instance, it'll just log you out of that application. So we've unselected some of these, but of course you can toggle those as needed. So notice we found this hidden screen within the application, within DVCA, by iterating through all known aid keys. So we could use the Logs tab. We do have some logging capabilities. This will be maybe the last time we have to do this. Okay, so we do have some logging capabilities here. We have a column for just for that ID, that traffic ID. We have the timestamp. We have an indicator on whether that traffic was sent from the server or the client. We have a length that you can use to check for discrepancies in the response from the server. And then we have some notes regarding that traffic. So I'll sort by ID here. You can sort by these columns. And notice that we have the traffic that we sent while we were iterating through all known transaction IDs. So you can actually click through some of these entries here. And if you click on the server response, it'll actually update the screen on the terminal emulator. So you can see what was sent during that specific entry. So in this case, you would click through. You can see what was going on during that attack. So here it was sending the program access key 1, program access key 2, 3. And then you can click on these and see which one led to a successful attack, see which one led to discovering hidden functionality in the application. You could also just check the length, right, and check for discrepancies in the length, and that can be an indicator of some hidden functionality there. You can also scroll down. You can see whenever you toggle the hidden fields or hack fields, you should be able to see that here. Okay, so here hack fields was toggled off, here hack fields was enabled. You can see exactly which start field orders we were parsing, which field attributes got modified. All right, so we do have extensive logging here that can substantiate your security assessment on a KICS application. You could also use this if you're during your peer review process, right? If your peer reviewer wants to review what another tester did, this would be a good place to do that. So the last tab here will demo. Yes, this is the last screen. So we have a statistics tab that, again, you can use as a quick reference to see what was tested during that engagement. And you have some stats here regarding the number of attacks that were performed, and the server IP address you connected to, and so on. And again, this can be used as an artifact to substantiate your assessment. So that was our demo. Now we'll cover some closing thoughts before we wrap up.
All right. So as he said, some closing thoughts. Mitigations. IBM does have a 3270 IDS, but we wouldn't recommend using it for reasons that we're about to get into. What we would recommend using is RACF or some other authentication and authorization system. Those systems do have the ability to protect the transactions at the individual transaction level. Do not rely on hidden fields, so don't hide anything in hidden fields you don't want people to see. These are all things that we have seen on real-world engagements. And then secure your attention identifier keys, so don't have any hidden functionality, developer functionality, backdoors, whatever, in those keys thinking that people can't get to them. A quick word about the IDS. So there are two versions of the IDS. There's the BMS intrusion detection service, which is implemented at the KICS region level. Unfortunately, it can only detect attacks that were done through applications developed using BMS maps. And we have seen a number of KICS applications that were not, and in those cases, this is completely useless. The other one is the VTAM 3270 IDS, and this is set at the communication server level, so it affects every region on that server. But it is a massive resource hog, so much so that when we tested it and worked with them, they were like, we can't use this. It takes up too much resources. And on top of that, they both have the same flaw of false positives because they can't determine malicious traffic from just junk traffic. So they'll append frequently or send a lot of false alerts. So it's just not really a good IDS to use. And even IBM doesn't recommend using it in the documentation. The key takeaways we want you to have is that mainframe computing is not a dinosaur. It's alive and well. It's a critical piece of our modern infrastructure. And they're not necessarily as secure from exploits. There are ways to do attacks. And everything that we showed you on here, we have done in real-world KICS applications. There are now open source solutions for you to learn this stuff, and now an open source tool for you to do this testing on your own. We do want to give a special thanks to Soldier of Fortran. Not only did he develop the DVCA application for us, he was kind of a mentor to us for a lot of this stuff. So he has literally hours and hours of talks on YouTube. Just go search for him on YouTube and you can find so much information. This is our contact information. Feel free to reach out to us for any questions that you may have. And there's a link again to the GitHub repo with the tool. And thank you very much.
Thanks, everyone.
It looks like we have like 2 or 3 minutes for questions if anyone has one.
Two quick questions.
Sure.
How big a deal is Linux in the mainframe world now?
I'm sorry?
How big a deal is Linux? I've seen IBM saying, hey, we run Linux, life is good.
Yeah, they have USS, which is the Unix interface, and then they have Linux on Z, and it is gaining prevalence. I mean, we still see TSO a lot, and that's still one of the main interfaces, but Linux on Z is definitely gaining ground.
Is it emulated, or does it run natively?
It runs natively. It's something you would install on the LPAR, like you would ZOS.
And my second question is EBCDIC still like everything is EBCDIC?
Everything is EBCDIC, yeah. So that was kind of our first clue when we were doing the Wireshark analysis, and we were able to decode it using EBCDIC, and then that was kind of what led us down the rabbit hole. But everything over 3270 is EBCDIC, yep.
Lovely. Thanks a lot. Great
Sure,
talk.
thank you. All right, well, thank you very much.
Thanks, everyone.
street, nobody can mind. Baby, you give me ice and fire. You're giving me wind and rain. You're some kind of butterfly. Baby, you give me midnight oil. You whip up my appetite. Don't leave me here high and dry. Oh, but I don't wanna jinx it, baby. Let's not get ahead of my time. Oh, but I don't wanna miss you, baby. So I stand up and speak my mind. Oh. Baby, you give me ice and fire. You're chilling wind and rain. You're some kind of butterfly. Baby, you give me midnight oil. You whip up my appetite. Don't leave me here high and dry. Baby, you give me ice and fire. You're channeling wind and rain. You're some kind of butterfly. Baby, you give me midnight oil. You whip up my appetite. Don't leave me here high and dry. Oh, 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 some kind of butterfly. Baby, you give me midnight. You whip up my appetite. Don't leave me here high and dry. Oh, well, I don't wanna jinx it, baby, and twist myself at the spine. Don't wanna overthink it, baby. It's just twist your body and mine. Baby, you give me ice and fire. You're giving me wind and rain. You're some kind of butterfly. Baby, you give me midnight. You whip up my appetite. Don't leave me here high and dry. Oh, but I don't wanna jinx it, baby. Let's not get ahead of my time. Oh, but I don't wanna miss you, baby. So I stand up and speak just my mind. Oh. Baby, you give me ice and fire. You're chilling wind and rain. You're some kind of butterfly. Baby, you give me midnight. You whip up my appetite. Don't leave me here high and dry. Baby, you give me ice and fire. You're channeling wind and rain. You're some kind of butterfly. Baby, you give me midnight. You whip up my appetite. Don't leave me here high and dry. Oh, oh, giving me wind and rain. You're some kind of butterfly. Baby, you give me midnight. You whip up my appetite. Don't leave me here high and dry. Oh, well, I don't wanna jinx it, baby, and twist myself at the spine. Don't wanna overthink it, baby. It's just twist your body and mine. Baby, you give me ice and fire. You're giving me wind and rain. You're some kind of butterfly. Baby, you give me midnight. You whip up my appetite. Don't leave me here high and dry. Oh, but I don't wanna jinx it, baby. Let's not get ahead of my time. Oh, but I don't wanna miss you, baby. So I stand up and speak just my mind. Oh. Baby, you give me ice and fire. You're chilling wind and rain. You're some kind of butterfly. Baby, you give me midnight. You whip up my appetite. Don't leave me here high and dry. Baby, you give me ice and fire. You're channeling wind and rain. You're some kind of butterfly. Baby, you give me midnight. You whip up my appetite. Don't leave me here high and dry. Oh. Keep on moving on.
All right. Hello, BSides. Thanks for making us a part of your lunch break. I know we're all excited to be here, but do not forget to feed the body as well as the mind out there. And definitely don't forget to hydrate. This is Vegas. For those of you who are ready to fill up your brain, however, if you still have a little room left after the last day and a half of conversations, we would like to ask you to join us in welcoming Security BSides' own Karen Elizari, a senior researcher at Tel Aviv University and a founder of BSides Tel Aviv, in a conversation with Jen Easterly, the director of the United States Cybersecurity and Infrastructure Security Agency. Put your hands together.
Ready to do this? Yeah! All right, all right, all right. So thank you so much for joining us here at BSides Las Vegas, Jen. And hello to our friends watching from overseas. We are coming to you direct from BSides Las Vegas, here in beautiful, sunny, peaceful, but not so innocent Las Vegas. So we have here with us, I believe for the first time at BSides Las Vegas, Director Jen Easterly from the CISA agency. Jen has been with the agency for 2 years. She was appointed by President Biden and then unanimously confirmed by Senate to the position just about 2 years ago. Yeah. So a happy work anniversary. Woohoo! And I am personally beyond thrilled to have an opportunity for a conversation with Jen, or Director Easterly, but I like to call her Jen, if that's okay. Thank you.
Please call me Jen.
And I am circa 200 or 300 of my best hacker friends that I just haven't met before. So for me, coming to Hacker Summer Camp, coming to these events, and definitely BSides Las Vegas, is the opportunity for the conversations that we don't get to have anywhere else. So I appreciate the opportunity. Thank you for being with us, and I know we're going to have fun. I'm not sure we're going to take questions from the room. Depends on timing and if we can accommodate for that. But I just want to get started by asking you, Jen, if you can tell us, in your own words, why are you in Las Vegas this week? I know it's not for the fantastic weather or great food. So why are you in Vegas this week?
I heard there was a... Yeah, I heard it. Well, actually, the B-sides, but there's Katy Perry.
I heard about that, yeah. You got the cat ears, so you're ready.
We're coming to the Katy Perry concert, and I figured there was other stuff going on.
Well,
first of all, it's great to be with you, my friend. We were supposed to do this at B-sides in Tel Aviv, and then the
weather was against us.
The flights and the weather got against us, so I'm so glad we could reprise it here in Vegas. So why am I here? Because this is our community, right? At the end of the day, I think Roger somewhere just came up to me and said, you know, I love that you come to these things because it's hard necessarily to get time with government officials. And so, you know, I really see the hacker community as our community. We are the champions for the CISOs. We are the folks that need your help, your creativity, your ingenuity. You know, I have to say, I just love that thing. I don't know if One Dark One is out there, but I love the design.
One Dark One is the designer. Melanie, she's been doing the designs for BSides Las Vegas and many other security and hacker events for more than a decade. So we're going to give her, let's give her a round of applause for, making sure, she's been making sure that hacker events and our community events get the color, the passion, the recognition that we want. So it really helps. I
don't know if she wrote this, but the themes are the solar punk themes.
Solar punk.
Demand utopia, fight dystopia. Like that.
You resonate with that message?
I do resonate with that, fight dystopia in particular. But it represents the hacker mindset, self-taught curiosity, do-it-yourself resourcefulness, right to repair autonomy, and moral conscientiousness.
Amen.
Yeah? Is that
I agree with those values, and I think it's fantastic that, you know,
that's why I'm here.
I believe you're quite definitely one of the first CISA director, one of the first government officials to come out to embrace the hacker community in such a way. I remember vividly about a decade ago when General Keith Alexander was the head of the NSA and the Cyber Command, and he came out to engage with the community, and he said, in this room right here is the talent our nation needs. And people responded, then stop arresting us, please. So a lot has changed in the past decade. And I think that the role of friendly hackers, of security researchers, of community initiatives has never been as important as it is right now. So Jen, would you like to share with the room some of your thoughts about what CISA is doing to help prepare the nation and corporates from the ever-evolving threat landscape? Hold on. It's a drinking game. Every time I say ever-evolving threat landscape, I must drink. It's just water, don't worry.
It's just water?
Mostly water.
Okay.
But then again, a lot of beverages are mostly,
Right.
in fact, all
It's
beverages
5
are
o'clock
mostly.
somewhere.
Yeah.
So CISA, does everybody know what CISA is, pretty much? Yeah, okay. So we're the newest agency in the federal government, but we're coming up on our 5th birthday. As Karen said, I've been in the job for a little over 2 years, but we were created to be America's civilian cyber defense agency, and the mission is to understand and manage and reduce risk to the cyber and physical infrastructure that Americans rely on every hour of every day. And when you say critical infrastructure, people think it's kind of a technical term, but at the end of the day, it's the water we drink, it's our healthcare, it's our education, our transportation, our communication, how we get money from the bank and gas from the gas station. And so this really is about protecting the networks and the systems and the businesses that we rely on every day. And frankly, the vast majority of it is owned and operated by the private sector. And CISA is not a regulator. We're not an intel collector. We're not a law enforcement agency. We're not military. We are a voluntary partnership agency. And we know that the currency of partnership is trust. And so every day it's about creating trusted partnerships across the federal government, but more importantly, with all of the owners and operators of critical infrastructure, the research community, the hacker community, the threat intel community, state and local. And so that's what we do every single day to help protect the nation. And frankly, one of the things that we are very focused on during our time at Black Hat and DEF CON is resilience. So when you think about the evolving threat landscape.
Oh, you want some of my drink? Maybe you'll drink. You're better off with that, trust me.
When you think about the evolving threat landscape, it is my belief, given the interdependence, given the vulnerability, given the connectiveness, everything is digitized now. Frankly, it becomes more and more difficult to prevent bad things from happening, to prevent disruption from happening. And so we're doing a couple things on this. First, we are really trying to catalyze a revolution to go upstream, so we're not bolting on security solutions, but actually creating technology that is secure by design. So that is the only way I think we can get ahead of threats that are becoming more and more sophisticated, well-resourced, and criminals where the bar to entry is getting lowered and lowered. But I also think we need to recognize, even as we catalyze the secure by design revolution, bad things are going to happen. Disruption is going to happen. So the most important thing we can do is to be resilient to it. What does that mean? It means that we expect and anticipate that bad things are going to happen. We build our plans to expect and anticipate bad things are going to happen so that we can respond effectively and recover to mitigate risk to our businesses, to our networks, and frankly to our country, just knowing some of the threats that are out there. And I'm very excited. In a couple hours, I'm going to be doing a keynote at Black Hat with my Ukraine counterpart, Victor Zora. And I hope he talks a lot more than me because he has so many fantastic things to say about what the Ukrainians have been doing to build their resilience, and not just cyber resilience, but their operational resilience as they're dealing with an onslaught of cyber attacks, but frankly, barbaric kinetic attacks from the Russians, and they're able to continue to keep going. And frankly, societal resilience, right? I mean, this is a people that have stayed unified, incredible courage, incredible focus on beating the adversary.
Absolutely, and I do hope you have a chance to catch this keynote later this afternoon. Speaking about Ukraine, we can learn so much from what's happening. So of course we should help or do what we can to help, but some of the phenomena that I've been tracking is, or are things like the Ukrainian cyber army, which is basically a partisan group of hackers and volunteers helping defend Ukraine from Russian attacks, helping fight disinformation and spread accurate information online, and through a variety of other ways supporting what's happening there. So this is very important. Now, Jen, I'd like to come back to the conversation here. Can you tell us a little bit more about Secure by Design? Because I think it's not just a slogan. This is a very important initiative that you're driving, and I believe security professionals need to be aware of that.
Yeah. Thanks for asking. Let me just set this up a little bit because I think everybody in this audience, and can people hear me? I don't know if this thing's working. Can you hear me in the back?
All the way in the cheap seats in the back.
Right.
I'm kidding, there are no cheap seats. It's a sold-out event.
So, I mean,
Indeed.
it's a very sophisticated audience. So, look, we know, go back 40 years, sort of the short history of the internet, and let's pick 1983 when TCP/IP was implemented so computers could talk to each other, right? Since that time, security was never, ever, ever thought about for the internet, right? It wasn't created, it wasn't designed to be secure. As Dan Kaminsky said, the internet was designed to move pictures of cats, and it's very good at moving pictures of cats. So from the early days, security was not thought of. And then you had the explosion of software. And that was all about speed to market and driving down cost and cool features. It wasn't about security. Right? So you now have an internet full of malware, you have software full of vulnerabilities, and we had the age of social media where everybody thought it was cool to move fast and break things. I'm okay with breaking things, but frankly, we also have to fix things, we have to build things, right? And that's what I love about hackers, is they're not just about breaking. They want to break into things so that we can also fix things, right? It's where you talked about in your TED Talk about the internet's immune system.
Absolutely.
Right? You break things with that mindset to get things better and better. But we had social media, which was never supposed to be secure, right? And so now we have a lot of misinformation, disinformation, and quite frankly, and I say this as a mom, we have a lot of mental health issues for our kids from some of the issues around social media. And here we are going into the world of artificial intelligence. And there's a lot being talked about this week on artificial intelligence, but it's the same thing. You know, everyone's rushing now that we've got this incredible capabilities coming, the explosion of large language models, 3 times the speed of Moore's law, so moving incredibly quickly, but
how can
frankly,
we inject security
exactly,
into that
you
very,
have
very
to
fast
think about
process?
Building security in on the front end. This is about innovation, but it's about responsible innovation. So to sort of set
Responsible
that
innovation.
up, we were talking at the end of last year with some of my teammates, Jack Cable, well-known security researcher, some of you might know him. Bob Lord on my team was the CISO for Twitter and the DNC, Grant Dasher, who joined us from Google, Lauren Zabirik joined us from Harvard.
So basically you're building the Justice League of
Yes,
security.
we are the Justice League.
Okay, you're
And-
missing Wonder Woman. Oh, maybe
and
you're Wonder Woman.
By the way, I think you're Wonder Woman. By the way, I am also here to do some recruiting, so
Oh.
definitely come see us at our booth.
Is that what's on your
that's
hand?
What the
So
QR
there's a
code
QR,
is my,
a recruiting QR code
Barbie
tattoo.
work at CISA. I've even tattooed myself because I love CISA so much.
Look at this commitment to recruiting hackers
Exactly,
to CISA.
exactly.
A QR tattoo. That's never been, I don't think that's ever been done on this stage.
Exactly.
So,
It's fantastic.
so you have these amazing,
so
talented individuals.
they really catalyzed this. So they came up with this principles and approaches to secure by design, secure by default. We rolled it out in April. I gave a big speech just before we rolled it out at Carnegie Mellon, which was fantastic. And I have to tell you, the response that we've gotten from the community, to include industry, has been incredible. And so we've done a lot of listening sessions. For all you out there, we're doing a red pen session at DEF CON. So please, please, please stop by. We really want feedback.
Hold on, Jen. What is a red pen session? It's not a red team session. It's not a pen testing session. Okay? So those are the terms our hackers and security researchers are familiar with. What is a red pen session? Are you red teaming and pen testing a document?
It's
Red lines?
actually, you take a red
An
pen.
actual red pen, okay.
And you like cross out what you don't like and maybe check mark what you do like.
All right, so this sounds like a very interactive opportunity
It's
to
the-
actually
it's the mixture of
influence
red
what
team and pen
and pen
test,
testing.
right?
You're testing a pen. You're testing the pen. So that's a literal joke. But this is an actual opportunity, an interactive opportunity for you to influence
Exactly.
what CISA and what Jen and her team are pushing. So what time is this happening again?
It's out there.
It's
I
out
don't
there in the
know,
world,
but
okay.
I will now post it.
Somewhere in the
Yeah.
galaxy, there's
Somewhere
an
in the
opportunity
galaxy,
for us to do
exactly, the
So let's
galaxy
talk
of
about
Vegas.
more opportunities for hackers.
Feedback, right? Like
and
at the end of
security
the day, I mean,
researchers.
it goes back to like your whole thing about immunity, right? The more crowdsourcing we can have of smart people who are, intellectually curious, who are resourceful, who want to solve problems, we can be better together, right, at the end of the day. And so, I mean, one of my operating principles in life is to treat feedback as a gift. Now, like, I don't really, like, if you're going to be an asshole about feedback, I don't love that. But if it's, like, legit and constructive, then I'm good with that as well. So we really do continuously want feedback on our advisories, on the products we do. There's some stuff that's been done with our work that I think has made it better and better, and it's been sort of pivoted around in ways that I think can be more useful to the community. So please give us feedback, even if you're not in the red pen session. Please take a look at the principles on the website and give us your thoughts. She has what?
She has the time for you.
All right, what time is it?
Saturday at 11, where? At Black Hat, at DEF CON? At DEF CON.
It's a DEF CON. I think you had to, like Truth in Lending, I think you had to sign up for it ahead of time.
Okay.
So I'll be there. You can come. We'll like get more people in there.
All
COVID
right.
is over.
So let's talk about ways that hackers. Thank you very much. So let's talk about ways that hackers can interact not just with the recommendations and guidelines, but with the actual vulnerabilities that are out there in the world. By finding vulnerabilities, there's a law. Is it Linus's law? Given enough eyeballs or bugs are shallow. Have you heard this one before? I hope I got the quote correct.
Is that like Linus from Lucy?
Yeah, no, it's Linus from Linux. So,
okay.
yeah, the originator of the Linux operating system. So, but Linus and Lucy is like a Snoopy thing or a
Peanuts.
Okay, different, okay,
like a
different
Snoopy.
American cartoon that I did not grow up on. But by the way, we grew up in Israel on American cartoons, but like 10 years later. So we got stuff like in delay, which is why I'm.
Do you know Schoolhouse Rock?
Yes.
Does anyone know Schoolhouse Rock?
Schoolhouse Rock?
Yeah.
Awesome.
It's my passion, Cyber Schoolhouse Rock.
Cyber Schoolhouse
It's
Rock.
my post-CISA job.
All right, school is in session, rockers. So how can hackers report vulnerabilities, directly interact with what the agency is doing, what vendors and companies are doing, when we still have so many of the Fortune 500 companies that don't have a vulnerability disclosure program, or they don't have a security.txt document somewhere on their website that gives out the details on who to communicate with. I know that as part of Secure by Design, you have some of the language that originated with my sister's work on legalizing bug research and decriminalizing the work of hackers. So can you tell us a little bit more about that? Because, by the way, Jen mentioned earlier Jack Cable. For those of you unfamiliar with Jack Cable, he started his path as a security researcher with the Hack the Pentagon program, where he won all 3 of their challenge coins before he was a senior at high school. So it literally changed his life, protected his nation, created a trajectory for him to become a security researcher, a fellow with the Defense Security Agency, a team member at CISA, So these types of programs, I believe, these types of interactions, each person here in this room can be that next hero that you need to recruit into the Justice League or to just use their talent to identify vulnerabilities. So what can you do, what can we do to help them help everybody?
Yeah. First of all, is Jack out there? I know he's in Vegas.
Well, he might be watching us from a discreet location.
And then,
in
so
his
on the
underground
CVD
headquarters.
stuff, Ian Deason is my teammate out there somewhere. So he just gave
all the way in the back.
So he just gave. One of the things I love about BSides is this proving ground thing you can do.
A new
And so
stage for new
He just
speakers.
gave his first proving ground talk on our coordinated vulnerability disclosure. So we run that for the government, and essentially we work between researchers and vendors, certainly if they can't come together, and that happens a lot, to essentially work through that whole process to make sure that the vulnerability is disclosed responsibly, that there's a patch. We look at timing, obviously, because we want to make sure that there's not excessive exploitation once the vulnerability is disclosed. One of the other really cool things that we did, that I think is one of the most important things that the team did, is what we call Binding Operational Directive 2201, which is
that's a catchy name. Binding Operational
that's
Directive
right. This
2201.
is the government. So what we did was instead we called it the KEV.
The KEV.
The Known Exploited Vulnerabilities Catalog. Has anyone heard of that?
Known Exploited Vulnerabilities Catalog, the KEV. That sounds like a person I'd like
So,
to meet, the KEV.
like
The
KEV.
KEV
Yeah, exactly, KEV, right? And so the innovation here was, we all know that there's a ton of vulnerabilities, and frankly, that's what we're trying to do with Secure by Design. We should stop accepting that technology products come off the line full of vulnerabilities. Like, we've normalized that in some crazy way, and it is unacceptable. So we want to make sure that actually we're lessening that. But as we catalyze that revolution, the thing that we're focused on here is ensuring that people know in a prioritized way how they patch the most severe vulnerabilities. So the KEV is essentially vulnerabilities that we know, whether it's through Intel or other sources, that are being exploited in the wild by threat actors. And so it really helps with prioritization. Now, it's only binding on the .gov that we're the operational lead for, but a lot of private sector have taken that and looked at it and used it for prioritization. So I think it's really important.
So it's becoming adopted by more
thing. I
organizations?
think a lot of people, I'm chatting with Patrick Garrity from Nucleus Security, another security researcher, who did this cool thing. I posted it on social media. He took the KEV and he did it in terms of, like, anyone know Piet Mondrian? He's a Dutch painter. Yeah, I put like a whole painter thing. And I'm a frustrated art historian, so
okay, cool.
So it's like the art and science. So check
Mondrian,
that out.
it's got cubes and stuff in it?
Cube thing, yeah.
Cool.
The biggest ones are.
Did he use any AI to create that?
I don't know, he might have.
So that's why I brought up AI, because I want to talk about AI.
Okay, yes.
So it was a very elegant segue. So it's kind of impossible to not talk about the AI, and I really am keen to hear your perspective and CISA's perspective. I know you're also tasked with election security, which is an area you have a new member of your team focused on that with your senior advisor.
Kate Conley.
Yes. So can you tell us a little bit more about AI and generative AI, and how can we trust the information? How can we trust the devices, the technologies that we interact with, and what CISA is doing on that front?
Yeah. So I don't think we can trust it. And I
Okay.
think that's part of the issue, frankly. This is all happening so fast. These are powerful tools. It's another form of technology, which is why you think about the internet, software, social media, AI. It's another technology that we need to focus on building in a secure way. So a lot of work going on to try and ensure we can trust it. But frankly, I think this is early days, and that's why so much work is happening both in the US, but around the world in terms of getting our arms around trust and safety and security. From a CISA perspective, we're very focused on three things. First of all, how do we responsibly use these capabilities for cyber defense?
Okay.
How do we assure AI systems? I think that's very important to have an understanding about how to audit, how to test some of these new capabilities wherever they're implemented and instantiated, particularly as people start putting this in everything. And then, finally, we're looking at the full range of threats to critical infrastructure, because that's obviously our focus, but both physical threats and cyber threats. And again, stipulate that these capabilities can do amazing things, but they can also do amazing things for very bad people who I think will be able to use them for cyber attacks, for chemical attacks, for biological attacks. So we have to cost that into what we're doing. Now, my concern is incredible capabilities, but they can also be used as incredible weapons.
Indeed.
And it's not governments that are building these things and securing them. It's private industry who, at the end of the day, are fiduciarily responsible for making money.
Yeah, to their shareholders, to their investors.
And so this is why the White House is looking to bring together the big companies, and they've made voluntary commitments, but voluntary will only take us so far. And frankly, even if the big 7 companies are responsibly innovating, a lot of this is already out there in open source. So I think we have to assume that there are going to be risks that end up happening, which goes back to my earlier
The
point.
resilience point.
Resilience, exactly right.
So what I want to go to now is we're almost at the end of our session, and I regret that we may not have time to take everybody's questions, but I do want to tell you that Jen and her team, they're going to answer your questions online. Or at least I'm not promising for Jen, but you can certainly reach out and interact with CISA in more than just in person right here. But what I wanted to talk about is with regards to AI and trust. One of the mechanisms to establish trust is to demand accountability and transparency. Right? So we can trust what we can see, what we can look at, we can trust. And one of the problems with the untrustworthiness, if that's a word, untrustworthiness of existing AI is that a lot of it is opaque. It's a black box. You don't know how it works. You don't know how it reaches the conclusions. So transparency can be a tool. And I know that one of the things you've been working on is radical transparency in technology. Do you want to say a few words on that? And then we'll go to the closing question.
The principles. So there's 3 principles if you look at the document. And we didn't
What do you mean the document?
The document that is Principles and Approaches for Secure by Design. It's on our website, cisa.gov/secure by design. So the principles that Jack and others created, they're not technical principles, right? What we wanted to do was put this in the language of business. Because at the end of the day, the imperative has to come from the senior level to resource the engineers and the technical people to ensure that they're creating safe tech. So it's all about business owners owning the outcomes for security. So not placing the burden of security on small businesses, on individuals, on app developers. Really, at the end of the day, you have to think about the frameworks that are being put in place so that the big technology manufacturers who are creating these frameworks and the big tech, that they understand that they own that responsibility for security outcomes. 2, to your point, Karen, radical transparency. You know, as my great friend Jeff Moss always says, transparency creates trust. And I'm a huge believer in that, right? Always shining a light on what you're doing, ensuring that people understand. And that's part of the problem with some of these AI models is they're not transparent. They are a black box. And that's why it's incredibly important that we as a community very loudly call for that radical transparency. And we're starting to see that from some of the big companies who are saying, this is where we're at in terms of implementing enterprise MFA. This is where we're at in terms of a roadmap for memory safety. So we are calling for specific things. Please do look at that document because I would love, love, love your feedback. And so all of these business outcomes, the last one is that these outcomes need to be owned by senior business leaders. Again, that is where the decisions get made and the resource decisions get done. So we really need this to be taken on by the business community so they can support the tech community to ensure that we're building security in from the beginning.
Absolutely. So just about this AI topic, there is going to be at DEF CON a generative AI versus hackers hacking event or challenge. I believe that's happening on Friday or Saturday. Amit knows the details, but check out the AI Village at DEF CON. If you are interested to become an AI security researcher and you don't know where to start, I think that's a good place to start because that's not a job that's going to go away. Unless AI makes all of us redundant, in which case we have other problems to contend with. So just to close this off before they throw us off the stage, and thank you, Spam, and thank you, DT, for hosting us kindly. Last 2 minutes, I want to talk about workforce, and I want to talk about how we can multiply. We're definitely going to need all the humans that we can get, whether it's to work alongside the AI systems or help defend the humanity that's left in us. So BSides, I think, is a big community for bringing new people in. There's the hiring ground, there's the proving ground. In Israel, in BSides, we do a lot of recruitment efforts. We recently did the Hacker Riot event to bring 300 women into cybersecurity roles, into their first cybersecurity job. Can you tell us a little bit about how you and the agency are looking at the workforce issue, if there's anything that you want people to know, and maybe you want to remind them about your tattoo again?
Yeah. So look, we hired 1,330 people, I think, over the last
What,
2
not
years.
1,337? Oh, you already had
Oh,
7
maybe
people.
it was 1,337.
Yeah,
I'm
that
gonna
would be a
use
good,
that
yeah,
now.
that's going to be a good number.
So how did we do it? Because it's hard to hire technical talent in the government. We don't want to be like the government, right? At the end of the day, we want to have the kind of culture that attracts people who are intellectually curious, who are problem solvers, the hackers, right? And we do that. Go to our website and look at our culture. It's all about flexibility. It's about creativity. It's about inclusiveness, because we believe everybody can contribute to solving the hardest problems for our nation. So we've got multiple ways to join CISA. You can join through our Cyber Innovation Fellow program. You can live anywhere in the country and join us. You can work on really hard problems. So please come to our recruiting booths. Yes, you can check out our QR code, and it takes you to very specific jobs that we've got open this week. We're hiring, I think, 200 more, and we'll be
200 more.
We'll be closing out our hiring. So please do join us. And if you have any questions at all, in all seriousness, I'm happy to stay after and answer
I
them.
have one final question for you, Jen.
Yeah.
Do the people who work for you get to wear cat ears and have like fun colors in their
Like-
hair and their nails? 'Cause
Like
it
props,
sure looks like
props
fun.
to DT, because I saw somebody walking around with cat ears and I almost stole them from him, and he like found me some.
Thank you
so.
for preventing federal crime by
Yeah,
a federal agent.
exactly.
All right.
All right,
So thank you,
thanks.
everybody. Thank you, Jen. Thank you so much. Please.
The cat ears are actually from our Chicago BSides. Oh, sorry, there we go.
Cat
the cat
from
ears
Chicago.
are actually from our Chicago BSides organizers. So,
Thank you so
yeah.
much. All right.
giving me wind and rain. You're some kind of butterfly. Baby, you give me midnight. You whip up my appetite. Don't leave me here high and dry. Oh, well, I don't wanna jinx it, baby, and twist myself at the spine. Don't wanna overthink it, baby. It's just twist your body and mine. Baby, you give me ice and fire. You're giving me wind and rain. You're some kind of butterfly. Baby, you give me midnight. You whip up my appetite. Don't leave me here high and dry. Oh, but I don't wanna jinx it, baby. Let's not get ahead of my time. Oh, but I don't wanna miss you, baby. So I stand up and speak just my mind. Oh. Baby, you give me ice and fire. You're chilling wind and rain. You're some kind of butterfly. Baby, you give me midnight. You whip up my appetite. Don't leave me here high and dry. Baby, you give me ice and fire. You're channeling wind and rain. You're some kind of butterfly. Baby, you give me midnight.
Hello, everyone. Welcome back. I hope you had a good time at Jen's talk or the fireside. This next section is Breaking Business as Usual by Priyank. But before we get started, I wanted to do a couple reminders. First of all is that if you have a cell phone, please silence it. Even the vibration can kind of be picked up by the mics. If you have a question, there's going to be a mic in the middle you can use that one. That way it's recorded. The people on the stream will see it. And we'd also like to, thank our sponsors. We have our diamond sponsor, of Adobe, our gold sponsors, are Prisma Cloud and Toyota, and Pretax. It's their support and the support of all of our others and the donors who help us do this. So with no further ado, and because we're running a little behind, Priyank.
Thank you so much. And now my mic is working. Awesome. Welcome, everyone. Welcome to my talk, Breaking Business as Usual. We're going to talk about attacking Android enterprise solutions. Show of hands, how many of you access Workday on your personal devices? Pretty much everyone, I believe. How many of you know the policies which are being applied to your device? All right, let's find out. So a little bit of background about me. I'm currently a red teamer at Microsoft. Previously, I was in consulting and did some application security, application development as well. Then spoke at various industry conferences. I'm interested in application security, IoT, as well as the image user. At home, I'm the blue teamer because my toddler is always trying to break things. So I'm the one who's preventing those. So what is Android Enterprise? It's basically a set of APIs which are provided by Google for developers to build enterprise management solutions for Android devices. And there are two primary ways of doing this. So there was like a company-owned device, which is also known as Core Pliable Device. And this device basically operates in a device admin mode, where your administrator pushes up some policies on your whole device that also applies to your personal profile, personal apps, as well as personal data. And then this is also known as the fully managed device. And the newer thing is like the personally owned devices, which is also known as the BYOD, wherein you set up a separate profile on your work device, and your company pushes the policies, but that's only applicable to the profile of that the work profile, but not on your personal profile. So the trend is towards the latter because it's usually cheaper for the organizations to do this. Also, they don't have to deal with lost and stolen devices and stuff like that, and the whole responsibility is now on the employee or the user of this device who's now going to manage certain things. Device admin is here to stay because some countries like China, they still require, they don't support that kind of a solution wherein the EMM provider has to have root on the device as well. So let's talk, we're going to talk about the personally owned work profile in this talk. So all of those talks will be about that. So this is how you set up. When you enroll your device, you're going to see that the company is going to create a work profile on your device. So this is Android specific. What happens is the application which initiates this is going to start the setup and then activate the work profile and then push the profile, push the device settings onto this profile. So as you can see, after the setup, it's going to look like basically like this, right? The image on the right? So you can see there's like a work tray, and you can see all these work devices, work apps, and then on the personal tray you have all your personal devices. So this is the, and you can kind of pause your work profile, and what happens is like basically it turns off. The work profile, the work apps doesn't actually run when you turn it on, turn it off, and then you can toggle it on back again. So let's get some terminology here. So EMM is basically the enterprise mobility management. It's an application which allows IT administrators to push the policies onto your device, and also during the setup, this is the first application which you download onto your app on your phone. So basically under the hood, it's the device policy controller. This is the class which Android Enterprise exports, and then it communicates with the EMM software. So think like Microsoft Intune, right, or Samsung Knox Manage, or Mobile Iron. So you're going to have a device which you're going to have an application which is going to help you enroll the device, and then on the server side, it's going to communicate with the EMM software, where your IT admin is going to see all the policies on your phone as well as manage the policies as suited. So with that, let's look at the threat model. What could go wrong? So we're going to talk about what would happen from the threat model on a mobile device. Like, so for example, file system communications, like what if you install a work app on a personal profile or personal app on a work profile. You're going to look at network communications. What are these connected apps? How to take care of the EMM app security, how to take care of the work application security, as well as the final threat is about the rootkits, where if your device is compromised, which is like a big part of the threat model and why we are doing this. But that is going to happen. So look at this thing. So you use a regular Play Store to sideload a work app. Now what happens is like if the employee owns the device, you can pretty much sideload any application if you have ADB or something like that installed. Any kind of debugger, right? Some apps allow them to be installed as a personal profile. So here's the thing, like it's difficult to run compliance check on a personal app, and only server-side conditional access checks can prevent this. So as an IT admin, you need to ensure that work apps cannot be authenticated against your SSO endpoint to access corp data if they are in the personal profile. So that's like the biggest check you need to do. And do not onboard rogue work apps onto the system, even if they are just accessing employee data like email or name or stuff like that. So that was like pretty straightforward, but this is more interesting. So the whole concept of separation of work profile and personal profile is to give a separation between the data, right? There's a data boundary there, However, if you can just install so basically what happens is like a separate user is created on Android profile. So Android is a multi-user system, right? So for your regular user, you are UID 0, and when you have like a work profile installed, it's typically UID 10, or in this case, I'm running it as 11 because I uninstalled and reinstalled it. So for example, if I install an application for that particular user, that application will be visible under the work tray. As you can see, I just installed Reddit under my work profile, right? So what happens is like the trust boundary, the whole premise is now broken because I can now interact with work applications using the IPC, like inter-process communications. I can access using access their content providers, their logs, their even their storage, public storage like documents and downloads and stuff like that. So the trust boundary is basically broken. Like in this case, the work profile is pretty much useless. So the things which ID administrators should be aware of is to whitelist the work applications and run compliance checks periodically to have like whether non-approved apps are installed within the work profile. And then depends on the EMM provider, whether, so all EMM providers are going to give you a list of work apps being already installed. So you just have to run the checks and boot any application which is not, liable. So as I was saying, because the trust boundary is broken, you can actually interact with any work, work app there. So by design, for example, most intents do not cross from one profile to another. Any personal app, whether malicious or not, cannot fire an intent to a work application because the system doesn't even know that. So, and secondly, like file URI. So if you have like absolute path hardcoded in your application, that's not going to work inside the work profile. And then, as I said, the download and data directory, as you can see, it's basically another path. So I'm here logged in as root just to demonstrate, but basically it's inside MNT user emulated, user ID 11. Inside download folder, you can see that some work app has downloaded this file. But if I install a personal app inside a work profile, that app can actually access this. So basically, the trust boundary is broken. With regards to network communications, they basically have a shared network certificate store. So people who have been pen testing here for a while, as you know, you have to install a root certificate on Android to intercept any kind of network communications, HTTPS and SSL-enabled communications. As you can see, if you install a system cert under this path, which is like system etc security certs, and you can look at it, it's trusted credentials, you can see that this is the personal set of HTTPS certificate, and you can see the work one, and both of them are actually visible, are active, right? Because I installed it under one location. So there is no actual separation between the certificate store, which is like huge, because if a malware is able to install a root certificate, which is how typically malware works, rootkit is probably going to install a root certificate to intercept all the network communications, and that's going to work for work profile as well. So an EMM provider may or may not detect this. This is like pretty much very difficult to detect. So we should be aware of this issue as well. And this is by design. There's nothing can be done about it. Same about device logs. Device logs are basically a stream of logs you can access via Logcat. Work apps, personal apps, they all output to the same thing. So if your work application security is pretty weak, a huge amount of data is being leaked in the device logs as well. So again, this is inherited from Linux, and this is by design. Except that Android apps are like more chattier in their logs because you can see all the activities, all the network calls, all this stuff, depending on the work apps. You can pretty much see everything there. And then there's like this special class of applications called connected work apps. So as an end user, you're going to see, if you just navigate to settings, app, and special app access, you're going to see connected work and personal apps. So basically, this is designed to break the boundary between these two profiles. So for example, in this current configuration, you can see Google and Gboard are basically connected. So the keyboard, which you are using to access work applications and your personal applications are sharing data. So again, there's no separation at all. So as an end user, you would want to disable them if you're not comfortable with data sharing, because this is going to be by default. At least Google ones are. And an admin has to ensure that whether you guys are comfortable with these defaults at all. So as you can see, they basically run under a different user. So for example, this U0 is running as a user ID 0, as I told you, and this is like the user 11, which is the work profile. It's the same app, but it's run under a different context. However, they are still sharing data between each other. So let's move on to the EMM applications security itself. So as I explained, the basic concept of work profile is the concept of a profile admin. Earlier there was device admin, but this is a profile admin, which is actually, if you think about it, it's more like a super root. Why? Because even profile admin enforces work profiles, which cannot be bypassed even with root access. So for example, a very basic device policy, which is enforced via EMM providers, is the enforcement of a passcode complexity, right? So on your device, you're required to have like 6-digit numeric characters or alphanumeric or whatever your org requires, right? As you can see, even with root, you cannot basically reset that. So you see I'm root here, and then if I just clear the lock screen settings, that's not going to work. If I try to set it disable the lock screen for that particular user, it says that it's true, but it doesn't actually disable the lock screen. So you see that even root access, the profile admin settings cannot be bypassed. And that is the reason why the EMM application is very powerful here. And so runtime application self-protection becomes very important here. Why? Because you could use dynamic instrumentation tools like Frida to hook into this EMM application itself, and if they're not doing any runtime protection, so you can basically change all of these settings from accessing all the methods of this DPC, EMM app from within the memory, and do stuff whatever you want. So for example, in this case, I have hooked into the process. So this name of the application is changed to to protect the innocent. But basically, what I did was I just instantiated a Java object with native settings, and you can see that the default password complexity is set as 3. I would just change it to 2, and you can see that it actually has worked there. And then you can pretty much enumerate all the methods of an EMM app, and you can pretty much access any method which a device policy controller exports. So that's like the set of Android Enterprise APIs, and you can pretty much bypass anything there. And then there are some other EMM application features which we should be aware of. So for example, sending logs via troubleshooting via email, it breaks out of the work profile confinement because these apps have these design built in. And then one of the classic ones is authentication before device enrollment. So when you start the device enrollment, you have to authenticate to your org, right? And that kind of leaks your token because the device isn't trusted yet, but you still have the token on the device. So if the device is compromised in some way, then that basically defeats the purpose. And that's a chicken and egg problem, right? And then obviously you should check for device integrity first because that's the solution there. And then there are like general application security considerations for work applications. Now these are like general OWASP level security guidelines, sensitive data storage, network communications, platform level stuff, and again the runtime application protection as well. You should also be, IT administrators should also be aware of alternate forms of authentication. So for example, so this is like a growing trend that if work applications provide a different way of authenticating to your enterprise, for example, linked devices, right? So you go to an application which provides a web interface, and you can add authorized devices. You could just enter the security code, like 6-digit PIN, onto your phone, and you're simply authenticated as that person. So think of like WhatsApp web, and stuff like that. that was just one example, but that basically bypasses your MDM restrictions. Why? Because you are not supposed to be authenticated before your device is enrolled, right? So IT administrators should be aware of such applications, and such applications should be booted off. All right, let's move on to the final threat, which is like rootkits. So rootkits are users with root access, which you should assume your users will eventually gain root access. They can almost always evade detection. But can they access work data? So it actually depends if the work profile is locked or not. So let's have a crash course on file-based encryption on Android. So the way this works is like, because Android is a multi-user system, they had to introduce this file-based encryption. Earlier, it was like device encryption, where either the whole device is encrypted or not, nothing is encrypted, right? And there used to be a key, and there was like this whole thing about where to store the key and all that stuff. But now with hardware security modules, it's becoming much easier to manage the keys and stuff like that. So, and there's also this new feature called direct boot in Android, where even when the device boots up, you can see certain applications are on by default, right? Your alarm clock, your calendar, your stuff like that, right? Anything which appears on the lock screen. And until you enter your passcode, none of the underlying file system is actually decrypted. So that's the DE storage. That's a device encrypted storage. It's accessible. That is accessible once the device is boot, as after the user unlocks the device. Now, credential storage is like specific to the profile. So you can unlock the device, but your work applications might still not be accessible because those are being run under a separate user. So that's the reason like a CE storage was created. And because the work profile is running under a separate user, you see ID 10, CE storage is only available after the work profile lock is unlocked. So that brings us to an interesting, default thing, where basically once you enroll, by default, one lock is enabled for work profile, as you can see in the settings. What happens is like when the user unlocks the device, the work profile is unlocked as well, right? So when you just have to enter your passcode once, and as you can see in the logs, you can see the installed CE key for user 10, right? And then so basically, we're going to trace these calls and see how this works. But this one lock setting is basically makes it easier for attackers, right? And so remember, there was like this functionality to pause your work apps. Basically, what it does is it just throws away the CE key, the credential encrypted key, and it deletes it. So what happens is like the directory structure for all the work applications look like this, which is basically it's locked and encrypted. And until you set, key in the passcode again, it's not going to work. However, as I said, because if it's just one lock, the CE key, even though it's uninstalled, you don't actually need any passcode here. So as we see, you can still get access with root, but not by directly accessing the keys, as we're going to see. So I started tracing the calls, like where is the DE key? If the DE key is already installed, that means the device has been unlocked at least once in its lifetime after being powered on. But the CE key for that particular user is not. So here's how it works. The lock setting service for Android, these are all Android system calls. It calls the storage manager service, which calls Volt, which is like a volume daemon, and then it installs the CE key. But I found there was like an easier path, which calls the request quiet mode enabled method. And basically, when you hit the pause or unpause work profile button, this is the method being called, basically. So I'm looking at the documentation and seeing that this caller must either be a foreground default launcher or have one of these permissions, which is like manage users or modify quiet mode. Now, these are very powerful permissions. So I don't think launcher has this. So I'm going to attack the weakest link here, right? So I just got hold of the launcher. So by default on Pixel, you have like the Nexus launcher, right? So I just hook this process, hook this launcher, and then initiate a call to the request quiet mode enable method with the following parameters, passing in the user handler instance and the parameter which is the Boolean false. And this works even in a backgrounded stage, and even when the device is locked. So I just reported to Google because that's basically a lock screen bypass where you can access a work data even though the work profile was locked and the device was also locked. They rejected it. They're like, oh, this is not an issue. Why? Because foreground default launcher does not mean the launcher has to be in foreground. So I don't know what this means, but if an attacker has a full chain exploit, this is pretty much game, like your work profile data is pretty much toasted at this point. So, and then talking about more threats from rootkits, which can actually prevent actual locking as well. So if you hit pause on the work profile, so consider this scenario, like a device is reported as compromised or stolen, right? And then an admin initiates like a lock of the device so that anyone cannot try to access the work data. What a rootkit could do is like basically get a handle on the work profile's data directory, as I showed you before, like the directory which was encrypted, and they could just like open random handles on the whole device. What's going to happen is when you hit pause, FSCrypt is trying to lock and encrypt all the device directories, and that's just not going to work because there are open handles there. So even though the UI is going to show that the work profile is locked, the IT admin is going to get a notification that the work profile is locked, but it's actually not. And anyone, a rootkit or a malware or a user with root access can actually access this. I reported this to Google as well again, and then the answer is like, they gave me a pretty good, decent answer about FSCrypt, how it works, but basically, this is how it is. It's, again, inherited from Linux there. Moving on, so if there are like separate locks, so these were the scenarios where just one lock is enabled by default for the parent and work profile, right? So I just observed that the CE key is installed on the first unlock, as we discussed, right? And the work apps are still running in background. But so if a device with a weak or no passcode, remember that the device admin can only enforce policies on work profiles, right? So there could be a scenario where an administrator says that, okay, your personal device passcode could be a little bit weaker, but your work profile has to be very, very strong. This could still be an issue. The conclusion is that do not enforce only work profile password because this can be bypassed. There is a disclosure in process, and it's pretty simple. I can't discuss the whole exploit here, but basically, you will be able to bypass it even as a rootkit or as a end user with root access there. So yeah, for IT administrator, do not enforce only work profile password. And of course, know the difference. So as I said, that you set the password complexity on parent profile versus just on the work profile. So this is under the hood. This is basically like the action set. Action set new password prompts a user to set a work challenge, but action set new parent profile password prompts for a user to set the device lock. So you need to make sure that then this is also applicable to the EMM work applications developer to ensure that which API you're actually calling to enforce those. All right, so moving on, if work lock is enabled, can you interact with the work applications? So can you simply call the activity manager and start any of the work application service? So the answer is like no, because when the phone is locked, you're going to get errors like this where background start is not allowed, service instant, and then stuff like that. So basically the intent is not honored. And so this is what I was expecting when I was trying to initiate a pause or resume work profile from the earlier exploit, which did not work. And they said that, oh, this foreground doesn't really work. But they have mechanisms to block background apps, especially when the device is locked. And this is like a very powerful feature, actually. But probably we don't need to interact with these work applications interactively by using Activity Manager, because if the device is logged and the credential encryption CE key is already installed, it's pretty much decrypted on file system. And what you can do is you could probably just enumerate the file system, get hold of the tokens or anything like that, and then simply interact with the API endpoints itself, right? So you could still get access of work data over there. All right, so moving on to the next threat, what if an end user disables a work applications? So imagine a scenario where device policies compel you to install antivirus software or VPN software, like stuff like that, right? Defender or any anti-malware software. And by design, your end user shouldn't be able to uninstall those, right? Because that's like bypassing a policy, and also you're kind of risking the corporate data there on the device. So the device policy manager, DPM, can enforce this via this method set uninstall blocked. However, I found out a way to actually disable it. So you can see that when I actually try to disable it using package manager for that particular user so I set Reddit as a mandatory application, and you can see that you cannot disable a protected app. But there is like a separate method. It's like kind of undocumented, but this is like pretty much known in the XDA community that you can kind of use this instead of disable, you use disable user, and that would just work. So that mandatory app was now effectively disabled. I reported to Google, and they were like, the IT administrator should expect to, block USB debugging by default. And this isn't documented on their method, so I'm like, that's just stupid. So whatever. So USB debugging is like really important, and IT administrators should enforce this in all cases, because a lot of settings are dependent on that. So as you see, this works. All right, and so from a privacy point of view, you might want to make sure that if Android ID is queried. So Android ID is basically a 64-bit number unique to each combination of an application's signing key, a user, and the device. And this device may change if the factory reset is performed or if an APK signing key gate changes. But post Android 8.0, apps with different signing keys running on the same device can no longer see that same user ID. So this is like one of the methods. I was evaluating one of the EMM application. As I can say that you can see safety net is basically used to attest device integrity on Android. And they can kind of query the Android ID for that application. And this is like pretty much unique between the installs. Although other applications cannot use this, but this is something to be aware of, especially because in certain cases, work profiles are supported from Android 5.0 until today. But if your devices are like 8.0 and 0, because there are like certain devices on the field which are like pretty much never updated, right? And they're running Android. So this is something to be aware of. All right, so mitigations and takeaways. Moving on to the last slide. So developers of EMM solutions. So these, as we discussed, this is like the Achilles heel of enforcing management policies. And as we can see that even if by some measure we can debug the applications or perform runtime dynamic instrumentation on the EMM app, it's pretty much bypassable, even with or without root, right? IT admins of these policies should be aware of certain policies where you can kind of fine-tune the available options. As I said, like for example, certain settings have to be enabled in order for other settings to be actually effective. And the work applications developer has to follow the zero trust approach of developing secure applications. So that's like the basic, like the OWASP security stuff, right? And the end user has to recognize and accept the privacy implications of installing a management profile on your device. So last but not the least, these are like the default settings. You have to set all of these settings, but there are like a few of them which are critical enforcement of other settings. And the key point is like none of these are set by default, right? So for example, I have like these major EMM providers, Intune, Nox Manage, and Mobile Iron. The ones which we really want to care about is the first three of them. The USB debugging is disabled. As you can see, in Nox Manage, it's allowed. in Ivanti, mobile iron is also enabled. And you have to detect rooted devices. So this is important for malware and users who are able to get root on the device, right? So you want to block those devices, actively manage them. Google Play integrity product, which is now the Play API safety net is now kind of deprecated, is basically not configured on any of them. So it's up to us to basically do this. And then require antivirus, anti-malware, or anti-spyware. Again, none of this is set. Microphone, this was like an interesting setting, but it was enabled for work applications by default on Mobile Iron. So that was like very interesting to me. The other ones have not set. And then minimum security patch level is like not configured. So in a nutshell, none of the security settings are set. If you just click next, 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 and deploy a policy, you're like pretty much toast, because none of those policies are actually going to have any effect there. So with that, I think we are end. Any questions? Not working.
Thank you for the presentation. When it comes to certificates, and I saw you had the Ports Figure certificate in there. It's definitely a big concern, especially since it's shared and devices and applications are going to go through that. What do you recommend for administrators to defend that particular issue?
Yeah, that's a great question. For network security, so there are like two things you can do. I believe if you have, I think at Microsoft, we enforce the root certificate requirement using Windows Defender, and then that installs its own root certificate. So you are only concerned about work applications, right? But I think if the user already or a rootkit already has root access, there's nothing you can do. That's like, I'm sorry to say, but because what is going to happen is because it is shared, the key threat here was like the user installs a CSRT thinking that it's only going to work for personal apps, but it actually is all your work data is also going through that. So that's like the key threat there. But yeah, if they really want to do it, they can do it. I mean, the way to override is probably tunnel everything through VPN, because I think then the local device settings are not honored. Yeah, that's true for everything actually. It's irrespective of work profile. Yeah. Go ahead. Yeah.
So same question, but how would administrators block people trying to attack with Frida?
Yeah, so you have to harden the EMM application like anything. So for example, our homegrown application, I think it's called Company Portal, that's like really good at detecting whether you are being runtime debugged. So there are like a few ways you can do. So you can enumerate the loaded libraries within the application. So you can see frida-lib.so, like shared object, right? You could have like canary checks within the memory of the application, which is going to just change the hashes of the library which is being used. There are like 2 or 3 of them. I don't recall all of them, but basically you have to harden your application before being shipped over to your users. I hope that answers it. Yeah. Yeah, it's a difficult problem. See, that's the thing, right? I mean, the user actually owns the runtime. So given persistent efforts, they're gonna bypass. Awesome. Thank you so much for coming to my talk.
kind of butterfly. Baby, you give me midnight. You whip up my appetite. Don't leave me here high and dry.
Ground. This talk is Beyond the Perimeter, Uncovering the Hidden Threat of Data Exfiltration in Google Cloud Platform. This talk is given by Or Aspir, and I just have a few announcements before we begin. I'd like to thank our sponsors, especially our diamond sponsor, Adobe. Thank you. Our gold sponsor, Prism Cloud, Blue Cat, and Plextrack. It's their support, along with the support of other sponsors, donors, and volunteers that make the event possible. These talks are being streamed live.
Sorry, I'm trying my best.
We're trying our best. And as a courtesy to our speakers and our audience, we ask that you check to make sure your cell phones are set to silent. With that, please begin.
Yeah. Thank you, Greg. Okay, so hello everyone. I'm so happy to be here at BSides, and thank you for your time that you're coming here and listen and want to hear about GCP exfiltration. So my name is Or, by the way. Or means light in Hebrew, not or in that. And this is the longest title that you will ever see in BSides. So let's read it together. Beyond the Perimeter, Uncovering the Hidden Threat of Data Exfiltration in Google Cloud Platform, or in short, exfiltration in GCP. So let's start. So a little bit about myself. My name is Or Aspir. I am the head of research at Mitiga, which is focusing on incident response in cloud and SaaS. I have over 10 years of expertise in cybersecurity, both as an engineer and as a researcher. And I'm a former salsa teacher, so if you know about cool parties in Las Vegas, please let me know after the lecture. And this is Chief. It's my dog. I love him very much, and you will see him later on this lecture. So, exfiltration in GCP, how it can be possible. So the first thing you need to know about exfiltration, it's all about stealing your data from your resources and from your network. And in GCP, the attacker has to have some permissions on your environment before the exfiltration. They need to compromise some identity with permission. So later on in this lecture, you will see how it can be possible, how it can be happening. The next thing you need to know about exfiltration in GCP, the attacker can be creative. They can do a lot of stuff which are not the normal stuff that you expect. So we will see that later on in this lecture. And the last part is that logs that Google provides you, or any cloud provider provides you, are your best friend regarding to detection, regarding to investigation. So this is why in this lecture we will learn about the logging mechanism in GCP, which is very important. So what we're gonna learn today, we'll start with an introduction, and then we will go deep dive on GCP logging, specifically on cloud audit logs. Later on, I will show you how you can ingest those logs and how an attacker can exfiltrate data and how it looks at the logs. And we will finish with a summary and a quick session of questions. So let's start. So how can attacker can have initial access on your GCP environment? So the first, I gave 4 examples, but of course there are more. The first part that I gave example is leaked service account keys. So if you don't know, in GCP you have something called service accounts, which is identities that you can use for automatic operations and applications. And one of the ways to authenticate as a service account is using a key, which is like a password. So by the way, in this lecture, I will compare different cloud providers, Azure, AWS, so maybe it will help to understand more. So leaked service account keys are more like programmatic access keys in AWS for a user, or service principal keys that are leaked. And how it can be leaked, for example, if you put the keys in Git repository and the attacker has access to those keys, or maybe compromised machine with those keys. So this is one way. The other way is compromised user. After a successful BEC attacks or compromised machine, the attacker, which has permission to look at the credentials of the user, can try to connect as this user. The third part is rogue employee, with what we called insider risk. There could be a legit employee which wants to do bad things to the company for a couple of reasons. So this is another scenario the attacker can have permissions on your environment. And the last part that I gave here, the compromised machine, there could be a possibility that you run some program on your machine and it got compromised by 1 day, 0 day, anything, and then the attacker can run from this machine and use the machine credentials. So I gave you a couple of ways the attacker can have permissions. And let's talk about GCP logging, which is very important for this case. So here I gave 4 examples of logs that GCP provides you and can help you in case of investigation. The first part is VPC flow logs, more like the VPC flow logs in AWS, give you metadata about connection that happen in your environment. Cloud audit logs give you information about actions that was used using the API that GCP provides you. Load balancer logs, metadata about HTTP and HTTPS connections. And the last part, storage usage logs, are more like access logs in S3 in AWS, which gives information about things that happen inside your buckets. But today we will focus on cloud audit logs, which I believe it's the most important one for detection. So, cloud audit logs, what is it? It gives you information about administrative activities and access inside your resources. It answers questions like who did what and on which resource. And this log can be split up to different categories, which are admin activity, data access, system event, and policy denied. By the way, after this part, you have a quiz, so be focused. So, admin activity audit logs. Admin activity audit logs include what we call admin right operations, such as creating resources, deleting resources, modification of those resources, more like the activity logs in subscription in Azure. So those logs are very important. They are enabled by default, and you need the permission of logging viewer in order to see them. Examples of such actions that are recorded in admin activity are in Compute Engine. You have creating new instances, update instance tags, removing instances. In BigQuery, creating data sets, removing tables. Cloud storage, creating new buckets, changing existing object ACLs. And in Cloud SQL, creating new instance, StarDB replications, and more. So this is about admin activity. The other category is data access audit logs, which captures actions which a person read the metadata of your resources and did data actions on your resource inside those resources, like written data and reading data from your resources. Those logs are not generated by default. You need to explicitly enable them for each service, and they have some cost penalty. They are not free. By the way, they're enabled specifically for BigQuery. And another thing about it, that if your resources are publicly available, you won't get any data access logs from those resources. We will see how it affects us later on. So how you can enable those data access audit logs on your GCP projects. So this is an example of a page in console which you can enable those logs for each service. As you see, you have 3 categories. The admin read, which is actually reading the metadata of the configuration, the data read, and the data write. So examples of such actions that get recorded under data access in Compute Engine. By the way, Compute Engine doesn't have data read, data write, only reading metadata. So listing instances, listing disks, getting permissions, BigQuery, reading tables, appending data to tables, writing data. In Cloud Storage, listing buckets, reading objects, creating objects, and in Cloud SQL, creating DB instance, listing databases, and even exporting data outside. The last one that we're going to talk about, which are important but less, are system event audit logs, which are generated by Google themselves. If, for example, you want Google to delete some bucket after it expired or any resource, Google do it for you, and those logs are recorded in the system event audit logs. They too enabled by default. Such examples of automatic instance restarts, table deletion after expired, and automation of instance backups. By the way, in cloud storage, you don't have those logs. And the last one is policy denied audit logs, which enabled only for VPC endpoints in GCP, and record access denials due to security policy violations. So now we come with the quiz. So now I want to know if you really understand. I will give you an action, and you need to answer if it's an admin activity or data access log. So the first one, copying objects in buckets. What do you think it is? It's an admin activity or data access? Data access. Cool, so you are right, this is data access. Next one, setting labels on compute instances. Setting labels, what do you think? Data? Admin, it's admin, you are right. Next one, execute SQL query on Cloud Spanner. Cloud Spanner is another service in GCP. What do you say? Data access. And the last one, reading blobs from storage accounts. Data or admin? Data? Going once, going twice? No, this is Azure Logs. Fail. All right, so I just wanted to see if you really got it. So, okay, how you can ingest those logs? So you have a couple of ways. One of the ways using the console, you can using what we call Logs Explorer to do queries. The other thing is gcloud CLI or the API itself. Here you have the API, and the log format, how the log looks like. This is an example of a log. I removed all the things that are dynamic and focused on specific stuff, such as log name and timestamp. In log name, you can see from where the log came from. In this specific case, this is data access, and it comes from the scope of project 1. By the way, GCP, you have organization, you have folders, you have projects. So this comes from project 1, and it happened in this time. The timestamp says when the action happened. Identity. In here, you can see who did the action. So in this case, this is a service account. I know that because this is the format of the service account, the domain. The name is Mitiga. And the IP and the user agent that were used in this action. Authorization info, which is a very critical area that people miss, is the permissions that were used in this action. So in this specific case, the permissions that were used are the get IAM policy of snapshots on the snapshot of snap 1. And the last part are the service name, method name, and the resource name, from which service it came from, what is the resource, and the actual method. So this is the whole event, but of course, there are more elements that are important. But those are the basic ones. So now we are studying the good part. I will give you now examples of exfiltrations in three popular services: cloud storage, BigQuery, and Cloud SQL. And I'm trying to show you different ways it can be possible. So we will start with cloud storage. Cloud storage, if you don't know, it's like S3 in AWS or storage account in Azure. Resources that you need to take care of are buckets, objects, and objects can be exfiltrated. So let's start with the basic form of exfiltration. Let's say an attacker has permissions, specifically object get, and they are downloading objects from your Google buckets. So what you can see in the event itself, which is very informative. So the first part is the request. In the request, you can see which object was downloaded. And in the response, you can see metadata about the object itself. But what is the problem about looking at those logs and understand if something is malicious or not? So the first part is visibility problem. If the bucket or the object is public, everybody can see this object and download it. You won't have any data access logs, as I said earlier. So you can't see if somebody is really downloaded the object from your bucket. In order to maneuver it, you can use another log, which we said earlier, storage usage logs. But yet again, this is not like a wonderful log that gives you all the information. It will just show you that somebody downloaded the object and from which IP. And the last thing about this problem of detecting something malicious in the get object is granularity. Let's jump for a second in AWS. In AWS, when you're downloading an object, you have get object. When you want to see the metadata of the object, you have get object metadata. But in GCP, you have only get object. So it's very difficult to differentiate between those actions. So for example, if you want to do some anomaly detection, you see 100 downloads for a specific bucket. You cannot really show if somebody read the metadata or the data itself. But we found a way. You can see under the authorization info which permissions were used. So in downloading file, you will see object gets, only object gets. But in get object metadata, you will see also the permission of get IAM policy. And why this is like that? It's because when you read the metadata, you also read about the permissions somebody has on this specific object. So this is a cool way to differentiate between those actions. So now I showed you the simple part of how you can exfiltrate data from your bucket.
Before we move on, could I ask a question?
Yeah.
Hi. Have you ever heard of Wayne Gorbea?
I have a small request. Can we add it to the end of the lecture, please?
Oh, well, actually, in this case, no, because I think you made an outrageous speaker request when you filed your request to speak here.
Okay.
And you said that you wanted some of the salsa music that you like to write code to.
All right, okay.
Is that you? Am I in the right spot?
Maybe so, I don't know.
Okay, so I was wondering if you've ever heard of Wayne Gorbea. Is salsa picante, no?
Maybe, I don't know.
Are you a salsa fan?
The energy here, like I'm very high, so I'm not sure what is happening right now. Okay.
During the call for papers, when you submit a talk, there's a field at the end that says any other outrageous requests.
Okay.
And you put down salsa music that I like to code to.
All right, okay.
Was
so
that
you want
you?
to put
Yeah.
some salsa?
So I have here for you a CD of Wayne Gorbea with salsa picante.
This is a gift for me.
This is a gift for you, yes.
Thank you very much.
All right.
Wow. Thank you. Oh wow. This is new. Okay. Thank you very much. Okay, so
welcome to BSides.
Thank you, BSides. So now let's come back to the interesting part of GCP and not salsa. Okay, I put it on the side. Okay, so where we are focusing on. So we looked at storage on downloading objects, which is the easy part, the most direct way to exfiltrate data. And now I'll show you a different way an attacker can use service in order to do the exfiltration for them. So welcome to Storage Transfer Service, which is a service that GCP provides you for transferring data from other cloud providers to your GCP bucket and from other GCP buckets. So this service is very easy to use. And another thing about it is that this service uses their own identity, which is another service account in your project. This is the format of this service account: project, project number, and storage transfer service. So how can attacker can abuse it? So the first part, the attacker needs to add information on the source bucket to the specific service account to read objects from the bucket. And then they need to give permission to write on the target bucket and create a task of the job transfer. So what happened, for example, if the bucket exists in a different organization? So let's see. So the log that we will see here is the adding permissions on the source bucket. As you can see, I focused on the specific part, which you have adding permissions to the specific service account of reading permission on the bucket. And those are the logs of the actual transfer. You see the get object from the victim's bucket. But that's it. OK, somebody created a job, and you see the permission added to the source bucket and getting the object from the source bucket. But that's it, nothing else. So what is actually missing here? So the first part is you don't see the adding permission of the right permission on the targeted bucket. Why? Because you will only see logs that comes from resources inside your organization or project, but this bucket is existing in a different organization. So you won't see the write operations. The second thing you won't see is the actual write, of course, for the same reason. You won't see the write on the targeted bucket. And the last part, which I think this is the worst case, by default, you won't see any creation of the transfer job. So you cannot see who created the job and to where the data will go to. So this is bad, of course. I get bad. And how you can still detect it and maybe look at it as something suspicious. For the first part, when you first time create when you enable this service in the project, you will see the creation of this service account. And so you can assume that in the future you will see some work there. The second part is the set time permissions on the victim's bucket. If you see somebody gives permission to this service account to read from the project, to read from the bucket, you can assume that there's going to be a transfer job, and probably this identity is going to create those jobs. And of course, seeing the storage object get. If you see a lot of get from the service account, you can assume that there is jobs going on. And the last part, if you want, you can not only look at the logs, you can just listing your resources inside your organization. If you see those jobs when you're using those API on the right, the gcloud transfer job list and describe, you can see actually who created the job and where is the destination. So in this case, here's how it looks in the console. So in this case, the attacker abused another service to do the hard job for him. So if you don't know that this service account can be abused, you probably can miss those exfiltration. So we finished with cloud storage. I gave you a simple way to exfiltrate using direct download and abusing storage transfer service. And now we will go to BigQuery. So BigQuery, another popular service in GCP, which used by BIs, analytics, and more. And resources that you need to take care of are data sets, which is a logical container for tables and views. So how it may look when you query the data from your BigQuery tables when the identity exists in the same project and in the same organization. So here an example of such query. You can see someone is, myself, querying the table of users inside company dataset, and then I'm searching for usernames that are not this specific user, the external user. By the way, those passwords are not real, so you can take pictures, but nothing will happen. So in the log itself, when the identity runs from the same organization or the same folder, you can see on the right, and it's a small part, but I'm sorry, you can see here the actual query of what actually happened. But what happened if the identity runs from a different organization? So as you know or not, you can run from a different context of a project. So if the identity has permission to read data from a specific table and their context runs from a different organization, the logs may seem different. So here is the full log of reading the tables. And as you can see, there are no metadata section. So if you don't have the metadata section, you cannot see the actual query. So you can assume that the whole table was compromised. So how it can look suspicious or maybe malicious? So in cases you see a log of get data from the table, and there isn't any metadata section, probably somebody from other organization queried your tables, which may itself be suspicious. And the last part is look at the identity itself. If, for example, a service account which exists in a different project or a user from a different domain that you are not know about did some query, this is suspicious by itself. So look it up, see if you have those logs in your system or those identities and service accounts. So this is about BigQuery. It was a quick one. And let's finish with Cloud SQL. So I showed in the beginning direct query, a cross query for different organization, abusing a different service. But now we will use a different API. So before we will start with it, just a quick introduction to Cloud SQL. This is the RDS, like in AWS. This is the managed RDBMS for MySQL, Postgres, and SQL Server. And the resources that are very important regarding to data are Cloud SQL instance, database, and read replicas. So here is export SQL dump file feature. You can, if you like, you can export data from your instances to buckets. By the way, this is the same for AWS. You have this feature in AWS also. And about it, the first part is you need to know that this is an API that you use. You're not using a different service account, a different service like in transfer service. You're using your own permissions and you're using this API. And another case is that the dump file will not be encrypted by default. So if I compare it to RDS, in RDS you have this feature. You can export data to buckets, but you have to use KMS keys. So in this case, you don't have to. So if the attacker or anyone has permission to read from the bucket, they can just read your databases. So how can attacker can abuse it? Same case. The attacker can just run export on your instances, and the bucket itself can be inside the organization or maybe outside of the organization. The only things that the attacker needs are writing permissions on the buckets, and of course doing the export data. And of course they need to have the ability to read from the bucket in order to do the exfiltration. But why the attacker needs to use it and not just query directly the instance? Why? Because think about it. Sometimes you have some network gap. You need to have network access to your instances in order to do the query. Sometimes you need to know the identity inside those instances in order to do the query itself. But now you just need to have the ability to export data, which is kind of like DevOps IT operation. So how you can detect it as something that may be suspicious or malicious? Look at the body of the export. In the body, you can see the full URI of the object that will be created in the destination bucket. You can see here the shelf test1 destination. Here is shelf, by the way. And this is the name of the bucket. And you can see the actual object. So in case the bucket exists in your organization, you can look for other actions that happen to this bucket or this object later on, such as changing object ACL, changing bucket object's permission, and even get data. If you see those actions, you can assume the attacker is doing the exfiltration. But if, in case, the bucket exists in a different organization, you won't see those actions. So if you see only the export and the bucket isn't exist in your list of buckets inside your organization, this is suspicious. You need to take care of it, and you don't have any logs after it to see what happened to the object. So to conclude all the examples of exfiltration, we've seen here simple object get. We've seen here abusing a different service that they have their own permissions. We see cross-organization query, and we see an abuse of a different API which is not directly querying the data, which is the export of the SQL dump. So to summarize everything, the first part, please, people, please, don't depend solely on the default logs that GCP provides you. You have a cool way to route those logs to a different destination, such as BigQuery or a SIEM or buckets. So please route them and save them in some place which will have longer retention, and you can really understand what happened. And of course, you need to enable those data sets, data access logs. So when you come back home or to your office, check your logging configuration, see if everything is enabled as it should be for your side. The second thing is that depending on the logs is not enough. As you've seen here, I did some listing and describing of resources inside your organization to check, for example, if a bucket exists in a different organization, or to see the job that wasn't exist in the logs. So have a good way to listing your inventory, maybe using an open source or commercial solution. Third part is that really learn what the logs provides you. Sometimes you have visibility gaps. Sometimes things seem weird, and really understand what the logs may look like. You have a lot of like TTPs and queries that you can look over the web and in our site too, and you can use them in order to see how malicious actions can look like in your GCP. And the last part, don't assume the attacker will use the simple way to exfiltrate data. Sometimes the attacker can be creative and can do more actions that will do the exfiltration for them, and you won't see it if you don't know about it. So I want to say thank you very much. It was a pleasure to be here, really. Thank you for your time. So of course, we have time for questions, but if you have later on question, you can just connect with me using the LinkedIn. This is a legit barcode. It's not a malicious one, and over the email. And give big claps for Chief that helped us in this lecture. Thank you very much, Chief. And of course, if you have any questions, I'm here. Okay, this is good too. So thank you very much. My name is Ora Spear, and I hope to see you later on this conference. Yeah, well, there is a question, yeah.
So most of the defaults are not secure by default through GCP and the GCP logging. Are there any resources you'd recommend in order to harden and best prepare an organization for an incident to detect it? And also, we'll just also say to prevent. So the detection and the prevention as two separate questions.
So it's a cool question, important one. So in order to detect, you have to have those logs. You need to check when you come back home or to the office, look at the configuration of the organization of those data access logs, see if you have some kind of GCP sync that routes the logs for you to a place which then you can add detection to it. Regarding to prevention, so you have something that's called policies, security policies in organization. You can automatically disable stuff such as not allowing any public buckets, for example. So you can use those policies in order to do prevention. And of course, harden your configuration, use some CSPM solution. And of course, you can use our blogs. We always publish stuff that we find, and we want to help the community to really understand how attackers can abuse the systems, not only in GCP. Yeah? Thank you very much, guys. And
up my appetite. Don't leave me here high and dry. Baby, you give me ice and fire. You're channeling wind and rain. You're some kind of butterfly. Baby, you give me midnight. You whip up my appetite. Don't leave me here high and dry. Oh, Baby, you give me ice and fire. You're giving me wind and rain. You're some kind of butterfly. Baby, you give me midnight. You whip up my appetite. Don't leave me here high and dry. Oh, well, I don't wanna jinx it, baby, and twist myself at the spine. Don't wanna overthink it, baby. It's just twist your body and mine. Baby, you give me ice and fire. You're giving me wind and rain. You're some kind of butterfly. Baby, you give me midnight. You whip up my appetite. Don't leave me here high and dry. Oh, but I don't wanna jinx it, baby. Let's not get ahead of my time. Oh, but I don't wanna miss you, baby. So I stand up and speak just my mind. Oh. Baby, you give me ice and fire. You're chilling wind and rain. You're some kind of butterfly. Baby, you give me midnight. You whip up my appetite. Don't leave me here high and dry. Baby, you give me ice and fire. You're channeling wind and rain. You're some kind of butterfly. Baby, you give me Baby, you give me ice and fire. You're giving me wind and rain. You're some kind of butterfly. Baby, you give me midnight. You whip up my appetite. Don't leave me here high and dry. Oh, well, I don't wanna jinx it, baby. Can't twist myself at the spine. Don't wanna overthink it, baby. It's just twist your body and mine. Baby, you give me ice and fire. You're giving me wind and rain. You're some kind of butterfly. Baby, you give me midnight. You whip up my appetite. Don't leave me here high and dry. Oh, but I don't wanna jinx it, baby. Let's not get ahead of my time. Oh, but I don't wanna miss you, baby. So I stand up and speak just my mind. Oh. Baby, you give me ice and fire. You're channeling wind and rain. You're some kind of butterfly. Baby, you give me midnight. You whip up my appetite. Don't leave me here high and dry. Baby, you give me ice and fire. You're channeling wind and rain. You're some kind of butterfly. Baby, you give me midnight. You whip up my appetite. Don't leave me here high and dry. Oh, oh, some kind of butterfly. Baby, you give me midnight. You whip up my appetite. Don't leave me here high and dry. Baby, you give me ice and fire. You're channeling wind and rain. You're some kind of butterfly. Baby, you give me midnight. You whip up my appetite. Don't leave me here high and dry. Oh.
Breaking Truth. Are we good with the AV? All right. So welcome to Breaking Ground. We've got Mayor here to speak to us about the ever-shifting habits of cloud malware campaigns. But before we get started, we want to thank some of our sponsors, Adobe, Prisma Cloud, SEM Group, BlueCat, Nudge, all out in the vendor area for you to check out with some pretty cool swag with some of them, all of them. All right, cell phones. These talks are being live streamed, so we ask that you do not take pictures or keep your phone on silent. If you want to take photos of the slide, that's okay. Please be careful with taking photos of other people. After we finish, there's going to be some time for Q&A, so please be sure to hold those until the end. And with that, let's get started.
Thank you. Hello, everyone, and welcome to my talk. So before we get started on the agenda for today, I'd like to first introduce myself. So I'm Matt Muir, and I'm the Threat Research Lead for Cato Security. Prior to working at Cato, I was a macOS malware researcher for several years, and I also have a background in DevOps engineering and digital forensics. So I've published several blogs detailing research into new and emerging malware families conducted by myself and my colleagues at the R&D team at Cato. I've spoken about this research at various conferences, including Black Hat EU, BSides, and GERCON. So this is actually my second time speaking at BSides Las Vegas, the first time being last year, and I'm very grateful to the organizers for having me back once again. So for anyone interested in our research or in cloud security in general, you can follow me on Twitter, or X as it's now known, at the handle on screen. I'll also be answering any questions as mentioned previously. So let's move on to the agenda for today. So anyone that was at my talk last year will likely remember that I focused on two distinct malware families. These families were named CoinStomp and ABCbot, and we'd been tracking them over the course of 2022. Now, given that I was eventually invited back to BSides LV, it seems like this formula was something of a success, and therefore I've decided to do a similar talk this time, but covering two new campaigns. Both of these campaigns were discovered and analyzed over the course of the past year. So the first of these campaigns is a family of cloud-focused hack tools named Legion, whose purpose is to harvest credentials for various SMTP services and hijack them for spamming purposes. So we'll take a look at some of the more interesting features of Legion, including the tool's ability to persist in AWS environments, and the tool's exploitation of AWS, SES, and other cloud-based SMTP services. I'll then move on to discuss DICOT, who are an emerging cryptojacking group, whose payloads that we discovered after detecting an interesting attack pattern on one of our cloud honeypots. So we'll take a look at a specific DICOT campaign that leveraged multiple interlinked binary payloads, which of course resulted in lots of complaints during analysis. So we'll also discuss some of the group's objectives, including their propensity for doxing and deployment of botnet agents on target hosts. And finally, I'll wrap up the session with some observations and predictions for cloud and general Linux malware before giving you the chance to ask any questions. So as you've probably gathered, there's quite a lot to cover here, so we'll dive straight in with our first family, Legion. So to give everyone a quick overview, Legion is written in Python and designed to exploit misconfigured web servers for the purpose of harvesting credentials. The tool automates the process of gathering these credentials, which provide access to cloud-based SMTP services. Legion will then attempt to access these services and even send test emails on behalf of the operator in preparation for spamming campaigns. Now, since it's written in Python and contains no obfuscation, Legion executables aren't particularly difficult to analyze. One slightly annoying thing about them is that they tend to be in the region of 21,000 lines long, which makes me think that the developers have yet to learn the concept of modularity. So I'm being careful not to use the term malware too much with Legion, as although it is technically malicious software, it doesn't infect the user's own machine or attempt to obscure its functionality in any way. For this reason, we personally would class this as a hack tool, given that it's used to facilitate cyber attacks rather than to conduct them. So acknowledging this, Legion contains some features that you might expect from traditional hack tools, included bundled exploits for conducting RCE on servers running Apache and PHP, and the ability to conduct target enumeration via Shodan, providing you supply a likely stolen API key. So the tool also contains some AWS-specific features, which is what made it interesting to us in the first place. If it manages to successfully retrieve AWS credentials from targeted servers, it will then automate the process of inserting a backdoor into the AWS account, acting as a persistence mechanism. Rather interestingly, Legion also contains a very rudimentary AWS credential brute forcing feature, the efficacy of which is dubious but entertaining to analyze nonetheless. So before moving on to discuss the functionality of Legion, let's discuss its distribution method and some details that we uncovered about the background of this hack tool. After first encountering Legion, we managed to trace its origins back to a public Telegram group using an embedded Telegram group ID extracted from the primary payload. It soon became apparent to us that this group was being used to advertise and sell the malware to potential operators. At the time we accessed it, the group had around 1,090 members and had been active since February 2021. Now, either that's a lot of people interested in exploiting cloud services to conduct malware campaigns, or it's a lot of overly enthusiastic malware researchers. So along with the embedded Telegram group ID, the original Legion sample we encountered also contained references to a Telegram user named MyLegion. From strings seen in the sample, we assumed that MyLegion was actually the developer behind the tool. So we examined messages in the Telegram group to see if we could find any discussion authored by this user. When we did access the group, we expected to find the MyLegion user listed as the group's admin. Instead, there were actually several messages from the real admin warning users of scams being conducted by the MyLegion user. So the admin didn't provide any context, but it appears that the copy of Legion we encountered was being illegitimately circulated by the MyLegion user. So from this Telegram group, we discovered a YouTube channel with the name Forza Tools, which included several tutorials for using Legion. Forza Tools also happened to be the username of the real admin warning members about the MyLegion scammer. So from this, we concluded that Legion was likely a paid hack tool distributed and sold by the user Forza Tools. So with that background out of the way, let's focus on Legion's functionality. Legion is highly opportunistic and relies on serious misconfigurations in target web servers for the majority of its functionality. However, that isn't to say it's unlikely to succeed. As I'm sure most of you know, these types of configurations are common methods of initial access, particularly in cloud environments. So Legion is designed to target servers running a variety of common web technologies. These include content management systems and web applications based on pure PHP or frameworks such as Laravel. Its core functionality is to identify these servers and attempt to retrieve application secrets from them. Once targets are identified, GET requests are sent to resources at a number of hard-coded paths, and this determines whether or not resources located at these paths are publicly accessible. So these resources include things like PHP info scripts and environment files, which have the potential to include application secrets. If the tool successfully retrieves any of these files, it will then run a series of regular expressions over the contents to extract credentials for various web services. You can see an example of the files themselves in the table on this slide. So one of the services specifically targeted by Legion is Twilio. And for those of you that don't know, Twilio are a company that develop tools for automating communications methods. So this includes things like programmatically making phone calls, sending or receiving SMS messages, and other forms of communication. So here's a code snippet from Legion showing how the malware scrapes Twilio secrets from exfiltrated credential files. Now, there's nothing particularly fancy going on here, just simple regular expressions for Twilio secrets embedded in the credential files that the tool targets. So one of these regular expressions targets Twilio string identifiers, or SIDs. SIDs are 34-character identifiers that are used to query specific Twilio resources via their API. Typically, they're prefixed with 2 characters, allowing you to identify the resource type. Now, Legion doesn't seem particularly concerned with any specific resource type, and instead just grabs any value assigned to the Twilio SID environment variable. It also does the same for the Twilio token environment variable, which is likely used to store an authorization token. So if successful, any extracted credentials are saved to a file and reported to the operator via standard out. Now, we've already mentioned Legion's deliberate targeting of AWS, and this slide demonstrates the method taken to extract credentials for further exploitation. In this example, we can see the tool utilizing a similar process as the one described previously, but this time attempting to retrieve an AWS secret access key ID and corresponding secret access key from any exfiltrated environment files. Legion assumes that these credentials will be stored under the AWS access key ID and AWS secret access key envars, respectively. Now, this is a safe assumption, as this convention appears in many AWS tutorials and sample code. Of course, it relies on another series of regular expression to discover these secrets and save them for later use. So I'll give you a quick overview of all of the services targeted by Legion before moving on to discuss the AWS-specific functionality in some more detail. So on this slide is a list including the majority of services targeted by Legion. So if you're at all familiar with these services, you'll recognize that they're either cloud storage services, payment services, or communications platforms. And this gives us some insight into the motivation behind the development of this hack tool. It also supports our theory that the primary use for Legion is to access these services for spamming purposes, which we'll come back to. So now that we've covered the credential exfiltration aspect of Legion, let's move on to discuss some of the AWS-specific features that are relevant to those of us working in cloud security. So before we get stuck into this, I want to give a big shout out to Ian Al from Permiso. So Ian noticed an earlier variant of Legion and posted some interesting information about the persistence mechanism on LinkedIn prior to our discovery of the sample. He also wrote a really interesting blog about some of the AWS functionality that Legion exhibited and collaborated with us on a blog for the first sample that we discovered. So I'd highly recommend reading his take on it. Now, as we've already discussed, Legion attempts to scrape AWS secret access keys from misconfigured web servers and applications. Given that this method is particularly opportunistic, the tool also includes a failback option. In the event that no AWS credentials are discovered in retrieved environment files, users are offered the option to brute force AWS credentials using a simple generator function. And we'll cover this in more detail in a coming slide. So I've already mentioned the tool's ability to provide the operator with persistent access to an AWS environment. And as you might imagine, Legion achieves this by creating a malicious IAM user and inserting it into the target AWS account using the stolen credentials from the previous stage. An attacker-created IAM group is also added to the account, to which the malicious user is added. On top of that, the infamous AWS Administrator Access Managed policy is then attached to this group, and the IAM user ultimately inherits the permissions associated with this policy. So with all of this in place, Legion can perform automated actions with Amazon's simple email service, or SES. So let's have a look at some code examples of this. So first of all, let's take a look at Legion's AWS Credential Brute Forcer. Now, before discussing this, I think it's worth stressing that brute forcing AWS credentials in this manner is incredibly unlikely to be successful. I won't attempt to calculate the probability of success with this method, but you can probably imagine that it will be very low. So as you can see on the slide here, the function simply builds up a list of 16 alphanumeric characters and appends them to the AKIA prefix. Now, for those of you that don't know, the AKIA prefix is used for long-term credentials reserved for IAM users or the account's root user. So this procedure results in a string resembling a valid AWS access key ID. Once this is created, an AWS secret access key is created using a similar method, resulting in a credential pair in a valid format. So Legion logs the number of AWS keys that it creates using this method and writes them to a file for later use. Now, Lacework posted an analysis of a similar malware or hack tool family that they named Androx Ghost. Androx Ghost included a similar brute forcing function, and Lacework concluded that its inclusion was likely a novelty more than anything else. And we would agree with this, given how statistically unlikely this procedure is to succeed. Now, onto some slightly more serious functionality. So I mentioned already that Legion enables persistence in AWS environments. To achieve this, the tool uses credentials stolen from the environment file enumeration stage and creates an IAM user with the username SES_Legion. So Ian from Permiso noticed that earlier variants neglected to tag this newly created user, providing a detection opportunity for defenders. However, in the sample that we encountered, as we can see on the slide here, this newly created user is assigned a tag with the key owner and a hard-coded value of MS Boharis. It's possible that this was added in reaction to Ian's posts on detecting Legion activity by hunting for new IAM users without tags. So with the malicious IAM user in place, permissions need to be defined so that the operator can access resources and services within the account. To achieve this, a new IAM group named SES admin group is created, and the MS Boharis user is added to it. Legion then goes ahead and creates a policy based on the administrator access AWS managed policy and attaches it to this group. We can see an example of this in the create new policy function, which is visible on this slide. So of course, anyone working in cloud security knows that this essentially gives users within the group full access to all AWS services, including access to the management console itself, providing that it's been enabled. Crucially, it also allows Legion operators to access AWS Simple Email Service, or SES, which of course is AWS's cloud SMTP service. So the function also includes some error handling to rename the assigned policy if it exists, and it achieves this by calling the Django getRandomString function and appending the resulting string to administrator access. Now, since we know Legion is concerned primarily with SMTP abuse, it should come as no surprise that the tool's next steps are to set up and interact with the SES service. The function on the slide here demonstrates the approach taken by the tool to set up an SES client via the AWS SDK for Python, which is of course Boto 3. This function also performs additional configuration, like setting the default AWS region and defining credentials, both of which are required to establish the Boto3 client. So of course, given the malicious IAM user is operating under permissions granted by the Administrator Access Managed policy, there should be no barriers faced by the tool when attempting to access SES. And with this configuration in place, Legion's operator is now able to send emails and query account information, as we'll see on this next slide. So with the SES client established, Legion proceeds to query the send quota assigned to the compromised account. This is, of course, valuable information if your intention is to conduct spamming operations via SES. Legion's operator now knows how many outbound emails are permitted to be sent from this account and can use this for the benefit of their campaign. Information about the send quota can also be used to avoid detection in the environment by ensuring that the operator doesn't trigger any billing or quota alerts. So Legion also lists identities associated with the SES account, and typically this would be email addresses or domains used to send the emails. So after these basic discovery operations, Legion then proceeds to send a test email, which includes the result of the tool's automated discovery mechanisms in the body. Successful delivery of this email confirms to the operator that the AWS account has been compromised and that the malicious user has access to the SES service. So moving on now to discuss another notable feature of Legion. One thing that stood out to us during our analysis was the tool's ability to conduct SMS spamming via SMS over SMTP. To achieve this, the tool uses credentials exfiltrated via the methods described previously to access various automated communications platforms. Some of these tools provide SMS over SMTP support, and Legion can leverage this to deliver spam SMS messages. So the tool targets various US mobile carriers, including AT&T, T-Mobile, and so on. Some of the carriers are now defunct, suggesting that the code for this has been around for some time. So Legion uses an interesting method of generating alternative numbers to target via scraping area codes and carrier keys from the website randomphonenumbers.com. So we'll take a quick look at this on the next slide. To conduct the scraping, Legion uses simple Python scraping mechanism via the Beautiful Soup HTML parsing library. This allows the tool to retrieve carrier keys and area codes, to which a series of digits can be added to make a valid mobile number. Custom number generation code is used to create the rest of the mobile number, similar to how the alphanumeric strings were added to the AKIA prefix for secret access key IDs. Now, due to the significantly lower entropy associated with mobile numbers, this is much more likely to result in valid targets for the operator's campaign. Additional SMS hijacking functionality includes the ability to write out these numbers to a file for later use, and Legion can also ingest predetermined carrier keys and area codes. An example of the carrier selection and SMS body code can be seen on this slide. So I mentioned in the overview of the tool that Legion includes some traditional hack tool functionality. And this included things like bundling exploits for web technologies like PHP. So let's examine these features in a bit more detail. Another thing that caught our attention during analysis was the bundling of an exploit of the CVE 2017-9841 vulnerability in PHP itself. Now, since I'm not expecting anyone here to remember CVE numbers off the top of their heads, I'll explain this vulnerability in a bit more detail. The vulnerability enables unauthenticated remote code execution via an HTTP post request containing a PHP open tag substring. The post needs to be directed at publicly accessible resources within the /vendor folder, specifically the eval standardin.php file. This allows arbitrary PHP code to be executed on the server itself and could be used for all kinds of nasty stuff like starting a reverse shell and retrieving additional payloads. Now, as with many things in the world of malware, it's reasonable to assume that the code for this exploit was lovingly repurposed, most likely from public proof of concepts released at the time of the vulnerability's discovery. It's unclear whether the Legion developer has some information to suggest this vulnerability is still common in the wild, or if they've simply included it as they're already targeting servers running PHP. Regardless, an example of the exploit code can be seen on the slide here. Early in the function, you can see a hard-coded path to the eval standardin.php resource being assigned to a variable named path. Legion then defines a PHP info string before proceeding to build up the malicious payload. The Python request module is then used to deliver the string via an HTTP post request, and the tool checks the response to see if the exploit was successful. Legion then proceeds to report the status of the exploit back to the operator. So with the core functionality out of the way, let's look at some changes we noticed in recent updates to this family of hack tools. So an interesting technique that's gaining popularity with the malware campaigns we analyze at Kado is the reporting of campaign statistics via Discord. This provides an easy way for attackers to programmatically report key information about their malware campaigns back to a centralized location. Furthermore, traffic designed for Discord is unlikely to be blocked in many environments. So in Legion's case, later variants utilize this technique to track and store campaign statistics that were traditionally reported via standard out or written to files on disk. This particular variant creates a Discord embed and populates it with values like the number of vulnerable sites discovered, number of successful RCEs, and the total number of sites processed. And this is sent back via an HTTP post request so that it can be displayed in the operator's channel of choice. SSH exploitation was another feature that appeared in some capacity in the original Legion sample that we encountered. However, it appeared like the developers had yet to finish the code for it. In all samples seen by Kado, code to parse a list of exfiltrated database credentials to extract username and password pairs was present. The tool attempted this using the environment file parsing technique we've already examined and looking for values like db_password. If these are found, recent samples use these credentials pairs in combination with a matching host value to attempt to log into the host over SSH. Now, of course, this assumes that the database credentials previously retrieved by the tool are being reused for SSH, which would be very stupid. So this seems unlikely to me, but I suppose you might as well try. So it also adds another feature to the tool that might make it more marketable to potential customers. So that's us just about covered Legion now. So with that in mind, let's move on to our next malware campaign from an emerging cryptojacking group named DICOT. So DICOT are a group that we became acquainted with after discovering an interesting attack pattern on one of our honeypot sensors. They are malware as a service developers and are known for targeting Linux servers to conduct cryptojacking and other attacks. The group takes its name after the Romanian organized crime police unit, but they previously referred to themselves as Mexals. If you go ahead and search for Mexals, you'll find some research into prior campaigns conducted by this group, and we'll get an idea of their TTPs. So initial triage of the payloads retrieved from our honeypot allowed us to quickly attribute this campaign to DICOT, thanks to a number of excellent blogs by Bitdefender and Akamai. From there, investigation of their C2 server led to the discovery of a group of new payloads that hadn't yet been reported on. And this included a Mirai-based botnet agent, a self-propagating initial access tool, and a custom miner. Another interesting finding was the discovery of a video which included doxing of other online individuals that the group appeared to be feuding with. There was no discussion of DICOT's doxing abilities in previous research into this group's activities, so we thought that it would be useful to mention here. Several members of the rival group appear during the course of the video, and their personal details, including photographs, full names, home addresses, and online handles are exposed. It is suspected that the individuals in this video are members of a rival hacking group, but it wasn't clear what they'd done to anger DICOT in the first place. Text included in the video was written in the Romanian language, and the addresses were all located in Romania. And this fitted with our attribution, as that I believed that DICOT are a Romanian group. Now, DICOT's doxing capabilities are interesting, but it's malware in particular that we focus on, which leads me nicely to this graphic describing the execution flow of the campaign directed at our honeypot infrastructure. DICOT campaigns typically involve a long execution chain with multiple payloads and their outputs forming interdependent relationships. We've attempted to illustrate these relationships in this graphic, but I'll discuss them further detail in the coming slides. So as you can see from the graphic, the group uses a combination of ELFs written in Golang, which is a Linux attacker favorite, of course. They also use plain text shell scripts, regular compiled ELFs written in languages like C, and SHC ELFs, which are compiled shell scripts. Now, this can make analysis feel laborious, even in situations where the payloads themselves aren't particularly complex. It also demonstrates DICOT's awareness of the malware analysis process and their attempts to slow this down as much as possible. The group's campaigns contain some relatively distinctive TTPs. The first of these is the use of the UPX packer with a modified header. Typically, when packing an executable with UPX, a header is added which includes a magic byte sequence representing the letters U, P, and X, followed by an exclamation mark. This allows the executable to be unpacked with the UPX command line utility. A typical anti-unpacking measure is to modify this header so that it's no longer recognized as being packed by UPX by the utility. So this, of course, confuses the UPX CLI tool and prevents it from unpacking the binary. Now, fortunately, Akamai researcher Larry Cashdollar released an excellent tool named UPX Deck, which allows you to automatically locate and restore the modified bytes to the values that the UPX tool expects. With the binary repaired, you can then unpack it as normal. Now, this technique is certainly not unique to DICOT, but it gives an interesting insight into the group's capabilities. So moving on now to another obfuscation technique. I mentioned DICOT's use of SHC executables in the execution chain graphic a couple of slides previously. For those that don't know, SHC executables are essentially shell scripts compiled into an ELF. They are heavily utilized by DICOT for loaders, registering persistence, and preparing the target for mining via a custom fork of XMRig. It's likely that SHC is used for obfuscation purposes, as it prevents the compiled script from being read in plain text. However, the resulting binaries didn't contain additional obfuscation, so were trivial to analyze. So this brings us back to a technique you'll remember was utilized by later versions of Legion, the use of Discord for campaign reporting. DICOT also make use of Discord for reporting campaign stats, and we identified 4 distinct channels used as part of this campaign. In this slide's example, we can see some decompiler output from a function in one of the campaign's primary payloads, which we'll come back to in a later slide. The function contains a curl request with a hard-coded Discord webhook URL. Now, generally, this function would be invoked after some system discovery procedures, with the results being sent in the post body. Further analysis showed that the channels were generated, likely by an automated method, within an 11-minute time frame on the 26th of April 2023, which was shortly before we noticed the activity in our honeypot. So each of the webhooks found in this payload of the campaign were used to send information about compromised machines back to Discord. Now, moving on to analysis of the payloads themselves, we focused our efforts on the payload named Aliases, which is a custom SSH brute forcing tool used for initial access in this campaign. Aliases is a 64-bit ELF written in Golang and is responsible for ingesting a list of target IPs and credentials to conduct a brute force attack. Shortly after execution, the sample will perform a GET request to an attacker-run API, using a hard-coded API key. This hard-coded key appeared to be reused across DICOT samples and wasn't specific to a particular campaign. The API request returns with a Discord webhook URL, which seemed to be neglected in favor of the hard-coded hooks we mentioned earlier. Prior to the execution of Aliases, an executable named Chrome is launched. Now, Chrome isn't particularly interesting from an analysis perspective, but it plays an important role in the campaign. Dynamic analysis quickly revealed that it was an internet scanner, most likely a fork of the popular internet scanner ZMap. Now, since ZMap is open source, it's very easy for attackers to customize it to add obfuscation or additional functionality. So DICOT's fork seemed relatively close in functionality to the original, with the only notable change being the ability to write out scan results to a file in the working directory, which were then ingested by Aliases as a target list for brute forcing. So moving on now to look at some of the SHC executables utilized by DICOT. This first executable was a payload named Update, and it had a number of key responsibilities to ensure success of the campaign. Update acts as a loader, and its main purpose is to retrieve the Chrome payload we discussed in the previous slide. The sample also retrieves the alias's SSH brute forcer if it doesn't exist on the target. Now, payload, which confusingly is the actual name of this payload, is another SHC executable utilized by DICOT. Payload is mainly responsible for retrieving the XMRig miner and preparing the system for mining. The sample includes logic to only conduct miner-related operations if the target has more than 4 processor cores. Payload also determines whether it's running under root and changes the root's password if so, before sending a JSON file named send.json back, which included the password. So with the payloads out the way, I thought I'd include this recent finding that we made before we finish up. So during some unrelated darknet research, we encountered an onion link for a hidden service which was tagged with the DICOT name. Naturally, this caught our eye, and we decided to take a closer look. We discovered this rather amusing homepage that you can see in the screenshot to the left of the slide. The homepage claimed to be the home of DICOT hackers and included some hilarious testimonies, an example of which can be seen on the right. Now, rather interestingly, the developers of this site had linked out to some press coverage of our research into DICOT, of which they seem to be proud of. Now, we think that this hidden service was most likely operated by an impersonator involved in scamming individuals wishing to contract the real DICOT for assistance in resolving extramarital affairs. However, it was an interesting and rather humorous finding nonetheless. So I think we perhaps are running out of time, so I'm going to skip over this just to give us a bit of a recap. So we've covered 2 recent malware campaigns analyzed by myself and my colleagues at Kado, and I hope that you all enjoyed hearing the findings. Now, if anyone has any questions, then please feel free to request a mic, and I'll answer them just now, or give me a shout on Twitter after the conference. So I hope that you all enjoy the rest of your time in Vegas, and I hope to see you all again soon.
Thank you. Does anyone have any questions so we can pass the mic around and everyone can hear?
Everyone's ready to party?
Well, I have a question then.
Sure.
You mentioned cloud and Linux. You can't really speak about that without mentioning Kubernetes. Have there been any findings in that area?
So there has been quite a lot of third-party reporting of cloud attacks against Kubernetes. I can't actually think of one off the top of my head, but I know that it exists. It's not something that we've seen personally, but we have seen attacks against serverless environments. So we discovered Denonia last year, which was the first publicly reported malware targeting serverless environments specifically. But yeah, we're yet to stumble on something that's Kubernetes specific. Hopefully we do, though. That would be very cool.
Well, thank you, Mayor. And enjoy the rest of the conference, the last talk coming up. Thank you.
Thanks, everyone.
give me midnight. You whip up my appetite. Don't leave me here high and dry. Baby, you give me ice and fire. You're channeling wind and rain. You're some kind of butterfly. Baby, you give me midnight. You whip up my appetite.
everyone. Welcome to Breaking Ground. Today we have Doron and Ariel, who will be speaking about how they found PII and public RDS snapshots in their talk titled, Oops, I Leaked It Again. Before we get started, we want to thank some sponsors. Without them, the help of the sponsors, donors, volunteers, this would not be possible. They're located out in the vendor area, but just to list a few, we've got Conductor One, Toyota, Plextrack. Be sure to stop by their booths. Quick note on cell phones, please make sure that they are silent and not interrupting. And with that, I will hand it over to Doron and Ariel.
Can you hear me? Right? Cool. So thank you for coming. Let's survivors of this conference. Today we are going to talk about how we found PII in public RDS snapshot. And as we called it, oops, I leaked it again. So this was Brittany, and this is us. My name is Doron, and this is my colleague Ariel. We are both security cloud researchers at Mitiga. And today we are going to talk, as the name of the presentation suggested, about how we found PII in RDS snapshot. We are going to talk a little bit about what is RDS, what is this service, what is the concept of RDS snapshot, and specifically public snapshot. We are going to talk about what is the problem with having public snapshot over there, and also show you how attackers can exploit it. We're going to talk about what we did in our research, how we mimic an attacker technique and did it at scale, and also share with you some cool examples of real cases, of real DBs that we found out there with real information. And at the end, we are going to share some ways to detect and mitigate this risk. But before we start, we want to show you some of these cool cases that I was talking about. So these are some databases that we found out there, and they shouldn't be public. So for example, here we can see a table of one of those databases that includes username, user password, email, the gender, the phone number of the user, the marital status, a token of password, ID number, and more and more and more and more. Okay.
So let's start. What is RDS? Amazon Relational Database Service, as known as RDS, is a platform as a service that simplifies database management in the cloud. There are many great features. For example, easy database management. This service automates time-consuming administrative tasks, such as software patching, hardware provisioning, and more. All of these allowing companies to focus on application development. Another example is high availability. By replicating databases across multiple availability zones, this ensures that your applications deal with infrastructure failures without downtime. This service was launched in 2009, and 9 years later, in 2018, Stack Overflow published an article about the incredible growth of Amazon RDS. Actually, in these days, this service is widespread in the cloud. What is RDS Snapshot? So, Amazon RDS Snapshot is a point-in-time copy of an Amazon RDS database, and the snapshots are stored in Amazon S3 bucket. Snapshot can be taken automatically, like every hour, every day, and so on. Snapshot also can be taken manually by click. RDS Snapshot actually backups the entire DB instance. It's not like select queries on all the tables. RDS Snapshot also contains the metadata, and you can restore the DB using RDS Snapshot. And also, RDS Snapshot is a resource that you can share. You can share it inside your account, outside your account, and even publicly. Why to share Snapshot publicly? Maybe because you want to share public data, maybe because you want to share a template DB to an application, or maybe you just want to share a snapshot with someone without dealing with roles and policies. It's so hard sometimes. So, public RDS snapshot is a great feature. What can go wrong? As all of us already know, of course, databases can contain sensitive data. Sensitive data can be personal identifiable information, is known as PII. If threat actor gets their hands on this type of data, it can be a disaster to your organization. They can publish it, they can blackmail you using this data, and so on. Sensitive data also can be secrets. Secret can be password, token, access key, and so on. With this type of data, threat actor can exploit your environment. Based on this, public snapshot with sensitive data to public, even for just a few minutes, it's a really bad practice. Now, we understand it, but we don't feel it. Think about that. How easily you can imagine someone in your workplace who publishes a snapshot publicly for a few minutes. It might be said, what's the worst that can happen? And even may think it's not an issue they need to report. And even after that, even after you publish snapshots to public, if you want to investigate what exactly happened when the snapshot was public, there is a major lack of visibility in AWS CloudTrail that Doron will describe later in this presentation. To you.
So now we know what is RDS, what is RDS snapshot, but let's see how it can be exploited by attackers. Here you can see an illustration of an attacker looking for sensitive data. But really, adversaries can easily clone publicly RDS snapshot. The only thing they need to do is to use 2 API calls that leaves no forensic traces. You won't be able to see it in the logs, but they actually clone the snapshot. Also think about it that traditional scans, like scans for open ports or vulnerabilities, will allow the attacker to understand some information about your organization, but not actual access to the data. With public RDS snapshot, if, for example, you expose it by mistake, and the attacker was able to scan your premises and understand that there is public RDS snapshot at this time, they have actual data to the actual access to the data itself. Let's see a demonstration how easy it is to do so. The only thing you need to do is to use the describe DB snapshot API call to include the flag include public, and you will get an output of all the public RDS snapshot in the specific region. This is the information, all of the snapshots that are there. Now, the only thing that they would need to do is to copy one of the DB snapshot identifier as they wish. And this is a unique identifier for each DB snapshot, and to pass it as the input of the next API call, which is copy DB snapshot. Here you need to mention the target DB snapshot, free Brittany, and the region. And a few moments later, you will have a clone of this DB snapshot in your environment. Here you can see some information about the newly created DB snapshot in your environment. You can see the engine, which is MySQL. You can see the master username, which is root in this case, but sometimes it could be indicative of the organization that this snapshot is belong to. Another thing that is important to know, that it doesn't matter what the owner of the snapshot or the owner of the instance, the database itself, do with the resource now. For example, they delete it. It doesn't affect this snapshot. You now own the data. You have the data in your organization. So what we try to do, we try to mimic what an attacker does, but we try to do it at scale. Our hypothesis for this research was that attackers can scan the AWS premises and clone those snapshots that were exposed only for a few minutes. So that's what we did. We built an AWS native technique. We use AWS Lambda function, step function, and Boto tree for the automation of the API calls. And we created this bot that runs every hour and looks for the newly created RDS snapshot. The overall, the high level goal of this bot was to scan and clone those newly created snapshots and extract the data automatically. So let's focus on those processes. This is the overall process. On the left-hand side, you can see the process that runs every hour. It's an hourly scan, and it's responsible to scan and clone new snapshots. On the right side, you can see the process that runs every 6 hours, and this is like the offline process. And it's responsible to go through all the snapshots that we have copied to prepare them, to create the instance out of the snapshot and to extract the data for manual analysis later. Let's talk a little bit about the first one. So this is an hourly scan, as we said. We run an hourly scan for all the snapshots that were created in all the available regions, which is most of the region except of 4 regions. And for this, we use the describe DB snapshot API call. Then we iterate through all those regions, and we clone the newly created snapshot in the last hour, since the last run, to our premises, to our AWS account. At this stage, we also maintain a state file that includes all the snapshots that we have cloned, so we make sure we don't clone the same snapshot in the next run. For this, we use the copy DB snapshot API call. This is an example of the function that we use. This is actually the function that looks for the newly created DB snapshots. The second process, now at this point, we have the DB snapshot, the newly created DB snapshot in our AWS account. So we don't need to run this process every hour, for example. We run it as less frequent. We run it every 6 hours. And what we do in this process is, first of all, we make a list of all the newly created snapshots that we don't have databases for them. Then we, again, iterate through all the regions that are available. We get the unique ARN for each snapshot that we later pass to create the instance. In order to create the DB instance, we use the restore DB instance from DB snapshot. It's another API call. Once we have the DB instance ready to work with, we reset the master password, and otherwise we cannot access the data inside the DB itself. Then we move to deal with the data itself. This step is the analyze and extract. We automatically extract the DB schema, which are the table, some information about the tables themselves in the database. It includes, and also the DB content. We take this content and the information about the DB schema and we store it at S3. And of course, we later on delete and when we got the data itself, we delete the database to cut charges. Let's talk a little bit about what we do with the data itself. So we created an automated process that helps us to highlight tables that contains in high probability PII. What we do in this stage, as we said, we extract the table name, which could be indicative of what there is inside the table schema, which is the name of the columns of this table, that could be also indicative, and first 10,000 rows of each table. We save everything in S3 as CSV, and then we use PySpark in order to slice and dice the data. Before we move on and we select those candidates that we would like to manually analyze, we do another step to reduce the number of candidates. We filter for only the tables that are non-empty, which has at least some rows, and we search the column names of those tables against list of indicative keys. This is an example of what keys we were looking for. So these are PII-related keys. It includes password, phone, account, IP address, document, secret, and so on. Now we are going to show you some cool examples that we found in the wild.
Cool. Now let's talk about our findings. Before we start, I want to define our research timeframe. Our research was conducted over 30 days, from middle of September 22 to middle of October 22. From now, I'm going to call this time frame our research month. To begin, I want to share with you 3 nice examples about public RDS snapshots we found. The first example is a snapshot that was exposed all the research month. The DB was created in March 22. The snapshot was taken in August 22. And this DB looks like car agency DB. This table, for example, looks like car rental orders table. Each row is an order, and as you can see, each row contains full name, phone, email, car model, date, sales consultant name, and the occasion. For example, father birthday, marriage, festival, and so on. The second example is a snapshot that was exposed for less than 4 hours, just for a few minutes or hours. What's the worst that can happen? This DB looks like dating app DB. The DB was created in April 16. The snapshot was taken in October 22, more than 6 years later. This table, for example, looks like the user's table. Each row is a user that contains the name, password, email, gender, birthday, ethnicity, link to an image, user description, and more and more. Another table in this DB, for example, contains the private messages. Now, just take a few seconds to imagine what could happen if this snapshot got into the wrong hands. The third example I want to show you is an example with technical data. This snapshot was exposed all the research month. The DB was created in July 15, and the snapshot was taken in September 22, more than 7 years later. This DB looks like mobile phone apps company DB. This table, for example, is the devices table. Each row is a device that contains the device ID, that actually MAC address, user ID, that actually email, the device model, the app ID that was installed on this device, and the access token. With this data, threat actor can impersonate a user, of course. So now you can say, okay, you search in all of the regions for entire month, and you found 3 nice examples. It's pretty bad, but it's not a phenomenon. So let's talk about it. Let's talk about how prevalent is this issue. In our research month, we saw approximately 2,800 public RDS snapshots. In this graph, you can see how many public RDS snapshots we saw per region. The most common region, of course, is US East 1, because this is the default region. But also, you can see here that this phenomenon appears in all of the regions. In this graph, you can see how many public RDS snapshots we saw per DB engine. We saw Postgres, Oracle, SQL Server, and of course, the most common DB engine we saw is MySQL. And it's not surprising because of the popularity of this engine. But now we can say, maybe all of these public RDS snapshots are supposed to be public. So let's talk about that. In our research, we try to deal with this issue, and we try to think how we can clean the data. In order to do that, we applied 2 filters. The first filter was, we filtered out all the public RDS snapshots that were published by accounts that publish a lot of RDS snapshots. Think about that. If an account publishes a snapshot, for example, every week, it might be part of their product or part of their workflow, so it might be not interesting. In this filter, we actually filtered out approximately 2,000 of public RDS snapshots, a lot. The second filter we did is filter out all the public RDS snapshots with boring keyword in their name. Boring keyword can be test, template, public, and so on. In this filter, we actually filtered out just 70 public RDS snapshots, not much. Now, we had 650 public RDS snapshots, and these snapshots is our potential to contain sensitive data. From now, I'm going to call these snapshots interesting snapshots. Now I want to share with you some insights based on the metadata of these interesting snapshots. This graph shows how many interesting snapshots we saw every day. We can see a change, of course, but also we can see here that this phenomenon is a stable phenomenon. We didn't catch a unique peak or something like that. This graph shows how many snapshots were public for each number of exposed days, from 1 to 30. As you can see, public RDS snapshots that were exposed more than 2 days and less than 30 days are anomalies. In the right side, you can see approximately half of the interesting snapshots that were exposed all the research month. It means maybe they're supposed to be public, maybe someone published them and then forgot about them. In the left side of the graph, you can see the other half of the snapshots, of the interesting snapshots, that were exposed just for 1 or 2 days, just for a few hours. It means maybe someone published them by mistake, maybe someone just want to share them for a few hours with someone. In all of this graph, there is another case that the publisher of the snapshot is a threat actor. If this threat actor try to be discreet as possible, he published for a few hours, and if not, they published for a long time. This is my favorite graph. Every snapshot, of course, was taken from an RDS DB. In this graph, we can see how many DBs were created each month. Most of the DBs were created in September 22 or October 22. And it makes sense. This is our research month. But also, we can see that the number of the DBs that were created before that is more than a few. Why is it interesting? Let's think about that together. Let's take, for example, a DB that was created in 2015. If this DB was created 7 or 8 years ago, and this DB is still in use, that 7 years later, it's still relevant, and an admin took a snapshot from this DB and published it, the probability that this snapshot contains sensitive data is higher than a snapshot that's based on a DB that was created a few months before. Now, let's talk about our insights based on the content of the interesting snapshots. As Dawn described earlier, from the snapshots, we extracted the data to CSV files, and we stored it to S3 bucket. After we did that, we built, as Dawn described, we built a list of interesting keywords to search in column names. Here you can see a sample of that: secret, billing, IP, phone, token, and so on. What we actually did is to search these keywords in the column names just in non-empty tables, just in tables with data. Here you can see the matches to these keywords. Actually, we found a lot of matches. All in all, we found approximately 5,800 columns with an interesting keyword in their name and with data. When we reduced it to different RDS snapshots, we found 171 public RDS snapshots that in high probability contain sensitive data just in 1 month. Now, we can agree that this issue is a prevalent issue.
Thank you. So, as Ariel said, now we can agree that there is a risk there. Even though you don't know, you didn't know that this could be a risk, that publishing RDS snapshot even for 5 or 10 minutes could expose the data out there. Now we understand the risk. And you might ask yourself, what can you do as an organization to detect this issue or to mitigate this risk? So as I say, you might ask yourself, how can I know if someone, for example, copied my public snapshot? Sounds pretty straightforward, right? So you can't. During our research, we were surprised to understand that there are no logs about RDS snapshot if they are public. For example, if someone tried to touch your public snapshot, for example, copy it or create an instance out of it, you will not be able to detect it. There is no log records about it in CloudTrail. And this was even more surprising because we know other services in AWS, for example, in EC2. If you create an EBS, which is the disk you attach to an EC2, and you publish a snapshot of this EBS publicly, and someone, for example, copied this snapshot or create a disk out of it, you will get a log entry about it. You will know that someone from a third-party account is trying to do something with your EBS, and you will be able to know if this account is related to your organization or not, and if not, it's probably an attacker. But in this case, there are no log records, which means you are completely blind once you publish it, either mistakenly or not. But there are some things that you can still do in order to detect some actions around a snapshot that went public. So we divided it into 2 sections. The first one is current state, to understand if right now you have public snapshot. And the second one is historical check. Let's talk about the current state, what you can do. So first of all, you can use the AWS API. Like the attacker did, what you can do is to use 2 API calls. The first one is describe DB snapshot, and the second one is describe DB snapshot attributes. Here you can see an example. What you need to do is to describe all the DB snapshot in your organization of type manual, because you want to see only the ones that are not automatic snapshots, and to query for the DB snapshot identifier, which is a unique identifier for each snapshot. Later on, you take this list of DB snapshot identifier, you input it to the next call, which is describe DB snapshot attributes, and you will get all the attributes of all the DB snapshots in your environment. There you will be able to see if the DB snapshot is publicly available. Another thing that you can do is to use AWS config, and the AWS config is a tool provided by AWS, which gives you the current state of your visibility of your organization in any given moment. You can know what resources you have and what are the configuration of the resources. This tool comes with pre-built rules by AWS, but you can also build your own rules. One of those pre-built rules is RDS snapshot public prohibited. Once you have enabled this rule for your organization, you will see that if you have any non-compliant resources, like in this screenshot. Another thing that you can do is to use the AWS Trusted Advisor. This is another tool provided by AWS, and it overlaps some rules with the AWS config. What differs this tool from AWS config, among others, is that you cannot customize the rules. You have a certain set of rules that you choose either to use or not, but you cannot build your own rules. Under security, there is a rule that looks for RDS public snapshot. And this is information about this rule. Now let's talk about an historical check. So it's important to know if right now you have public RDS snapshot, but it's also important to know if you had in the past public RDS snapshot. So what you can do in this case is to look for the modified DB snapshot attribute event in your CloudTrail, and to see if in the time that you store those logs, any RDS snapshot went public. To do so, you need to search for this event, as I said. The attribute name would be restore, and under values to add, you will see all. In the AWS documentation, they specifically mention to not use the all statement under this store because it exposed your public RDS snapshot to everyone. And this is a mistake that actually it happens a lot, as we saw. What about mitigation? So this is for detection, to understand if you have or had snapshots that are public. What can you do in order to mitigate the risk? So first of all, which is quite straightforward, and it's true to other risks, not just this one, is to employ least privilege permission practice, which means give only the permissions that are needed to perform certain job. Either it's a role or a user, give it the permission that they need to do their job and not more. The second mitigation step is more specific to our case, to encrypt your snapshot with KMS key. If you encrypt your snapshot with KMS key, what we found is you won't be able to share this snapshot to the public. You will be able to share this snapshot with other AWS accounts, whether in your organization or outside of it, but not to the public. And this should help you to reduce the risk and to prevent mistakes. So to summarize, let's talk about what we had today. So we discussed about RDS, what is the concept of RDS and RDS snapshot. We emphasized the risk and the problem. Now we know that there is a risk that before that we didn't know. It's very important to understand that if you expose snapshot even for a few minutes, it's probable that someone took this snapshot and can use the information. We also know that there is a major visibility gap. AWS doesn't provide you any information about public RDS snapshot if anyone from third-party account ever copy or create an instance out of them. And also we showed you some cool examples. But you might ask yourself, what now? What you should do now? So we recommend you to do the following. The first thing, which is the easiest, by tomorrow you can check, do I have public snapshot? You can use any of the steps that we recommended. You can use the AWS config, the AWS Trusted Advisor, or use the API to understand if right now you have public snapshots. In 1 week, because this is a little bit more complicated, to check your logs. Check your CloudTrail logs. You can do it through the console or through anywhere else you have your logs, to check for this modified DB snapshot attribute event, and to search if you had a snapshot that went public. If the snapshot was public and you didn't know about it, that it includes information that shouldn't be out there, you should treat it as an incident because someone might touch it. And the last thing is to apply the mitigation step that we recommended you, and specifically to encrypt your snapshot. As we said, if you encrypt the snapshot, you prevent mistake. No one will be able to share it with the public. Thank you. This QR code leads to our blog, which includes more information, and of course we share a lot of details, so you can see everything, all the recommendations, the mitigation and detection methods. So it's a very useful resource for you. And thank you.
Thank you. Do we have any questions?
I'll get the fun question first. What was the most interesting thing that you all found within there in terms of the relationships and the naming conventions? What was like the most concerning, the more interesting thing you found while kind of scavenging through this data and everything
naming
else?
Convention of like a table or a DB, or?
Yeah, just in terms of the combination of the keys and all the data points, where you're like, oh, that's really concerning. Why is that there?
So I think the most interesting examples were the one that we showed you. For example, this dating app, it was like very interesting, and we actually we didn't share it, of course, but we found like the real conversation between users in this dating app, which is quite shocking. And of course, this shouldn't be public. So this was like one of the most amazing results. But we found other examples which are not PII, for example, production servers of really big retail company around the world, that we can see all their stocks, all their models, like a lot of information that shouldn't be exposed. Yeah.
So the lack of the copy database snapshot logs in CloudTrail is a feature according to AWS?
So we I'm not sure if I said it, but we did talk with the AWS, and they acknowledged that this is like a lack of visibility they should bridge at some point, but not yet. It was like last year, and there are no logs yet, but hopefully sometime soon.
Do we have?
Any of the companies? So I'm not. Did we try? No, we didn't.
The answer is no.
The answer is no. We thought about it, but we didn't. Anything else?
To copy the snapshots, did they need any sort of access, or like you need to be able to read it and write it, or you can copy without that?
To copy the snapshot, for like you mean by mistake if you are a user within an organization, to copy a snapshot it's already public?
Yes.
No permission. That's
So you don't need anything in that organization?
No, because it's public, and that's the whole thing, that people, they don't know that they even share it publicly, and from this moment onwards, this is for everyone's eyes. Everyone can see it. They just need to, the thing that is like the hardest is, as we said, we found like 3,000 new public RDS snapshot over this month, and what we try to do to build like a machine that helps us to find the one that are interesting. This was like the most, the hard part of this research. And for attacker, they need either to build something similar or to understand by the naming convention of the DB or the user, the master user, if this is a target that they would like to target. Anything else? Hope you enjoyed it.
Thank you.
Thank you.
kind of butterfly. Baby, you give me midnight. You whip up my appetite. Don't leave me here high and dry. Oh, but I don't wanna jinx it, baby. Let's not get ahead of my time. Oh, but I don't wanna miss you, baby. So I stand up and speak my mind. Oh. Baby, you give me ice and fire. You're chilling wind and rain. You're some kind of butterfly. Baby, you give me midnight. You whip up my appetite. Don't leave me here high and dry. Baby, you give me ice and fire. You're channeling wind and rain. You're some kind of butterfly. Baby, you give me midnight. You whip up my appetite. Don't leave me here high and dry. Oh, 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 oh,
maybe. Hey, everyone. Hi, how's everybody doing? Woo! I love that. Great. That was loud. I know, it's fair. So I just want to say welcome, everybody. Welcome to the close of our 2023 version of Security BSides Las Vegas. Got a few things we want to go ahead and get covered here. We have some contests to cover, some content we want to discuss, and a few other fun things to talk about. Thank you all for being here, and I'm going to go ahead and start off by handing off to Damon, who's going to, I know, shock and awe, where he's going to go ahead and give us a little information on the content that we were able to see this past couple of days. Monsieur.
Hey, everybody. Before I get started, is there anybody here who went to a talk at BSides? Unlike DEF CON, yes, there are talks at BSides, and like 90% of you actually got into one, so that's like a big point in our favor as far as I'm concerned. But actually, it's the whole point, like, that started this conference is getting people to be able to speak, getting those voices out, having those conversations, right? So it's really kind of satisfying to me to see, like, we had over 400 submissions this year in across 10 different tracks. And that is amazing, like, to me, to see the community that participates in that here, that people come here to speak. They come here to have a conversation rather than just kind of, I mean, and don't get me wrong, I love everything else, right? Contest games, all this, like, this is all incredibly important. They're all ways to get people engaged, get people involved, get people to, like, actually become actors rather than spectators, which to me is what BSides is all about, right? But anyhow, all that to say, had a couple of really great keynotes this year, to my mind. I really deeply enjoyed the sort of personal and emotional retrospective over the evolution that we've had here with I Am the Cavalry over the years, which is one of the things that makes BSides very special. That movement that started here, that's grown beyond us into, like, ways that we can't possibly, couldn't possibly have imagined at the time that it did start. But it was nice to see sort of a culmination of that. Like, we have actually affected the course of legislation at the federal level in the United States. This is something that 10 years ago, like, nobody thought that we could do, and we did it. Hackers did that, right? And then at the same time, we have a kind of a soft spot for trying to look at things in a cross-disciplinary and sort of esoteric way. We've had neuroscientists come and present keynotes. We've had behavioral economics, on our keynote stage. And this year, having Sunil come here and kind of talk about how AI is transforming the very nature of, like, what a CISO is, what a security department should care about, what, we as security professionals will contribute to society, and the way that we will transform corporations and the way that they conceive of their intellectual property and the way that we steward it, I thought was, for me, very interesting. But all of that is wonderful and exciting and new, and I love to see the forefront of the conversation happening here. But for me, in my deepest heart, the thing that I love the most in our talk program here, in our content program here at BSides, is proving ground, right? This is the thing that, again, we've done a lot of firsts here, right? We were the first people talking about gender issues, first people talking about mental health issues, first people, talking about all of these things. But we're also the first people that I know of, anyway, who had this formal mentorship program for bringing voices into the broader security community, putting them on a national stage, people who have never spoken at that level before, pairing folks with a mentor for 6 months to work on their idea and make the delivery of that something that is, like, as impressive as any talk that you'll see anywhere in the world, right? So I do want to make a special plea to folks, all of you, everybody watching on stream, everybody. bring more people into the Proving Ground program. I would love to be at the point where I cannot possibly, like I have to find another room to host Proving Ground in, where we're running out of mentors, right? And we see these people come and they learn, they talk, they give that Proving Ground talk, and then they come back and they give a talk of their own. And then 2 years later, they come back and they're mentoring someone in that program. And I love that about this. This is for me, it's one of the best things that we do here. And so please, every one of you, if you can go out, your homework for next year for BSides, right? And it doesn't, you got a couple months off, don't worry, you don't have to do it right away. But in January of next year, I want everybody in this room to find someone that they know is just an amazing person who has never had the chance to share with the world how amazing they are, and get them into this program, okay? And if you do that, my heart will probably pop, but
Don't let that happen.
That said, the other thing that I think is, for exactly the same reasons, just as amazing at BSides, is our Pros versus Joes CTF. The way that we do CTF is fundamentally different than anyone else, and it's one of the coolest things that we do. And I want my brother Dichotomy to come up here and talk about that.
All right, thank you. Good evening, BSides. It is a pleasure to be here, and I'm waiting for my staff to come up, as I told them to please do so. But I'm Dichotomy. I run the Pros vs. Joes CTF. Been doing it since 2013 here at LV. It is our pleasure to be here. We are honored to be part of this amazing conference. Pros vs. Joes, for those who don't know, is an offensive-defensive CTF that is all about teaching our Joes, teaching the people who are new to the community, who want to become part of cybersecurity, who want to be part of the industry, make a job here. Maybe it's a passion for them. And we are all about helping them learn through a bit of a crucible, where we give them some environments to protect. We bring a red team to play the part of the advanced persistent threat, to do all kinds of shenanigans and help them learn through that hard experience in a 2-day intensive affair that is, it's people have had amazing things to say about it, and we're flattered to do so. And it's key point I want to make is we have these people standing up here. I am just the figurehead. I don't do a whole lot these days. There are these people here, my staff, who deserve a round of applause. They do some amazing things to make this happen. We work on it through the year. It doesn't happen without them. We have Uplink, iDigital, Flame, Gabe the Engineer, Tectonic, I Found It This Way, Watchdog, Imposter, Prominent, Misfit, Mateer, Luftcroft, Hazar, ETH5, Nita Mulligan, Jeff, Mark, Spike Roche, Haxermad, Malware Mama, SLR, 3Bob, and Endgame, and Kaz. And that's just the people who helped us run this year's game. We have other staffers who are continuously helping and doing amazing things. And so we're here to do this for the community. We're here to help things move along. And we really appreciate all the support that we have, and we love doing this, and we love it. So Cindy, I think you have, I think you're next? Yeah. Okay. So Cindy.
We absolutely want to make sure to not miss the fact that Dichotomy is the one who's been running this for years now and has been just kicking butt and giving the opportunity for some of our participants to come in and kick butt. People who may not have come otherwise, so it's very exciting for everybody to be able to see that. So thank you, Dichotomy. I appreciate it. Awesome. Okay, so one of the cool things that we are able to do here, we are a 501c3. We are a charitable organization. And one of the things we like to do is have the opportunity to give back to some worthy charities. We've got some amazing charities that we give, or that we're working with on a every year basis. EFF is one of those, so I just want to say shout out to EFF because they are amazing, right? Oh, all right. I might be representing, I don't know. Another one of the charities that we selected to support this year is the Cognitive Security Institute. And I have a very long, I had to write this out because what they're doing is really exciting. It's really important. I didn't want to mess this up. So my understanding is that a big part of what they're doing is looking at the global view and how the world has been expanded. You know, we're having, everything's closer and closer together now, even though we're still the same size globe, we're still getting closer and closer together. They have a YouTube channel that is, the purpose of it is to share information and to facilitate understanding of the intersections between, I'm reading this now, technology and the human mind with an extreme focus on emerging security threats, which is really exciting, and as well as information processing and how that gets processed not only from a technology perspective, but using that, the human mind and how those things are intersecting across the board. And it's really interesting when you get to talk to anthropologists, sociologists, and you think about those kinds of aspects, something that I nerd out on a lot, actually. So I'm looking forward to watching some more YouTubes on it personally. So I just want to say a huge shout out to them, and we're more than happy to support them. One of the ways that we support them is through our silent auction, and our raffle. And I think a lot of folks were able to participate on that this year. Do we have some updates? Come on up. This is Xanadu. Xanadu runs our silent auction and raffle.
Hello, everyone. Well, I honestly thought we were only going to get 3 items because that's all I knew that was actually going to show up. But we had 33 more items donated for us to auction and raffle off. Wonderful. Woo! I know several of you in here have no clue on whether or not you've actually won. But I'm going to try to read off the names. Your handwriting, not the best. And again, none of you do. I don't either. Okay. Eddie Artwork, Godare, Goddare, Goddard? Not near? All right.
So let them know if these are claimed by the end of the closing. We're gonna auction them.
Yeah. So at the end of this, once we're done, we're going to raffle off anybody who is not here. So if you are here when I call your name, stand up now.
Anything not claimed by the end of the show is being
Yep.
auctioned, not raptioned.
Yeah. Anything not claimed is auctioned, not a silent auction, loud, not raffled. Pardon me about that. All right.
That was for the Eddie the Yeti.
Edit the Yeti artwork. We have the Darknet Badge Kit 23. Ashley S.
Ashley S.
Mm-hmm. Army Train for Bitcoin's collection.
I saw him earlier.
Army Train.
Okay.
Okay. Next one. Alice and Bob's Learning Application. Army Train.
Okay. Sounds like we're going to have our auction.
Men's XL. BSides Sao Paulo. Sao Paulo. Brazil.
We're
Yes.
very tired.
Is Dorgen, D-R-G-N.
Sure. Keep
going. Yes. Good. Okay.
Yeah,
Huh?
Ashley.
Ashley's here as well. Beautiful.
Sweet.
Okay.
All right.
Meet us after the thing.
Women's. Dorgen.
Sao Paulo.
Oh, you can sit down.
Donated from Car Hacking Village. Harbus.
You just want to come up and sit up here? Is it
Harbus.
Once, twice, no? Auction.
All right. POCGTFO. Acronyms are hard. Yay. Alaska.
Alaska.
Woo! All right, we have the U.S. drone donated by Ralph and Stephanie DeFrancesco. We have Scanpenter.
Scarpentici?
Scarpenter.
Scarpentici?
If you think you did win it, come see me too.
If you bid on it, come see it.
Yeah, you bid on it. Jeez. Words. I'm not used to being up here, so.
You're doing a great job.
Awesome. All right. Mystery bag, number 3, Aliska.
Again. Awesome.
Mystery bag number 1, Prism Q. Darknet badge, Demon Face. Marion? M-A-R-R-I-N?
Marin?
Penmanship.
Marin.
Marin.
Marin Leitner?
Leitner?
Okay.
All right, next. The BSides Las Vegas patch from Operation Yestern. Only 100. Amy. Looks like Amy?
Okay.
Circle City Con.
Oh, the 10.
Origin. Again.
Awesome.
He's here. This is Horizon Cybersecurity Summit Bronze Partnership, SEMGREP. Anybody from SEMGREP going to be here?
Nope, I don't see the
Nope.
shirts.
All right. Custom DEF CON 31 badge. DT.
Who's that?
Good question.
Oh, that DT.
That DT. All right, Luxky's Key. Army Train.
Still not here.
Still not here. All right, so these are all going to go back.
And we got that one.
One more?
Huh?
Oh.
You want to auction off a ThoughtCon t-shirt?
We could add it to the
Sure.
stock for sure. I mean,
I
that's
never
great.
turn anything away.
Do you want to do
Large.
It's me. Not really.
Size large, bozo.
We'll do
This
the
is how much
last
we've
at the
raised so
end.
far.
Okay, we'll do that at the end.
Yep. Okay.
Thank you.
So we don't know our total yet. Because
Nope.
we're,
Here.
We don't
Yeah.
know our total
we
yet.
don't know our
Okay.
total yet because we've got to auction some stuff off live.
Those are the ones that are going for auction. These are the ones that have been claimed.
Yep.
And they've been separated by names. Thank you very much. I know. I have to be organized with paperwork because, you know. Okay, so thank you, Xana. I appreciate it tremendously. And thank you guys who donated and who bid on the silent auction. It really does go to some amazing causes, so thank you very much. Oh, one thing we did not mention was a very specific item that was directly donated and all proceeds were going to the EFF.
Yeah.
And that was Jack's guitar. Ooh. So our loving, one of our loving founders, Jack Daniels, is constructing guitars now in his, in his retirement. That's how he's spending a lot of his time, or some of his time anywhere. And Tiffany, what was the, do we have a total? It ended up coming in at $1,500 that went straight to the EFF, so that's pretty cool. Awesome. So I'm going to talk a little bit about the people who are here, the people who we outreach to. Right now, one of the groups that we always want to go ahead and encourage to be here are folks from the local community as well as students. Students, it's kind of challenging sometimes. I mean, we've all been a student at one point in time. A lot of us ate a lot of ramen, you know. So we give the Utes, we give the, well, if they're from the University of Utah, they are Utes. Anyways, I recovered, see. We give the students that are coming out of the local colleges as well as the local community here the opportunity to purchase badges at a much reduced cost. And this year we sold out of both styles, so that's really cool. We did have some incredible numbers that registered as participants, donors, super donors, and that's something we want to, that's amazing as well. But the ones that really stick in my heart and that I really appreciate is being able to have those students come in. It can feed into Dichotomy's program. It can feed absolutely into, going into the Proving Ground setup, getting those mentors, making conversations, having conversations with everybody here, sitting at the tables over in Common Ground, having the opportunity to meet people who may influence their future, and that's just one of the best things in the world. So once again, echoing Damon's comments about the the proving grounds and everything else, and getting those new voices, being able to identify those new voices by letting those folks come in a little bit of an easier way, it's kind of something that's close to my heart. So, a couple other things just to bring up real quickly. Damon was very eloquent in describing the I Am the Cavalry track, and they've been here for 10 years now. This is their 10th year, so we are more than happy to have them here. We know that you all get a lot out of them, and they are letting us as a community do a lot of real good, solid work, and it's excellent to see. So I do want to give them one more props. We also have a pretty unique track in where it's the full track, and I'm not sure if we were one of the first ones to do something like Higher Ground, but we may have been. Yeah, I think so. So for those of you who didn't have the opportunity to participate in it and would like to in future years, because we really want you to come back, Higher Ground is a track where we do everything from career coaching to resume review. We'll do they'll have interviews there, and a lot of our sponsors participate just for that track alone to be able to start gathering candidates. It's a great opportunity to go ahead and build your own, help develop your own career path, or potentially influence those around you, and maybe pick up new hires along the way. So just keep that in mind. It's a great way to sponsor. So, yes. I would be absolutely remiss if I didn't say thank you all of our wonderful sponsors. Thank you, sponsors. Literally could not do this without you. I had the opportunity to walk around Common Ground yesterday and just thank the folks working the tables there. If they weren't the ones who signed on the dotted line, I asked for that message to please be passed up to the folks who did, because we could not be here without their assistance and their contributions to helping develop this community. So thank you so much, sponsors. Let's give them a huge round of applause. Kelly is standing in her thoughts, but she is. But now you have to stand, because something I need to do is introduce Kelly. Kelly is our amazing Chief Operations Officer. She herds the cats. She cracks the whip when necessary, and she does a fabulous job to bring you the content and the experience that you have here. So I'm going to hand over to Kelly really quick.
I am not the person who likes being out in front.
Great job for that.
Yeah, that's why I have a Damon. But it's very important to me to have the opportunity to come up here and talk about the staff and volunteers. BSides, yes, BSides doesn't happen without every piece coming together, the sponsors, the content, but as you have probably noticed as you've been walking around or sitting in tracks, this thing doesn't happen without the people who are in the orange, the blue, and the purple shirts. My staff works year-round. We plan, we talk, we try to have game nights. We end up coming up with new ideas about how to improve the conference. All of these volunteers in orange and blue are working their butts off, missing out on all of the stuff that everybody else gets to see in order to make it run, in order to make sure that our speakers are treated well, in order to make sure that we're able to get our video out to the internet so that everybody possible is able to be exposed to the interesting things that we're talking about. We are a team, we are a family, and this is not possible without them. You don't even see all of them here because they're still working, they're breaking down, they're putting things away and getting ready for next year. So you'll see a lot of us tonight at the pool party when we finally get to blow off some steam. Please, first of all, give them a round of applause here. And when you see them this evening, or when you see them walking around at DEF CON or at your local regional BSides events and other things, please do give them a big thank you. And from me personally, I thank you deeply. I love you. It's really a privilege for me to get to work with you all and do this thing. This community is very important to me, and the work that we do is very important. Thank you all.
We love you, Kelly.
So one last thing that I want to say before we get to have the joy of we go ahead and kick off the auction here. Are you going to go ahead and help us with that? Awesome. Zaz has got it under control. I'm so excited about that. I want to thank you all, the participants, the donors. My goal with joining BSides as a volunteer a long time ago was to be able to give something back to the community, because I had been taking for a while. I've been listening to talks, here, there, and the other, but I hadn't really contributed. So going ahead and starting the volunteer path that I did gave me the opportunity to ensure that I was giving back, but also so that people could participate in these conversations. We could get the new ideas. We could see the new things. And by you all participating, by having those those conversations over in Common Ground, in the hallways, at various tables throughout the Tuscany space, just watching everybody communicate, I've just got to say, I'm so excited to see that type of growth and seeing how it's impacting different areas of our industry. And I want to thank you all for coming here and taken the time to spend your time doing it here at BSides LV. I love y'all. Thank you so much. Yeah, I think that about wraps it up. I mean, come back, contribute to the CFP. I mean, submit to the CFP next year. Check into Joe's Voces Pros. I just realized I didn't introduce who I was at the beginning of this. My name is Cindy Jones. You can reach me at cindy@bsideslv.org. If you would like to you want to send any comments in. What do you do? Oh, I'm sorry, I'm the president of the board of directors. I'm a volunteer. So, thank you. So, feel free, if you have any questions, anybody, staff, volunteers, especially the folks who are participating in our events, please feel free to let me know if you have any questions or concerns, or if you have some neat ideas. And who knows, maybe you'll end up wearing a purple shirt. Okay, thank you. Zaz, you're up.
All right, so we're going to knock out this auction pretty quickly, but just before we do, I'm going to ask you to indulge me for just a minute. We had a teenage volunteer on the on the AV desk, and the progeny of one of our staff members. And on the first day, the said staff member came and he said, I asked him who he was hanging out with, and he said, he wears glasses and he talks funny and he's old like you. And so in my role as loudmouthed old person, I had to explain to him what a B-side is. And I said, back in the mists of time, recorded music came on a physical platter, and there'd be like an album track on one side, and on the other side was some music that the band thought people needed to hear. It didn't make the album, but people needed to hear it. And B-sides is the same kind of thing. B-sides, the conference, is a rejection of gatekeeping, and it's a rejection of artificial scarcity. It's about sharing what we know, right? And so anyone here who, over the last couple of days, if you shared anything, any knowledge with anyone, if you educated anyone, thank you. Give yourselves a round of applause. All right, we're going to try to make this as quick and painless as possible. For each one, I'm just going to quickly once again see if the person who bid on it is here. If you bid on the Eddie the Yeti extremely online artwork and your name looks anything like Godair, speak now or forever hold your peace. Where are we going to start the bidding here? Are we going to start on the second to last or the last?
The last.
Okay, so the opening bid here is $250. Do we have that artwork to show people? Or
she's got it right there.
Okay, right here. Original Eddie the Yeti artwork. Do we have $250? What do we do if we have no bids? What's the plan here?
Who's the second bidder?
Okay, the second bidder is Dave Johannes or something like that.
I know. I agree. No? Okay. So we're at, start at 200.
Yeah. Do I hear $200 for this original piece of Eddie artwork?
It's not a copy. It's not a copy. It's not a print. It's hand-drawn.
Yeah. How about this? Do we have an opening bid for this piece of original artwork? Who's $50 in the back there? All right, $50. $60 here in the front. $60. $70. $70 in the black shirt. Do I hear 80? Do I hear 80? 80 there. $100 here in the front. $100. Any advances on $100? $100 going once, going twice. What are you bidding? 120? 120. 120. Any advances on 120? 125 here in the front. 125. Going. That's a cube. Anyone going to go 6 cubed? That's 5 cubed. Do I hear 6 cubed? Maybe not. All right, $125. Going once. Going twice. Sold to one dock one in the front. I like this model. I think we should just have opening bids. This is donated by Lolski. What is it? Oh, Deep Bass X wireless headphones.
And then some.
Original starting bid $25. What am I bid on these wireless headphones? $60 here in the front. $65 in the back. $110 here in the front. All right, that's what we like to hear. This is all to support BSides. 120, 125. 125 here in the front. Any advances on 125?
You got Google.
125 going once, going twice. Sold here in the front. Front row is taking control here of this auction.
Come put your name on it.
What's next? Okay, this is a bronze partnership package for the Horizon Cybersecurity Summit, October 2 to 4, 2023 in Turtle Bay Resort, Hawaii. Sounds pretty nice. Do I hear a starting bid? Original starting bid was $75. $100. $100 over here on the right. Any advances on $100? The Horizon Cybersecurity Summit, Turtle Bay, Hawaii. Sounds pretty fun. $100. Going once, going twice, sold. Okay, a darknet badge kit with the demon face. So it's a DIY solder kit. It's part of the darknet competition at DEF CON. There is no starting bid here, so one of my bid, we can't see it, but the darknet is one of the, $40. $40. 50? Yeah, it's 60. It's this year's darknet badge, $80. $100 to the Australian in the front. He'll set a drop bear on you. What was it? 150. 150 all the way in the back. 160 over here on the right. Any advances on 160? I'm hearing 160, 170, 180, 190. Bidding's coming thick and fast, folks. 190. And do I hear 200? An even 200 here in the front. Even 200 for this darknet badge. 200? No, we have 200. We have 200.
I like the hacking.
220? 250? 250 in the back on the left. $250 for this darknet badge DIY kit for this year's DEF CON darknet. 250 going once. 255. Ooh. We might need some bigger increments, but 255. 275. 275 there in the back. 275. 280. 280. Do we have an even 300? Can anyone give me an even 300 for this darknet badge? Three is a dark number.
For the EFF, people.
Yes. This is for the EFF. Do I hear 300? 280 in the back here. Going once. 290 in the front. 290. The man in the plaid shirt. 300 in the back. And even 300. Any advances on 300? Going once. Going twice. Sold. 300 to the back. Thank you very much. Okay, this is this year's Car Hacking Village badge. Probably has all kinds of car hacking functionality. What do I hear opening the bidding for this year's Car Hacking Village badge? 100 in the front. Good round number. 190? Do I hear in the back the man with the towel? 190. Do I hear 200? 250. 250 here in the gray shirt. Any advances on 250? What? 300. This is a man who knows where his towel is. 300. He's a hoopy frood who knows where his towel is. Any advances on 300? 300 for the Car Hacking Village badge. It is really cool. 310. I had a look at it when I was over there. It's got silver, red and white silk screen, black board. Very nice looking badge. Any advances on 310? Going once, going twice, sold for 310. This is an autographed copy of Alice and Bob Learn Application Security, signed by Semgrap, or I guess signed by the author and donated by Semgrap, maybe. Any opening bid on this signed book? 20 bucks here in the front. 60? I hear 60, the man in the red cap. Any advances on 60? Once again, we're supporting the EFF here. This is ultimately supporting all of our digital rights online. Any advances on $60 for this autographed book? Going once? Going twice? Sold for $60. Thank you very much. It was in the gray shirt all the way on the right.
That
With
guy
his hand up?
up there.
Okay, okay.
Oh.
Featuring Malort.
Thank you. Oh,
But will you
very
pay for
nice.
his rehabilitation?
So here we have a collection of physical cryptocurrency coins donated by Spam. 6 different cryptocurrency coins in physical metal form. They do not have any private keys. There's no real cryptocurrency here, but they're good-looking coins. That's right. These are the original non-fungible token. What am I going to be bid for this 6-coin? $10 here. No. Whole amounts only. $20 here in the front. 30. Any advance on 30? 35? 40? I hear 60. 60, that's $10 a coin. 70? None of these coins were created by Sam Bankman-Fried, all right? These are valuable coins. I hear $70. Any advance on 70? $80. 90.
I'm Satoshi. I'll sign it for you.
Satoshi in the front, but I heard 100 from someone behind. Well, no, I had 100 over here. So any advances on 100? Would give me 120. All right, 120. $20 a coin. 120. 140. 130. $130. Any advances on 130? 140. Oh, come on. You can do 150. Give me 150. 150 for these coins. 160. A bidding war. This is going to be the future. These things are going to be the future of money. Having this as a display on your mantelpiece will never get old. What are we at? I forgot. 160, right? 160? 160. Going once? Going twice? Sold. Thank you, sir. 160. All right. Are we?
Who was it? Sorry.
The man in the dark gray shirt.
Oh, our friend.
Wait. So this is a giant pile. This is a giant pile of stuff. Toys. We got some kind of a drone. We got a stuffed Star Wars thing. A VR smartphone headset. So it's part of US Drone Con. So what am I bid on this collection of things that you'll definitely make a friend with some teenager with this stuff. $50 in the front. Any advances on $50? 60? I hear $100. I hear $100. Any advances on 100? $100. 110. 110 from the gentleman in the black mask. $110. Going once? Going twice? 120. 120 from the extremely generous man who's purchased at least one thing here before, supporting the EFF. Thank you very much. $120. Any advances on 120? Going once? Twice? Sold for 120, and thank you for your generosity. Is this the last one? Okay. All right. This is an interstitial one, just donated minutes ago by a person who is bidding also here and has also brought up a drink. So a very generous person in the front row, a ThoughtCon, like a Stormtrooper clown T-shirt, size large. $40. Buying back his own donation. Come on, folks. Like, you got to respect that. Don't make this person buy back his own donation. $50 for the shirt. $50. Any advances on 50? Once? Twice? Sold $50. Thank you. Thank you for saving this generous man from having to buy his own donation back. Much appreciated. What do we have left?
We have this. Donated by our own One Dark One.
Donated by One Dark One. A sticker and badge collection. Safety third. What am I bid for this? $50 in the front. Sir, if I had a hat, it would be off to you. $50 for this sticker collection. 60 in the back. What am I advanced on 60? 80 in the back. What a fabulous crowd. I have tears in my eyes right now. $80 for these stickers. I'm sure also you could get One Dark One to sign them or something too. Oh, wow, there's all kinds of stuff in here. Glow-in-the-dark PVC patches, and who knows what else is in here. Any advance on $80? Will anyone give me an even 100 for this?
Will anyone give the EFF an even 100?
That's right. $100 in the back. Thank you. $100. Going once, twice, sold. Very generous, all of you. Thank you. Is that the last one? That's it. Folks, thank you very much. Fantastic. We'll hopefully have a total for you soon about what we've been able to contribute to the EFF. At the pool party, we'll announce it. Thank you, and thanks for coming to BSides Las Vegas.
If you just won, please bring your cash up to the front here. And for everyone here, whether you won or not, remember, you are changing the world with every conversation you have here and with every bit of participation you provide.
Oh, this Pan-Galactic Goggle Blaster is good.
Thank you.
It's like being hit in the head with a gold brick with a lemon slicer after having it.
Yes, that's what I was going for. It's not my first iteration of it, but it's the first one.
and a